Hey everybody, we are ready to go right here. How's everyone doing? Right at 8 a.m. right now. We have everything fixed up. R is working better. Did some system utilities on the computer. Maybe I'll talk. I think it was Dennis or Alex was I don't know. I looked in the Discord for you guys afterwards. So, and can everyone hear and see me? We got the green screen working. We got everything working. Just give it a weekend, get everything fixed up. Can everyone hear and see me? I'm always got that a little bit of afraid. Looks like my mic's a little bit low though. I'm going to bring the mic up just a little bit higher here. How are we doing on volume? How are we doing on everything? How are we doing? Good volume, good everything? Awesome. Feel free to tell me a little quiet, a little loud, but I always look at the levels and see how we're doing. Awesome. So check it out. So great job on the take home. Great job on the test. Definitely, both of them were a little tricky. Now, please, if you feel like your grade's low, please email me. I've got a thing I created right here, so I'll send out announcements about this. But I went through, and because of the way the randomness was done, I had to do all these different things. I spent all of yesterday grading. So very, very sorry to a few people who got an email saying I didn't have your results. I had them. I had just things got a little disorganized, and I found them about 20 minutes after emailing about 4 or 5 people, and they were like, "Wait a minute, Brian, I did it," and I was like, "Yes, you did. Sorry about that." So if you got that email saying, "Hey, I didn't get your results," just a few of them emailed me back and were like, "Wait, you did get my results," and then I emailed them specifically and said, "I do have your results," so they know about that. They're fine, and thank you for understanding that. My mind, hey everybody, my mind was just a little bit. I think I graded from like 8 a.m. to when you started seeing grades posted. So it was a long day of grading, getting everything, making sure it was all right, making sure the grade book was accurate. Just, I want to make sure everyone sees their grades and knows where they're at. Because there was a lot of changing to grades due to midterms and everything. So when you, cool, go. So just making sure. When you send me, like, Brian, I want to see my results, I made a function right here where I can just put in a student's ID number. Now, let's make sure it works. Only one, well, no, don't do it because you have to put your student ID. Don't do this. Don't do it. It's a public video. Don't do it. But what you would do is you would send me, you would put your student ID, or I'll put your student ID in here, and it'll give me your results, and then it'll say your answers. So please email me. Don't put your student ID in the chat. Don't do that. If you do it, delete it immediately. But please email me and say, "Hey, Brian, I'd like to see my results. I'd like to see what I got wrong," and I will send you your results, and it'll show you the code. So I'll send out a reminder about that today, so you can see what you got wrong on the take home. For 474, I did a little bit differently for theirs. I kind of put the points off, but 474 was a much longer grading process. The issue with 320 was a randomness issue, that the randomness was being generated 2 separate ways, so I had to create 2 separate keys, and then I just figured out which one you did better on, because that's the one you did better on, and because that was the one graded with the correct randomness, and so everything was good there. But then I decided, I was like, okay, it was like 10 p.m. at night, and I was like, you know what? I'm gonna look at all the grades. It was called 320, but then I got done with 320, and there's more 320 students. I was like, you know what? Let's just throw 474 in there also. So this file should be called 32474. So if you notice here, I've got time and class. Now here's what I want you to look at. And here's what I said we'd be talking about at the start. So I'll just tell you which line of code does. This line of code right here reads in the file. This line takes, was there a curve? Because the high score, yes, there was a curve. There was a 1-point curve. So I curved it by 1 question. And so the highest possible score was a 33 out of 30. So good job if you got that. But I definitely allowed the highest possible grade to be, someone got 110. Yeah, I think there was only 1 person. So someone got, or maybe there's 2. But, and the average, I think the average is even higher now, because the people, interestingly enough, yeah, they did really well. And I was like, yes. But please email me if you think it's wrong. It's just easy to make mistakes. But email me, say, "Hey, Brian, I'd love to see my grades," and I'll send you that sheet there that shows you what you got wrong, and it'll show you the right code to do it. And I could maybe talk about anything you want related to it. And so the biggest thing is remember, the final is coming up. The final of a take home. If you did well on this take home, you'll probably do well on the take home final. If you did well on this respondus midterm, you'll probably do well on the next one. It's not saying you will, but there's a high association with doing well on, like, take-home test, doing well on take-home test, doing well on respondus test, doing well on respondus test. Let me ask this. This is something I always like to ask. Let's talk about the respondus test first. Who feels like they did really well on the respondus test, and what was their strategy? Like, I know it's next week. Yeah, so great. Who feels like they did well on the respondus test, and what's their strategy? And while we're saying that, let me show you the averages in the class, and I'll show you something right here. If you look at the model, everything worked, right? I saw a red line. I don't like red lines. I don't know why there was a red line. So if you look at this model right here, this is the model showing us when you watch the videos, here's the relationship we see. Rewatch the videos. That's awesome right there. And thank you, Nicholas, right there. 20 points, Nicholas. It's Mega Mondays. We don't have it on the screen, though. We got sports. So one thing I want you to notice right here, and this goes into multiple regression. With multiple regression, the biggest thing we need to think about is this. What does this coefficient right here mean? What does this coefficient mean? 1,000 points first person to interpret it accurately. I mean it. This is something you have to know. It's a review from last week. Who knows how to interpret that coefficient? These are students in a class. I know I throw crazy points out sometimes, but I really want someone to make sure they know how to interpret this. Because it means something. And this is, I put it in the chat at the start. This is watch time in hours and your grade in the class. But be careful. This review is from last week. This is a review from last week to interpret this coefficient right here. Who's got it? Be very, very careful. There's a very specific interpretation we want. What was the change in multiple regression? We're all of a sudden reviewing right now. We're talking about the test, but we're also reviewing material from last week. So we're already doing material. What is the change when we do multiple regression? Remember how we talked about weight? We had two individuals who are otherwise identical. So what are these? These are students in a class. So listen to the key things here as I'm kind of giving it away. These are two students in a class who are otherwise identical. Well, so what does it mean? What does it mean? What's the full interpretation? Like when we say interpret a coefficient, we need to, which I usually do this as a written part, and this is where people usually lose a ton of points. So I always stress this, but it'll be multiple choice. So maybe it'll be easier this time, but this is where I see people lose tons of points on the test. Two otherwise identical to a different new time by one respect to. I'll take that right there, Alex. I'll take that right there, Alex. Alex, I'll take it. Yep. So, and then I think Mila, let me read. Between two students who differ by 1 hour in time and are otherwise identical, expected to differ by in their grade hours where the individual. Wow. Both Alex and Mila right there. Yeah, and then Sylvia, all three of you right there. Those three right there. And be careful. So I'm giving it to those three, and I'll explain why. Let me explain why those three. Because all three of those I would accept on a written test. And there's a few key things right here. The word will is one that we never want to do. And I'd like to put this as a trick question on the test. I'm throwing Grant and Brennan 100 points right there. But never use the word will because it makes it sound like a law. Does everyone hear that? These are key tricks Brian can put on the final. So Alex is really good at putting up these possible test questions, which I'm going to be taking a lot from that off of the Discord. So hop on the Discord and look at Alex's possible test questions because he's helping me build the test with that right there. So when I'm looking at what's going to be on the test, those possible test questions are really great things that could go on there. So the word will is a trick because it's not that this will happens. What to use instead? I like Mila's the best. Between two students who differ by 1 hour in watch time and are otherwise identical, and they are expected to differ by, and expected is the key word right there. We expect them to differ by this, or maybe predict them or estimate. So the word will is like this will happen, but estimate, predict, they are expected to, I'm using the same words, to differ by this in their grade average, where the individual who has watched longer is expected to have a higher grade. Yeah, and the expected first, I'd be totally fine. Those are top answers right there, and also other people are giving top answers. I think Alex also, two otherwise identical individuals who differ in time by 1 unit are expected to differ in grade by this. Yep, exactly. And then time was in units of hours, which I'm usually pretty nice around those things. But those were great answers right there. And Sylvia also said two students who are otherwise identical in different watch time by 1 unit are expected to differ by 0.33 in their grade. There you go. The word will is a trick on the file. Yeah, huge note. Philip, 100 points right there. Make sure you know those types of things, that if I put that this will happen, or if I do like a stat to 1 interpretation where I say something like, for each additional hour you watch, your grade will increase by this, that is like complete trick. No, it's two otherwise identical individuals who differ in their watch time by 1 hour are expected to differ in their grade by 1/3 of a point. How about, what does this mean? And I love this coefficient. Because what does this mean? We would expect the difference between people who differ in their watch time by 3 hours. People who differ in their watch time by 3 hours would be expected to differ, who are otherwise identical, multiple regression. Individuals who differ in their watch time by 3 hours, who are otherwise identical, are expected to differ in their grade in the class by what? Expected to differ in their grade in the class by what? Yep. Basically 1 point right there. And this is a real model. This is real data. This is, my gosh. This is you guys. This is the class. This is real data. And we're doing an indicator variable. More on that this week. But you can see literally the differences as you have people who watch longer. Now there's people with residuals, like you generally want to be someone up here with a very positive residual. You're way above your predicted. But there's a relationship that the longer you're watching, the more, the higher your grade. There's people with negative residuals though, like this individual, sorry if that's you, has been watching longer and their grade is lower than we would predict. So you can see, they have a negative residual. They're below their line. So you don't want to have a negative residual. You'd like to have a positive residual. But there's probably other variation. So both, this was predicting the average in your class, the current average. This was the midterm score. You can see once again, with the midterm score, once again, your time watching, whoa, look at the coefficient on this. This is your score on the midterm. Two individuals who differ in their watch time. The first one was overall average in the class. This is now midterm, which this has an even bigger coefficient. Two individuals, and I'll show you the model because that's pretty small. Here's the model for the midterm one. So two individuals who differ in their watch time in the class by 1 hour are expected to differ in their midterm scores by 0.5 point. So basically every class you watch is almost like, is over 0.5 point on your midterm test. So watching a whole week is 2.5 points. And I mean, you'd hope it'd have a higher coefficient, but I'm glad that it's statistically significant. I'm glad that it's obviously positive. And there was a difference between classes where we would expect the 474s to have higher grades. The 474s were higher on their respondents midterm, which I definitely noticed. So there was a statistically significant difference between class. Their take-home was harder, which I probably told you guys. Their take-home was a good bit harder. I put some 320 questions on 474. I'm going to do some item analysis, but they had like beginner coding questions too. But they're in 474, so when they do beginner coding, it's a little bit easier for them because they're like, oh wait, this is our second time through it, and but don't worry, that's why I really like when you get to 474, you'll be like, I got this. I can do the beginner coding stuff. We want to make sure you have a really, really, really strong foundation, but their take-home was a good bit tougher. Some of them told me they spent 20 hours on their take-home, and I was like, oh no, I'm not trying to ruin people's lives. I spent a lot of time fixing it and grading it this weekend, so I understand. It's a lot of time. So, and I really appreciate all the hard work people are putting in. I know this is a tough class. How's everyone doing this morning? That kind of is a good review of interpreting coefficients right here. We won't do the indicator variable right now, but, well, it'd be two individuals who are otherwise identical, where one person was in 320 and the other person was in 474, are expected to differ by 7.3 points, where the person who's in 474 is expected to have a higher grade. And just look at this. Does that make sense? That if you have two people who watched for 5 hours, good, Emily, I'm glad to hear that. There's one assignment 8, and I'll have that posted up here. There's one assignment 8, and it just counts twice because it's very important to have your multiple regression. The first assignment, yep, it's worth 2 grades. Because if you don't do the assignment 8, I think you're lost. I've found that every semester, that if you don't do it, if you're like, I'm just going to not do this, the whole rest of the semester, you're just way behind. So please, 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 please do it. I just put it twice in the grade book. And does everyone see right here, if we have 2, but the second one is the one that's titled 2 grades. Oh, it's just a placeholder spot. All I do is just double it. So the assignment 8, I just double it. Does that make sense, Nicole? So there's no assignment for it. It's just I just double it. Yep. Nicole, 100 points right there. Thank you for clarifying that right there. I don't want anyone to be confused. Please ask any question you have. And look right here. Do you see how these two people, let me do this. Let me do this. 2 lowest grades dropped. Yep. And I hate, some people lose their 2 lowest grades on that one alone. In the grader, I will say this. The grader's been pretty nice, which I like. I think she's been doing a great job. I don't want them to be too mean. I don't want them to be too nice. I think they've been a good amount of nice. I think they've been a good, and I like that. I like the, like, not too mean, not too nice, like maybe going a little towards nice. Does everyone see these two people right here who I'm highlighting? Does everyone see these two people? We got person 1 and person 2. Person 1, person 2. Person 2 is in what class? Person 2 is in what class? Person 2 is in what class? What class is person 2 in? 100 points first person. Which one is worth 2? It's Simon 8. Simon 8. 320. Emily right there, 100 points. Yes, they're in 320. Now, person 1 is in 474. What is this difference between the two people? If you were to trace this over here, like you trace this over, what is this difference right here between these two people? If you notice, these lines are parallel. That difference is kind of the same no matter what. Can anyone tell me down to a tenth of a decimal what that difference is? Can anyone tell me down to a tenth of a decimal what that difference is? First person, tell me. Can anyone tell me down to a tenth of a decimal? 100 points, first person who tells me. Yes, Ryan, you're right. 100 points, Ryan. Yep, it's 7 point. Oh, wait, there you go. Ryan got it first. Good, Ryan got it. 7.4. That is the difference. Does everyone see it? It's right over here. And that's the difference right here between these points at all times. And these people have the same amount of time. Do you see that? Like, if you look at these two people here, they have the same time. So when you think about the interpretation of this coefficient, two people who are otherwise identical, like they have the same time in the class, but one person's in 320 and the other person's in 474. Do you have 474 as the red line? The person who's in 474 is expected to score 7.36 points higher. Who thinks that kind of makes sense right here? It's like, okay, they have the same time, but a 474 student is expected to score this much higher, just like that's their difference. Like if I had two people at the same time, one's in 320, one's in 474, well, I'd expect the 474 person to be this much higher than them. And just let's take a look at the graphic. They'd be, whoop, that much higher than them right there. It's just, that's the difference I expect. Who's like that? Oh, that makes perfect sense. I see it there visually. And if we have a 320, and we go to a 474, that's the difference. On the same, this is their grade on the, what did I predict? The midterm. Yep, on the midterm. And if you're seeing this right now, you just did another topic that we haven't even done yet. Hopefully, I want you to have confidence that the topics we are doing will literally be very similar for the next 3 or 4 days. Now, if you're behind, that's where you got to review. But if you feel like you've been staying on top of it, if you're doing the interpretations, if you're like, okay, I understand how to interpret a multiple regression, then when we do indicator variables, which will come up, I believe, tomorrow, you'll be like, I got this. So please, please, please be here. If I can't stress anything more than enough, it's that these coefficients right here are statistically significant. The amount of time you spend watching and practicing, there's probably other things like, are you active in the video? Are you taking notes while watching? I don't have data on that. Like I don't have data on how active you are. I don't have data on the notes you are taking, but I do have data on how long people are watching. So I can track the amount of hours. But there are people doing well who aren't watching very long. Like if you look, let's go to the previous graphic, you can see people with lower watch times with high, like they're off the top of the graphic right here, but they've got lower-ish watch time and very high grades, like very high averages in the class. So there are people breaking the trend. There's a person over here. I got to vanish. My buttons work. This person over here has watched 30 hours, but they have a lower B or about a mid B, and they're in 474. So this person doesn't have the highest grade in the class, but they have some of the highest watch time. So, but this person here has a higher watch time, but they're very above. They have a very high residual. But this does explain 16% of the variation. 16% of the variation in your midterm grade is explained by what class you're in and also how long you watch. We could just do, if you wanted, you could just do midterm grade explained by just how long you watch. So if you notice, I'm just removing the class from that, and we'll just remake, and it's 10% of the variation, which it has even a higher coefficient, even more statistically significant coefficient over here. So 10%. You could fact, I know I was gonna do MuBucks and I got like tired. How good is Brian at 100 points right there, Alex? How good is Brian at assigning MuBucks? So I could take into account MuBucks, which that'd be pretty interesting too to see MuBucks. We're gonna visualize it here. There's the visualize of this model. And this is actually, you know what? This probably passes conditions, which is so crazy. I'm shocked we get something that might actually pass the conditions. It almost passes every condition. You should know instantaneously that the only condition it fails is this one right here. And when you look at the normality of the residuals, what do you think? A through F, what do you think? First person who picks the one I pick gets 100 points. What do you pick? First person. First person who picks A through F for this graphic. I'm giving 100 points to Alex. That was actually the first thing I thought, and I changed it in my mind. Sylvia's right, B+. I thought A-, then I went to B+. Because I was doing A- until I saw these, and I was like, okay, B+. It's not that bad. It's quite fine. It's quite fine. So if you're saying B+ right there, yeah, it's a pretty decent plot. Does that make sense where everyone's like, it's pretty good? Like, that should definitely pass. It's not like awesome, but it's like, it's pretty good. So who thinks, are you getting it? How we check regression? Like, this is now a review, again, of checking regression right here, checking the conditions. And we go right here. We look to see if the p-values are low. There's one low p-value. We look at the sample size. We're good on the sample size. Then we look to the plot over here related to the normality of the residuals right here. What's the lowest? Like a C-. You see, when it's like everyone's parents are different. Good question, Sylvia, 100 points. If it was like a C-, some people would be like, nah, not good enough. Imagine if this is like, what do they say, good enough for government work? It's like a joke, like, oh, it's good enough for government work. So if this is like a really important job, you might want it. Like, some people might not want the B+. B+ is, unless you have really picky parents. My parents would be super excited if I got B+. But I mean, this is like B+, A-. I mean, this is awesome. Yeah, that's like where it's also getting. And is the grade in Canvas the currently weighted grades? Everything in Canvas should be accurate. Please tell me if it's not. But everything in Canvas, I believe, is accurate. I worked on grades all yesterday. Please tell me if it's not. I will try to fix it immediately. I believe everything in Canvas is accurate. And also remember, the final is a big part of it. Also, here's a big thing too. Let's go over to Canvas really briefly right here, because there's a really great thing in the syllabus. I might be double playing the audio. 2 seconds here. Let's see, I might need to log in. So give me a moment. Oh, we're logged in. Let me go over to Canvas, and there's some really good info, really good saving stuff. So we're pulling up the syllabus now. Syllabus time. Okay. Let's go down to the test right here. I think one person informed me that things weren't weighted properly. We'll be doing some more activities this week for practice, and I believe we might do one today. And I like to give people at least like till the next night to do it, but we do it in class, so you have enough time to do it. Exams are with 50%. Here's a big thing right here. The 2 conceptuals, take-homes, best are worth right here. So there are 2 conceptuals, take-home exams, best worth this, best worth this. Do I have everything weighted properly? The way it's oriented here, the 2 conceptuals without a computer, take-home exams, best worth this, best worth this. Maybe I don't have things weighted. Did I change the way your guys are weighted? All of a sudden now my brain is just like, what went on? Because I modeled it after 474 now, so I could have the same pattern. So homework, grading. Maybe I misspoke right here. Let me see, because I think the way I have this written, there are 2 conceptuals, take-home exams, best worth this. So, wait a minute. Oh, wait, the 2 programming exams are worth this. Okay, wait. So here's the confusion right here. And this is good. This is the way it's weighted right now. Good. So, and it says without a calculator. Sorry, it says, well, it's with the calculator on screen. So, with this right here, and sorry for any confusing, the exam will be done with lockdown browser. Good. Okay, perfect. The way it's worded, these are the programming exams. It's early in the morning. Now my brain is back on. We have just enough Red Bull. So, yep, and does everyone see this right now? I don't know if you can see the weightings inside of Canvas, but the programmings are each worth 10%. But here's the really good thing about the Respondus exams, and this is what I wanted to point out, is that if you do better on the next Respondus exam, it'll greatly pull up your grade. Does everyone understand right here that your best Respondus exam will be worth 17.5%, and your worst Respondus exam will be worth 12.5. So right now, the Respondus category should be worth 30%, which is a big portion of your grades. That shifted a lot of people's grades. Like, if you made a little bit lower on the test, it pulled your grade down. If you made a little bit higher, your grade pulled up. But this right here is a big shift to the grade. Does everyone understand that? And let's see, and I'll probably do some other stuff later on to help out, but please be working hard. We've got just a little bit of time left, but who feels like this right here is probably going to help their grade? Because it can't hurt your grade. So this right here, if you do better on the final respondus, it'll definitely pull up your grade. So that's a huge thing right here. So please keep coming to class, because people who like, I just feel bad. And yes, thank you so much. I wrote 100 points right there. I probably maxed everyone at 200 already, but please keep coming to class. Please keep working. Please, you have to listen to this, because if you just say like, I'll just learn it over the weekend, that's where the C's happen. That's where the C's happen, because it's not something, it takes a while. It takes hearing it multiple times. It takes practicing it. It takes emailing me questions. Thank you to all the people who email me saying, hey, can you explain multicollinearity? Hey, can you explain VIF to me? What does this mean? And if I don't explain it well enough, ask me to go into greater detail. So please, 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 because today we are going back. Everything's working today. I like it. We're going back to multicollinearity on these. Whoops, wrong button. What does that button do? Oh, that's the Brian off button. On these Mega Mondays. What's up? It's Mega Mondays. So let's start talking about some multicollinearity right here. Now, and we'll do some help for tonight's assignment. So the very end of class today, I want to focus on tonight's assignment. So make sure to stay the whole time. We will go into tonight's assignment. I'll answer some questions related to it. So have your questions ready. During class, we're going to work on tonight's assignment. Was it due last night? Sorry. Yesterday was a busy. Tomorrow's assignment. So which, oh my gosh. We will do the one that is due tomorrow night. OT, we got this then. We thought you, well, I didn't get many emails on it. Good, assignment 8. So assignment 7, yes, I didn't get many emails. When I don't get emails, I'm like, I guess. Sorry, I was all day yesterday grading. We're going to work on assignment 8 tonight. We got this, or today. Let's do this. It was hard. Well, let's make tomorrow's assignment even easier. The one tomorrow is the one that counts 2. So how about this? Let's start working on that. We'll be done here in a moment with the material, and we will start working on assignment 8. I like that. I like that plan right here. Sorry, I didn't get that many emails yesterday, so I was like, and also, so I'm always trying to keep straight, like 474, 320, what's due when? We got this. Let's do this. Here we go. I like the positivity. Good with you guys? Love it. Let's do it. So what is r squared sub I? R squared sub I right here is going to be how x's explain the x's. So that cracks me off. 100 points right there. You can always ask how x's explain the x's. This is how x's explain your x's. Does everyone understand this? That r squared sub I is a model where you have your x's explaining your x's. This is a bad thing. This is when we talked about a party where everybody's bringing the same thing. You take one of your x's and you see how that one x is explained by all your other x's. It's a model where a singular x, just one of them, this is why the I is here. The I is here because it's like the ith x. So it's one of your x's being explained by all your other x's. You want this r squared to be very, very what? 100 points first person, extra 100 points on your today's. You want this r squared to be very, very what? You would really want this r squared to be very, very what? R squared sub I, you want to be very what? No. Low. You want your r squared, Sylvia, 100 points right there. You want your r, and Brad, you want your r squared sub I to be very low. Because this is how your x in your model is explained by your other x's. This is how a singular x in your model is explained by your other x's. You don't want your x's explained by your x's. That means your x's share the same sources of variation. If your x's explain your x's, they do the same thing. Imagine this. What perfectly explains how tall you are? I know this sounds ridiculous, but just think of something that explains how tall you are. that perfectly explains how tall you are. Don't think too hard on it, as in, what explains how tall you are? Not, well, perfectly. 100% of the variation, how tall, your height. Sylvia, 100 points right there, your height. Your height explains how tall you are. So if we're trying to explain somebody's height, and we make a model that has height predicting height, well, that would be an X and Y model, but it'd be like, well, yeah, 100% in your variation in your height is explained by your height. So if it's an X explaining an X, you don't want the two explaining each other. Because, yes, Philip, 100 points, Philip, you want R squared to be low because your X's are explaining the other X's in your model, as in they're doing the same thing. They bring the same sources of variation. Does that make sense there, Philip? That you don't want your X's to explain each other, lest they're kind of like stepping on each other's toes. They're doing the same thing. You want the X's to be unique and not do the same thing. Because do you know what happens to the model when the X's explain each other? The model doesn't know what to do. If you have two variables, and I can show you this very, very quickly, watch this. We're going to make a model right here. Let's hop back to the main screen. Everything's working. Man, that Friday got everything fixed up right now, and everything's working. R's working. It's going to not work now. Watch this. We got, great job right there. We've got here random normal numbers, and I'm going to do here 100 random normal numbers. So Y is just 100 random normal numbers. But I'm going to make X the vector 1 through 100. Now we're going to make a model right here where this is LM Y tilde X. They're not in a data frame. This will work. We can see how well it explains it. Whoops, wrong button. And so this is a model, and you can see it's just random, but watch this. Let's make an X2. And X2 is the exact same variables as X1. And if my theory is correct, inside of one of these, I think X2, we will see that we will have NA. There it is. What is X2? You do have a cheat sheet for the final. 100 points right there, Nicole. You do have a cheat sheet for the final. Yep. Lockdown browser, cheat sheet, same rules. Good question, Nicole. What is X2? It's exactly the same as what? X2 is exactly the same as what? X2 is exactly the same, the second variable in the model, as X. 100 points, Ben, right there. And Brad, it's the same as X. So they do the same thing. Does that make sense? That X1 and X2 do the exact same thing. So you know what the model says? It says, I don't even know how to use this. I wonder, excuse me, I wonder if we can even get VIF for this. There are aliased coefficients, which means it can't even find it because the coefficients don't even exist. I'm going to make this slightly different right here. Let me try this. 99, 99. Okay, will that work? It did work. And if you notice here, cool. We do get coefficients. We do get coefficients now because this is now 1 through 99 and 99. So it's almost 1 through 100, and then we repeat 99. But now our X1 and X2 basically the same thing. Our X1 and X2 basically the same thing. Does everyone see how they're basically the same thing? Except there's a small difference right here. So since they do, I think that would, Brad, I'm gonna do that next. I think that'll be the same source of variation because it's just, it's linearly dependent for matrix algebra people. So you know what the VIF should be? The VIF should be very high. I'm guessing in the thousands maybe. Woo! That's ridiculous. We'll talk more about what that means here in a second. But those VIFs right there. But think about this. The VIFs are identical because there's only two variables. And the way in which X1 explains X2 is the way in which X2 explains X1. Now watch this. I'm going to make an X3 here. And X3 is going to be 100 random norm or 100 uniform numbers. Random uniform. So these are 100 random uniform numbers. So will X3 share association with X2 and X1, which is just X? Will X3 be in any way related to those? It's just random uniform. It's completely random. It's completely random. No. So we should see very what VIFs. The VIFs for this should be very what. We'll talk more what variance inflation factor means in a moment, but the VIF for that one is super small. So the variance inflation, oh, I had my signif difference on very, let me change that. Options, SciPen, it's SciPen. SciPen equals 4. There we go. SciPen equals 2. Sure. I was looking at results and stuff, and I was messing around with my controls. So this right here literally means the sources of variation shared between them is almost nothing. We'll talk more what variance inflation factor means in the notes in a moment. But Brad brought up a really good question. What if this was 101 through 200? And I'm guessing we're going to get aliased coefficients again. So let's change it. And yeah, it's completely, it brings the same source of variation. VIF means variance inflation factor. Variance inflation factor. Variance inflation factor. Great question right there, Grant. 100 points. Thank you for asking. What does it really mean, though? Like, what's the point of this VIF? What is the point of it? Mega Mondays. What's up, Mega Man? So when it comes to the variance inflation factor, we need to know how it's calculated. So it's calculated based on how strongly correlated the x's are with the x's. We do not want this. If the x's are correlated with the x's, they bring in redundant information. That's like the biggest key word for this. That means your x's are not doing unique things. High VIFs means high correlation, but being larger is relatively, so what counts as high? Great question right there. So yeah, don't worry, Jonathan. We're going to definitely say that. 100 points, Jonathan. So when there are redundant predictors, we bring in the same information, and here's the big thing. Then we have more uncertainty in the estimates of the coefficient. First person, 1,000 points, who tells me what uncertainty is in terms of the notes. 1,000 points, first person, who tells me what uncertainty is. I always call this uncertainty. I always call this uncertainty. First person tells me what I always call uncertainty, because this is going to go into something big that you need to know. Close. People are getting close. Was it? We might do that, Sylvia. I think we might, Sylvia. We'll take a look at that. I'll take a look at what was on it, and let me see that, Sylvia. I will definitely consider that. And I think it was, James is the first person to say it right here. Thank you, Sylvia, for that suggestion. 1,000 points, Sylvia. We will look into that. I will look into that. Sorry. I'm sure everyone had a busy weekend, and I feel, if you couldn't tell, I was like, did we have it? And I couldn't remember because I was mainly focusing on grading. And so I was like, got to get the grades out, got to make sure everything's accurate. And so I didn't see, there were some emails yesterday, but not a ton. And so that's why I'm going to take a look, and I will definitely consider that, Sylvia. I'm going to look what was on there, make sure we had the knowledge and all that good stuff. So James is right. This is standard error. When it comes to standard error right here, that is our uncertainty. And what do we want? We want low amounts of uncertainty. So let's take a look at this right here and see how the formula is done. Now, why is it important to know that standard error is uncertainty? Because if you square standard error, what do you get? If you square the standard error, what do you get? If you square the standard error, you get what? If you square the standard error, you get what? Does anyone know what standard deviation squared is? Not the VIF. Not the VIF. If you square standard error, or if you square the standard deviation, what's the V stand for? You get variance. Standard error squared is the variance right here. And think about this. Just take the last part of it. Inflation factor. So the inflation factor is how much we are increasing the variance. So basically what this could be called is uncertainty squared inflation factor. Or if you just want to think of it as uncertainty inflation. So this could be uncertainty inflation, because it's uncertainty squared inflation factor. It's like how much you are increasing your uncertainty. So think, if your x's bring together the same sources of variation, the model doesn't know what to do with them. Does that make sense? Like, your model says these x's do the same things. What do I put in the model? I don't know. This one does the same thing as this one, so I don't know what to do. They're both the same thing. How do I know? I'm just doing math. So the model gets more uncertain the more variation the variables share. So you don't want your variables, as we saw with the equation, to overlap. What's the difference in standard? So we really don't interpret variances in squared units. Emily, 100 points, great question. Variance is in squared units. So we don't really ever talk about variance. We'll usually square root it. So when you do this right here, you square root it. Like if you get a variance inflation factor of 5, then our uncertainty is about 2.2 times larger than if the x's had been independent. Like we have 2.2 times more uncertainty in the estimates of these coefficients. So it's how much we are increasing the standard error, which is in our output. So the standard error is probably increased by about this much due to the overlapping variation. Does that make sense, Emily? We don't ever really talk about variance because it's in squared units. And we just square root it then to turn it back into standard error. So I don't know why they don't just call this standard error inflation factor and square root it. That would make our lives a lot easier instead of having to go through these steps. But whoever created it just wanted to call it VIF. And I guess because it's so easy, they could have just done a square root over this, though. All you'd have to do is take this formula, square root it, and boom. Variance inflation factor or uncertainty squared. Yes, I like that. Philip, Philip, you're on 1,000 because you're putting you always put excellent notes in the chat. Thank you very much. It's how much more uncertainty we have due to the overlapping variation in the x's. The overlapping variation in the x's is the degree to which there is multicollinearity. Now, why do we call it multicollinearity? It's called multicollinearity because we have the x's, multiple x's explaining x's. Now, in one of our models, just previous here, in this model, technically, this is just collinearity. And I have to go way back in time right here. In this model right here, there is a collinearity. There's collinearity because there's two x's. In this model right here, there's multicollinearity. So the multicollinearity is how this x is explained by these other x's. That's multicollinearity. Collinearity, meaning just two things, is how this x is explained by this x. That's the collinearity of the model. Does everyone hear the just small shift in words? That the collinearity is how an x is explained by another x. The multicollinearity is how an x is explained by multiple x's that are in the model. So that's why we call it multicollinearity, how x right here, this x right here, is explained by all the other x's. And this x is definitely explained by all the other x's. It's probably due to the collinear relationship between these two, which you can see by looking at the way that they're built. There's really a high degree of collinearity leading to multicollinearity. So that's a little bit specific. If you understood that, you definitely understand just the small nuances between the words. But that is, it's probably one of my favorite topics. I don't know. I just like multicollinearity a lot. Good. We've seen Mega Man a lot today. Let's go here. We're almost done with the notes. Multicollinearity does not invalidate a regression model. This is key. Anytime you see something in a box, make sure, so Alex might be taking a note on this, you don't throw away your regression model because it has multicollinearity. Multicollinearity is mainly just going to be a problem that's going to make us more uncertain. So in descriptive statistics, multicollinearity just adds to our uncertainty, making us more uncertain about how to interpret these coefficients. But you don't just toss out your model when it has multicollinearity. If it has multicollinearity, you say, that just increases my uncertainty, and uncertainty is a bad thing. So the last set of stuff right here, standard error, Alex 100 points. The standard errors will be larger, and since the standard errors are larger, which, do we have any output with standard errors? Here we are. The standard errors are just your uncertainty. So if there's multicollinearity in this model, it'll increase this right here, which if it increases your standard errors, then it will decrease your t-statistics, and it'll also increase your p-values. So think about this. If your standard errors are larger, what would happen to another thing? What else would get wider? 1,000 points first person. What else gets wider if your standard errors get larger? If you have more uncertainty, what would get wider? I'm throwing 1,000 points every day now, so stay watching live. Confidence intervals, Emily, you're totally right. So the standard error is used to build the confidence interval. So if you have more uncertainty, your confidence intervals will get wider. So, you know, there's lots of test questions I can make from this. Like, if there's a high degree of multicollinearity, which of these will be bigger? VIF, t-value, or I could say which of these will be smaller? The t-value is the only one that would be smaller, because I could say if there's a high degree of multicollinearity, which of these would be smaller? Standard error, that would be bigger. P-value, that'd be bigger. Confidence interval, that'd be bigger or wider. And t-statistic is the only thing that would be smaller. So if I did if you have a high degree of multicollinearity, which of these would be smaller? The only thing that would be smaller would be the t-statistic. Does that make sense? So that's a really good test question there because it's 4 things, and you have to think, okay, if there's more uncertainty, well, yeah, my confidence interval is going to be wider because I have more uncertainty. If there's more uncertainty, then we'd be less likely to say that it's statistically significant. If we have more uncertainty, then that would literally lead to a higher standard error. So more uncertainty would be higher standard error. Does that all make sense right there? And then the t-statistic would be smaller because the t-statistic is the ratio of these two numbers. So if you have more uncertainty, it would create a smaller ratio. How are we doing on that? That's a really good test question right there. So Alex, hopefully taking notes on all those test questions. Love it. Let's continue on right here. And where are we in model evaluation? So it's got a little bit more notes, and then we'll get to an assignment at the end, and make sure to come back for off stars. We'll do even more assignment. Statistically significant. So in multiple regression, what does it mean for something to be statistically significant? Great notes, Jonathan, 100 points right there. Statistically significant in a multiple regression means that a variable brings with it new information. So in a multiple regression, a variable brings with it new information that the other variables are not accounting for. We mentioned this last time, and I kind of alluded to it, that in a multiple regression, to be significant, you have to bring with it new information. We talked about a party. Can anyone tell me what is something at a party that would be significant? Let's say if there's 100 people at a party, what's something very small at the party that might be significant? Like someone brings something to a party that would all of a sudden be significant with like 100 people at the party. They've all brought different things. People brought chips, people brought pizza, people brought Coca-Cola. What would be significant at the party? Trash bags. I love that right there, 100 points, trash bags. Now imagine if you have a party where people just brought trash bags. You'd be like, wait a minute. But I mean, if someone shows up with trash bags with like 100 people, you'd be like, oh, thanks, we need these. We've got ping pong balls. Yeah. These things that are maybe small that by themselves are not significant, but all of a sudden now the variable is significant. So you might not say, oh, trash bags are the perfect things to bring to a party, but with all these other variables, trash bags do something unique that pizza doesn't do, that soda doesn't do. Trash bags bring unique information. They are unique in what they do, and the other variables don't do that. So that is so key right here. So in the multiple regression, it's statistically significant when it's better than the naive model. The whole of the multiple regression, so the multiple regression itself is compared to the naive model. That is when we look at the reduction in the sums of squares from a model with nothing in it. So what is the naive model? You should have a key note that the naive model is when we predict everything to be the what of y. 100 points first person. The naive model is when we predict everything to be the what of y. The naive model is just the what of y for everything. What is the naive model? Make sure you have these. Whenever we pause, you should make sure you have. The naive model is when we predict the what, and this is being in 474 also. Who knows what the naive model is? Here's a hint. Average value, Sylvia, right there. You're right. The mean of y. So it's the mean of y. Jonathan also. Yep. The average of y. It's the mean of y. So it's the overall average. It doesn't use any x's. The mean does not use any x's because it's just the mean of y. No x's. The naive has no x's. So if you notice right here, here's the naive model. You can tell very quickly. Remember this right here? That's the naive model. It's just the mean of y at all points. What we create from this is a sum of squared error. So this is literally if we were to take and do squares right here and just sum all these squares. Hence why it's called the sum of squared error, like it's a residual. So we have here all these sums of squared errors. Now we go over to our model here, and we have how much our model has as an error. Now the goal is to reduce this sums of squared error. So if you were to calculate r squared from this, all you do is say how much have we reduced the sums of squared error. So we'd go here to 957, and we have still 323. So does everyone see that's how much error we have reduced it by? And then we divide by this, and that's the r squared. R squared here is 66%. Because what would you like this one to be over here? What would you like this error to be for how much error we have after we make our model? How much error would you like there to be after we make our model? How much error would you like there to be after we make our model? 0, exactly. You'd like there to be 0 error, and then your R squared would be what? If we had 0 error, 100 points Brad right there. If we had 0 error, what would your R squared be? With the 0 error, then you'd have reduced it. What? Your R squared would be, first person 100 points, your R squared would be, any ideas? If you have no error, how much of your yes, Corbin, 100 points right there. You'd have an R squared of 1 because you'd have explained 100% of the variation. All the points would have to be on the model. So if you explain 100% of the variation, you'd have no error. So we would have reduced the error 100%. Great job. And so when we look at this right here, this p-value right here is how we are overall doing. I want to make that very, very clear. This p-value right here is how well the overall model is doing. So overall, our model does better than the naive. In multiple regression, our model is shown to do better than the naive by the p-value. I can't make that clear enough. The p-value tells us how we do related to the naive. And we are doing way better right here. So what is this ANOVA telling us? That our model reduces the sums of squared error in a significant way over the naive. So we have right here that if the p-value is below 0.05, we do better than the naive. If the p-value is above 0.05, we don't do better than naive. Now here we get to the individual predictors. This is so key. If a variable is significant in the multiple regression, it brings with it new information that the other variables are not accounting for. If the variable is significant in the multiple regression, it brings with it new information that the other variables are not accounting for. Does that mean it's a bad variable by itself if it has a high p-value? No. That means if its p-value is high, it does not bring with it new information after you have the other variables in the model. That is so key. This is where I trick people, because we'll see, we go through in the notes right here explaining. If the p-value is less than 0.05, the predictor brings additional information that the other variables are not accounting for. If the p-value is greater than 0.05, the predictor does not bring with it new information. So what is this key thing? I'm going to say the key word a few times here about multiple regression predictors. In a multiple regression, if it's significant, it brings with it new information the other variables are not accounting for. In a multiple regression, if it's not significant, it does not bring with it new information the other variables are not accounting for. 1,000 points first person. If you hone in on that key phrase I'm saying here, it's a 2-word phrase, that in a multiple regression, a variable is statistically significant if it brings with it new information that the other variables are not accounting for. If it's not statistically significant, if it does not bring in the multiple regression new information that the other, boom, Sylvia right there, yes. That's the whole goal of a multiple regression, is that the X variables bring with them new information. What would you not want the information to be? You would not want the information to be redundant. If you remember back here, you don't want the information to be redundant. Redundant information is bad and will lead to uncertainty. So it even goes back to variance inflation, that we do not want this redundant information. You want new information with your X's. So this is a bad thing right here. X's bringing new information will make them statistically significant when they bring with them new information. So our goal is that they bring new, not redundant information. And so that's what we want. Here we go. We've got a model right here predicting the wins of an NFL team, and take a look. Offensive total plays is very significant. In a multiple regression of variable significant, if it brings with a new information. Yes, Corbin, 1,000 points. Great note in the chat, Corbin. And also Philip, you guys are on your 1,000. Thank you so much. Great notes in the chat. And so right here we see a multiple regression where we're predicting how many wins a team will have, and we're doing it by the offensive total yards, offensive total plays a team has. And this is very statistically significant. But now let's take a look at what happens if we add into it their offensive rushing and their offensive passing yards. Wait a minute. All of a sudden now, this is not statistically significant. Because wait a minute, the multicollinearity here would be very high. because your offensive total plays would be explained by your rushing yards and your passing yards. Does that make sense to everybody why there would be high multicollinearity? That this X right here would be explained by these variables. Like what explains your offensive total plays? It would be your offensive yards and your offensive passing yards. Your rushing and passing yards would explain this X. And because of that, this X does not bring new information the other variables are not accounting for with the model. So hopefully that makes sense right here, that if you know football, got the sports on today, that we would not have new information brought by this. So it's not really needed in this multiple regression model because the other X's are already accounting for the variation that it's bringing. That X that I have highlighted does not bring with it new information. So it's not statistically significant. But by itself, is it significant? Yeah, by itself, it brings great information. But in the multiple world, it does not. So imagine this. We're going to have a party, and someone brings McDonald's for everybody. What do you guys think about that person? That person came to the party and they brought cheeseburgers from McDonald's for everyone. They're like, hey, everybody, I just brought some McDoubles. You're like, woo, McDoubles, way, that's awesome. Who's all happy? Who was it? It was Brian brought the McDoubles. Brian brought McDoubles for everybody. We got McDoubles. Sorry if no one likes McDoubles right here. Yeah. Austin, you're cracking me out 100 points. So right here, everyone's happy. But then guess what? Brad comes to the party and Brad's like, hey everybody, I brought stock and barrel burgers. Brad's like, I got custom stock and barrel burgers for everybody. So now Brad, and he even brought like the chicken burgers if you want. I think they might have a fish one. So Brad and he also brought the fries. Well, then we don't completely overlap in the variation. But who's going to be, I know, me neither, Dennis. Who's going to be more significant at the party? Brian was significant by himself, but as soon as Brad came into the party and brought stock and barrel, all of a sudden Brad is more significant. So you see Brian by himself at the party, everyone's like, hey, Brian, that's awesome. We love McDoubles because they're awesome. And then, they're, Brad. And so we see right here, Brad is more significant. There we go, 100 points if you're saying Brad in the chat, because Brian and Brad now overlap in the variation they bring, but Brad's kind of doing a better job. Does that make sense? Like Brad brought something better. Even though Brian and Brad overlap, Brad is kind of doing a better job. So Brad would be like one of these variables over here that's doing a better job. And Brian was significant by himself, but now he's not in the multiple world. Do you see how another variable entered in the model? Brad entered into the party. So that way it's like, wait a minute, Brian was the king of the party, and now Brad is. So like Brad saying Brad in the chat. And so this is just what's going on through the variation explained. Here's a very, very cluttered model. We'll talk more about making models later on. But if you notice here, if something is not statistically significant, it's not that your offensive pass first downs, it's not that it's not good. It's just that it doesn't, ooh, Emily, that might be unique in the information it brings. If we only brought burgers and Emily brought Chick-fil-A, Emily, 1,000 points. Thanks for throwing that in, because that might be significant even with Brian and Brad and now Emily at the party. Emily's bringing kind of unique information because we brought like burger items and you brought chicken items. So Emily would probably be significant, and Brian and Brad are kind of fighting for the significance. Like Brad is probably going to be significant, and Emily might be the most significant because Emily brings the most unique new information. Does that make sense why Emily might be the most significant? Because Emily has no confusion between, like, it's like, well, do we like McDonald's? Do we like stock and barrel? They're both burger. Everyone likes McDonald's burger is classic, but Emily brings with new information that's not really overlapping. It's food items, but then someone comes and they're like, hey, I brought drinks for everybody. I brought Kool-Aid, and I brought Coca-Cola, and I brought water, and I brought lemonade. And you're like, whoa, this person's, they're bringing other new information. Now if you have Zaxby's, you have Emily and Nicole overlapping in the variation they bring. There's some overlap between everybody because we kind of got food items. Like there's overlap between Brian, Emily, Nicole, and Brad. But Nicole and Emily now have more overlapping variation, like collinearity between these two. Does that make sense right there? So the more food items, the more significant goes down with each item, the more overlap. So if you look at where the overlap is, because maybe this, yeah, and Emily understands it right there with the, you might steal my people, because now people might be like, okay, well, I'm picking between Chick-fil-A and Zaxby's, but they are different. But then if you went and said, like, let's bring KFC, that might have more overlap with the Zaxby's. It's all food items, so they're all going to kind of have overlap between each other. Like, there's always incidental overlap, but if someone's like, I'm going to bring, like, Coca-Cola, that'll have the least overlap. But then if someone's like, I'm going to bring Pepsi, the Pepsi and the Coca-Cola will have overlaps between each other. So the way in which your variables overlap, you really don't have to worry about too much. But if you notice, as more people come to the party, as we see here, we have a very big party right now. This one right here brings the most new information. Why do I know it brings the most new information? It has the lowest p-value. And so it brings with it the most unique new information that the other variables are not accounting for. And it's not that it's significant by itself, it's that it's significant with the other variables in the model. The KFC would add 100 points. So if there's a single variable in the multiple regression that is not significantly, you can drop it without fear of losing and reduce. Yeah, so you can remove out, and this is our last thing right here. I think this is the, yeah, we'll be starting the activity, or we'll be starting homework stuff in about 15 minutes. So this is a big topic right here as we get into what a partial F is. So you can always remove one X out of the model just like this. You can just take your X, you can be like, out of the model. That's all you have to do. So we can take any one of them out of the model. But if we have a set of X's, if you have like 3 things you want to remove from the model, do you know what happens once you remove something out of a model? When you remove, like, let's not remove that one, that's statistically significant. Let's remove this variable out of the model. If I remove this variable out of the model, everything gets shifted and changed around. Not as much material today, and then we'll do some work here in a moment. I think about 9:15 we'll start doing some homework. I'll answer homework assignment questions. So I'll do as many homework questions as I can. It'll be in the video, you can see it. And we'll do some more tomorrow too. I'm gonna try to do homework every day with you guys. Remember, office hours too, we do homeworks. And so right here you can see, if I take this variable out of the model, what will happen? Everything will start shifting around. Imagine Brad says, I'm taking my burgers out of the party. Brad says, everyone's brought so much food, I'm removing my burgers. Well, what would happen? People would start eating Emily's food and Nicole's food and Brian's food at different rates. Everything's going to like shift in the party. The whole table's going to be reorganized. So as soon as one variable is removed outside the model, it means other things might go up, but they'll just shift. Like, who knows what will happen? It's a big, like, I don't know what will happen. So removing something out of the multiple regression will change everything about the model. So how many things can you remove? 1,000 points first person. How many things can you remove out of the model if you want to remove something just by, like, well, let's take something out of the model. What is the most amount of things you can remove just by doing that? Can I remove this thing that's not significant? 1, Austin, 1,000 points right there. You can remove one thing just like this. You can just be like, I don't like that. But as soon as you remove that one thing, everything changes. So you only want to remove one thing max. Do not, because everything else is model dependent. It says p-values, but literally everything. I mean, the p-values are deduced from the other things. So do not remove more than 1. If you remove more than 1, you need to do a partial F. How do you remove a variable? You just do a minus on it, or you don't include it. So if you notice previously, let's show it here. If I want to have in here x3, I do this, and I get x3 in the model. If I don't want x3, I do that, and I don't have x3. So you can choose what variables go in. If you want x3, you can put x3. If you don't want x3, you don't have to. And you can do minus if you're doing like, here, I'll show you real quick. Let's do survey 10, and let's do M save into LM. This is going to be a very, very big model right here. Whoops, I didn't do a comma. It's early morning when you know you don't do a comma. And so this model right here is going to be a very, very crazy model. You notice it's got a ton of variables in it, but I could go here and do this, and now I've removed weight. So if you have everything in, you could remove it that way. No, good question, Grant, 1,000 points. No, always ask, always ask. There's no bad question. So if you want to remove more than one variable, you have to do a partial F. That's a key note you should have in your notebook. If you want to remove more than one variable, you have to do a partial F. To do the partial F, you need to make a simple model and a complex model. The simple model is called simple because it has less variables in it. The complex model is called complex because it has more variables in it. If you notice, we did the trick here to put them all in. So a simple model versus a complex model. And when we look at this right here, when we look at this, what we have going on is the following. Here's what we do. We have two types of f-tests, and the two types of f-tests are as follows, and we'll start doing homework after this. The two types of f-tests are when you go all the way right here. Let's call this your model. And this is the naive. This is called an f-test. When you compare your model to the naive, oh, the total dot is everything. Good question, Sylvia, right there. That means all the x variables. So when you do the dot, it's like y tilde x. And so the dot is every single x. It'll do every single x for you. Does that make sense, Sylvia? It's just a shorthand notation that the program recognizes you want to put in every single x. It's called the formula format. So the tilde right here, this just creates a formula. This is like y explained by x. So it creates a formula format. So that's how the program recognizes it, as like the formula, like you're saying, we're going to use y as an equation built from x, and then the dot is a y built from all the x's. I hope, does that make sense, Celia? That was a good question. Like, I don't know, that's just like what they chose. Don't worry, like when I laugh, I'm like, that's totally something that I was like, why is it tilde? It's just what they did. I hate an answer. I hate those answers. It's like, because. But so right here, let's take a look. If you start off here at a simple model, I want a keyword in the chat for 1,000 points. You're traveling what amount of this right here? A what amount of this? Of the whole scale, you're traveling a what amount of the whole scale? Like usually the f-test, boom, Brad, 1,000 points. Partial. Yeah. You're traveling a partial amount of it. Because now you're comparing a simple model, and your model can be known as the complex. So the complex has more in it. That's all the complex means. Like complex just means it has more in it. And now when you're doing this comparison right here, you're going part of the way. So does everyone understand right here, you're comparing in a partial f, a simpler model to a bigger model. And if the p-value here is low, it means that the complex model brings with it new information that the simple model does not have. In the original one, if the p-value here was low, it's that your model brings with it new information that the naive doesn't have. So the f-test just compares two models. The original intent of the f-test is to compare the naive to the complex model. But a partial f compares two models, one with less variables to one with more variables. Does that make sense what a partial f does? The reason it's called a partial f is because you're not going from the naive to your model. You're going from some simpler model right there up to your model. And you're seeing, does it explain more variation? So that's why it's called a partial f. You're not going all the way. The full f test would be from the naive to your model, but the partial f is going from a simpler version of a model, which just means less variables, to a complex version of your model, which means just has more variables. So the idea of simple versus complex is just fewer variables versus more variables. So hopefully that. Good stuff. And I think we'll finish these notes tomorrow. Talk about practical significance, R-square, just RMSE. We'll talk about these tomorrow, but let's start doing some of those homework assignment questions. And let me see, which one do people have questions on for the homework assignments right now? Multiple regression, yeah. Let me see, and let me make sure. Got last night's homework assignment here. Let me see. Let's see. What questions are there? Ask your questions in the chat. Let me see what was on last night's that I feel like we did not cover. We covered this. The book questions are always, yeah, is there a partial? We're putting bonus on this. I might need to move tomorrow nights. Yeah, the multicollinearity we didn't, or well, the partial F we didn't cover, so that's definitely not fair game. So that's, sorry about that. I think that's the only thing, because we talked about VIF last time, but I reviewed it today. Let's hop over here to next night's assignment. Make the scatter plot matrix. Let's see right here. Yes. Okay, we can do all this. Oh, and then we got polynomial models, which we'll cover more tomorrow. Cool. I might even, today's the 22nd. Time just flies. That's why I always hate putting due dates. What question? Oh, wait, you guys can't see anything. What questions are there? Surely a question. Do not leave right now because we're going to be going through. All we really have to understand is I might move this by 1 day. I'm going to give bonus to last night's assignment. I'm going to move this by 1 day. Just looking at everything. Interactions. Yeah, we're going to have to wait. Yeah. Okay. So we'll move this by 1 day. So we're going to move this over 1 day, I think. Yeah, most of assignment 8. Well, let me show you how to do polynomials on this. So yeah, and always be telling me what's going on. Sorry, when I say it's busy, I mean it. I understand. And moving and teaching 2 classes. Whew. So who's going to be my reminder person? Who wants another 100 points on top of how many you got today? It'll be due Wednesday. I'm going to shift everything over just a little bit. Yep. And we're going to put bonus on the last assignment. We're going to shift everything over a little bit. Who's going to be my reminder person who gets extra 100? You need to remind me. Send me an email saying, hey, Brian, start shifting those assignments. Who's going to be my reminder? Anybody? Bueller? Nobody's going to remind me? I won't remember. No one reminds me. Nicole, 100 points right there. Remember to remind me. Be like, hey, Brian, in the email, be like, hey, you got to move those assignments. I was going to have a backup person too. Nicole, remind me. Okay. Which one are people wondering about? We could start this assignment. Let's take a look right here. Load in auto. Cool. Let's load in auto. So one thing, you could put this right here. You do need library reg class because data auto is going to be right there. Cool. Can we do an afternoon? Yeah, of course. Yeah. Oh, yeah, we'll try to do, you're right, afternoon. You got it, Brad. What time is good for you guys for afternoon office hours? Tell me what time is good, and I'll try to do it around there. Scatterplot. Make the scatterplot matrix of values. So let's see right here. And we should be able to, I think we just plot. Scatterplot matrix. 3. People are saying 3 or 4. I think 4. 4 is winning right here. 4 is winning. You'll bring burgers. You'll bring burgers. I like that. So if you're wondering, a lot of times in the notes. So I think I'm in the, here we go. So when we go back here, there's a scatterplot matrix. We see here at the start. Here we go. Scatterplot matrix. See here, pairs. So we're going to take this function right here. Well, it's very easy to use. So make a scatterplot matrix in the data frame. Yep, it's pairs. You got it. Do the relationships of each of the predictors feel efficiently look to be roughly linear? So this is pretty good right here. Pairs. And we are going to predict fuel efficiency with all of the x's. And data equals. There's a package that, and you can do this, the PCH, the CEX. You can play around with it yourself. Let me try to find something real quick. Correlation matrices in R. Take a look at these graphics right here while I look up this and see if you see some really nonlinear ones. Do you see any nonlinear ones? Oof, that's not what I want to. Those are not that great. Does anyone see any nonlinear ones? There was a really good package I found a long time ago that displayed the data really well. Oh, here it is. Okay, found it. Okay, you can always do, so what did people say in the chat? Fuel efficiency and horsepower? Fuel efficiency, boom. Yeah, that's really shows some nonlinearity right here. Also, so fuel efficiency and top speed. Now, the only ones you really care about would be this one. Because what do you notice right here? This is the y variable, and the most nonlinear relationship is with horsepower, top speed, and the other ones really don't have much of a nonlinear relationship. So I just found the package that I always forget about in the background, and let's take a look at it. You can always do this. I don't mind if you put these things in here. So this is performance analytics, which I need to install because I probably don't have yet. And so I'm installing the performance analytics. Good, it's got it. And you do not have to do this. If you notice right here, it's my data. There's my data. Oh, it just takes the whole matrix. So all you have to do is put in this. and it should do it. There we go. I love it. Wow, that's awesome. So if you look at this right here, it actually shows you. Let's go to fuel efficiency. Where's fuel efficiency at? Oh, it's hard to read. There's fuel efficiency. So we are actually looking at this one, this one, this one, and this one. We can actually fix this if we want. I'm gonna put fuel efficiency right here in position 4. So 1, 2, 3, 5, 4. Okay. So we're gonna go here, and we're gonna go 1, 2, 3, 1, 2, 4, 5, 3. Did that do it? Error 3 is empty. Oh, ha ha ha. There we go. There we go. Okay. So you might be saying, why did I put, let me move myself. This right here, I think, is a really good visualization of what's going on, because if you notice, where is fuel efficiency graphed at in all of these graphics? What axis is fuel efficiency on with all of these graphics now? Fuel efficiency is where on all of these axes? I'll even drop this code in the chat. You just have to download the package. I think this is a pretty cool package. Fuel efficiency is now on the what axis? We can actually see the correlation between each of them. This has the weakest correlation. Oh, wait, fuel efficiency is on the, if you trace this way, Corbin, I'm still getting 100 points. It's, I reached out, I was like, gosh, reach out there. It's on the y-axis. Does that make sense, Corbin, that if you trace this way, fuel efficiency is always on the y, and then weight would be on the x right here, and top speed would be on the x, and then horsepower would be on the x, and cab volume, I think that is, would be on the x right here. So you can really see the nonlinear relationship with these two. Like this, it's just weird right there. And this is very strong nonlinear. That's very strong nonlinear, even though they have really good relationships. And so let me drop this code in the chat right here. What you need to do to get this code, though, is you need to install the performance analytics. And so there's the codes right there in the chat to do it. And it makes this really nice graphic. You know, there's always better graphics. There's always things you can look up. And I knew there was a better way to do the correlation matrix than what we have, because someone just wrote the code that does this. And so why not take advantage of their code? It also shows you, if you look at the middle of it, it shows you the distribution of the univariate variable. So you've got here the bivariate relationships, and then you've got the univariate, and then you've also got, oh, look at that. The size of the number is related to the, and then they tell you the significance up here with the stars. So the star tells you if it's significant, and then the size of the which, why is that so, wouldn't that have, I don't like that they put that so small. Well, that would be, see, that's horsepower and cab volume. So that's that one right there, right? It's pretty weak. And then this one here is this one here. Okay. Top speed, cab volume, if you trace it, that there is that there. And this here is this here. You see, that's kind of weak, but it's got something a little bit better. So, and then they're doing statistical significance, like I was saying. So fit the model with all the variables in it using the twiddle dot shortcut, examine the summary as well as the check regression of the model, x equals true, discuss at least one issue with the regression that potentially makes it a bad model. Cool. So let's fit our model right here with m save into lm, and we're going to go fuel efficiency. I think that's how we spell fuel efficiency. We'll find out the hard way. I don't know how to spell fuel efficiency. And we did. Wow, I do know how to spell fuel efficiency. Let's look at the summary. The summary of the model looks as follows. Off topic, we will now run x equals true on the question. R can't run the function. Yes, yes, yes. Alex, 1,000 points. Or Austin. Let's show why. I'll show you why. Good question. So when you're running that right here, here's what happens. It's x equals true, right? X equals true. Let me show you. When you run that, it goes down here and you have to hit enter. So good question, Austin, right there. A lot of people get stuck on that. I got an email yesterday about that. I think I got a few emails. I think I got 2 or 3. Like one person was like, I'm stuck, and then they fixed it. But you have to hit enter down there. You have to run it, and then it prompts you to hit enter. Sorry that there's a prompt on this, but a lot of people get stuck on it and like it's not doing anything. And once you see it, it's so easy to fix. No, Austin, that's why I give you 1,000 points, is because there's other people who get stuck on that too. No. Great. That's not off topic at all. That's exactly what you should be asking, because here's the thing, and this is why we start early on the assignments. There can be things that just get you stuck for hours. You could be looking at that all day and be like, what, my computer's broken. Exactly. And so don't worry, start early. And when it doesn't work, remember the rule of thumb. If you're stuck on something for more than 5 or 10 minutes, please email Brian. So I can't state that enough, that if you're stuck on something for more than 5 or 10 minutes, please email Brian. Be like, it's not working, it's stuck, it's broken. And you're not the first person to get stuck on that. And you won't be the last. Like Brennan right there. Brennan, 1,000 points for the commiserating. And you're like, that was totally me. That happened to me. So let's look right here. Well, when you look at this model right here, we'll go to the check regression. Look at this. The linearity. What is the big issue? Can anyone explain in words what the big issue of this model is? What is the big issue? Imagine I had a, if I said, what is the big issue for the model? See, it's a good written question. The big issue for the model, aside from equal spread, I mean, that's a problem. The p-value is below 0.5. Yep, that's going to be issues. Fails assumptions. Brad, great job. And Sylvia, great job. Yep. And the big failing is the linearity of a lot of these x's. If you look at like horsepower, here I'll vanish again. If you look at like horsepower, there's non-linearity, and that's this p-value, which is telling us that's really bad. This p-value for top speed is telling us this is really bad. We might not really see it for weight, but that's, you see it goes above it. That's pretty bad right there. Cab volume surprisingly passes. I mean, even though it's got a weirdness over here, but apparently cab volume's okay, but most of the x's have high degrees of nonlinearity. So most of the x's, 3 out of 4 of the x's have a high degree of nonlinearity. We also have problems with equal spread, which is going to show up right here. This is your equal spread plot, which apparently there's some, you see it gets a little wider. That's not the worst. And then there's a problem with normality of residuals, which I'd probably give this a B. B plus. I'm really nice today. I don't know. That's the B plus part of it. If you notice, it has some points that go outside. It's not it's a B or B plus. I'd let that pass for normality. My bigger problem is going to be on the non-linearity of some of the x's exhibited right here. So when you see low p-values and a high enough sample size for you to investigate, greater than or equal to 25, you need to then look at the plots to see where the issues are, like what exactly is going on. Like, let me take a closer look at this. So this is where we get to the part that is going to be a huge help, because we will do this tomorrow, but we haven't done it yet. So there's a really cool code right here. Probably one of my favorite codes right here. Is this where we're doing it? We're going to do the choose order? Yeah, we're doing choose order right here. I'm going to show you a quick way to do this. Watch this. Here's a trick. The trick is we're going to make model 1, and we're going to go to LM. Here, I'll read up here. We're going to go make model 1 and watch this trick. Fuel efficiency, and I'll drop this in the chat, so if you're watching, you get this. Fuel efficiency and tilde dot. You're like, wait a minute. When you do each x, watch the trick. Data equals, and then we go to auto, and then we go here, comma, and then that. Okay, that should do it. Good. Now, I want us to think, I know this data set pretty well by now. When you look at the data set, we'll look at the data frame really quickly. I got so much in here. Auto. Well, will that do it? Yeah. When you look at the data frame auto, your y variable is in position 3. That's why I chose this right here. So position 3 is auto, fuel efficiency. And then cab volume is the first variable. So when you look at this model, it has cab volume. So guess what I'm going to do now? And I'm going to append this code here just to make it one line. I'm going to take, and this is where it gets a little confusing, model 2, model 3, model 4, and this will be summary model 2, model 3, model 4. And this will be the first, the second, the fourth, the fifth. Who here thinks they completely understand what I'm doing right here? I'm taking my auto data frame and only taking those columns. Those are the only columns I'm analyzing in the auto data frame. Cab volume and fuel efficiency for this one. In the next one, I'm only analyzing cab volume and horsepower. And you see 3 is my y variable at all times. And this is, yep, and then I do the dot here because since I'm limiting my data set, it only is taking those variables. Here, I'll drop one of these in the chat. Should be pretty obvious to do with the rest of these, but there's one of them in the chat for you guys right there. So keep hanging out. I'm going to keep dropping things. So keep working away right here. Keep understanding the theory of how I've like written my code out easier right here by being like, oh, I'm just going to change which X variable I'm using, and I'm going to take all of them. Like the next one uses columns 4 and 3. The next one uses columns 5 and 3. And I've now permutated through every single model. So now I can go choose M1, choose order. There we go. And then we'll go here, whoops, here. And then you could have appended on to the end of it, but I'm just going to do it this way. So let's look at the choose order, which will pretty much bring us to the end of class. And we're going to kind of learn this topic a little bit right here. So what choose order does, and this will actually be a really good topic. We could have technically had the assignment due tomorrow, but being nice and we're putting it Wednesday, that'll give more than enough time. So if you don't have choose order, run library reg class. If you don't have choose order, run, and make sure to put this early on. Run this, Jonathan. 100 points. Thank you for asking. 1,000 points. I was going to have big points today. We got this. You can only get the 1,000 one time though. So you might already have it. I don't know. So make sure you run library reg class, and that'll make the choose order appear. So the choose order is in library reg class. You can confirm this also by doing choose order, and you will see it's in library reg class right there. So that's how you know it's in reg class. So when we run choose order, we've got 4 minutes to talk about what this output means, and here it is. Okay. So the way this output works is it looks for polynomial models that are going to explain more of the variation. Let me rerun it here. There we go. So here is your black line. And here's the polynomial models with higher orders. Now this has to bring up a new topic right here, which is R squared adjusted. R squared adjusted is R squared adjusted for how many variables are in the model. R squared adjusted is R squared adjusted for how many variables are in the model. Does that make sense to everyone? Let's get some yeses in the chat. That this is an R squared adjusted for how many variables in the model. Yeses or nos? I can't continue on to people say it makes sense. It's just this is an R squared adjusted for how many variables in the model. This is an R squared adjusted. Awesome right there. So this is R squared adjusted for how many variables in the model. So R squared will always go up. R squared adjusted might go down. And we can see this in the notes. We were literally right to it. That if we go to R squared adjusted, R squared always goes up, but R squared adjusted is simply R squared with a penalty term. So R squared adjusted might go down. So we were right to this today, but we didn't mention it, that R squared adjusted is R squared with a penalty term. R squared adjusted can actually be negative. So R squared adjusted will not always go up. We notice that right here, that as we go to higher polynomial models, R squared adjusted goes down sometimes. So how do we know what the best model is right here? I'm going to give out big 1,000 points here at the end. We take our highest R squared and we subtract off 0.005. And this is our standard. We will practice this more tomorrow. We look and we do this. After we create our standard, step 1, find highest R squared adjusted. Step 2, subtract 0.005 from it. Step 3, start with order 1 and keep increasing as they pass. Okay, so as everyone sees, step 1, find the highest R squared adjusted. Step 2, subtract 0.005 from it. And then you look here. Is this number right here greater than that? Yes or no? Is it greater than or equal to? Does it meet this standard right here? Is this number right here greater than? So we need to, or excuse me, wait, my brain just broke. So we can, this right here, it's not. And so with this right here, we will continue on to the next one. And the next one right here, we are going to continue on again because we do not meet the standard yet. And then we continue here, and do we meet the standard? Do we meet the standard right here? Do we meet the standard of having at least this? We do. And that's when we stop. So when we finally pass this standard, we stop. So let's try the next one right here, and this will finish class. 1,000 points, last answer. Model 2 not found. Let's create model 2. Okay, so model 2 is created. We can now do it. Could someone tell me the right polynomial order to use for this question? Can someone tell me the right polynomial for 1,000 points to use for this question? Oh, it's so close. Can someone tell me the right polynomial order to use for this question? 1,000 points first person. What is the right polynomial order to use for this question? The last one was 3, I believe. The last one was 3. Well, the polynomial order, Ryan is correct. It is 4. That's on top of your points, Ryan. So here's the steps. Find the highest one. That's step 1. The class is officially over. This is our last question. So we found the highest. Step 1 is find the highest R squared adjusted. Step 2 is subtract off 0.005. And now we ask, does this pass? No. Does this pass? No. And by passing, do I mean is it higher than this? Does this pass? Just barely. No. Does this pass? Yes. You guys want to do one more? Do you guys want to do one more? So it's 3, 4 so far. The first one was 3. Should we do one more? Let's do one more. You ready? Here we go. So, okay. Which one of these is the correct polynomial order? I can just put this on the test. I can say, what's the correct polynomial order? So the only answers are 1 through 6 possible. What is the correct polynomial order? 1,000 points first person. No one's got it yet. Do your steps. Do the steps. Do the steps. I think it's right. I think Henry was right. 1,000 points, Henry. It's 2. Here's the steps. Step 1. What's step 1? We're just reviewing right now. What's step 1? Someone tell me step 1 in the chat. What is the first step you need to follow? Step 1 is what? I'll drop that in the chat real quick. What is step 1? Find the highest. Yep. Take the highest R squared adjusted. So that's the highest. Step 2. What's step 2? We need those steps, especially for the test. Subtract 0.05. And then what's step 3? We have to start from the beginning, a very good place to start. And we see, does this pass, yes or no? And by passing, we say, is it higher than this value? Does that pass that value? We start with the first one. Yep. Does not pass. Does this pass? Is this higher than that number? Does this pass that standard right there? Does step 2? Does 2 pass? 2 does pass. 2 is higher than that. So that's where we pass. Yep. Does that make sense? Let's do the last one. Remember, this is just bonus. We're just doing work. We're just learning this concept. We will review it in the notes, but we already got to it today. So if you're like, he goes over. No, we're just reviewing. I mean, but you know, I can be like, goodbye, buddy. Okay. What's the correct answer here? 1,000 points first person. What is I have to look. I have to like think. Okay, I got the answer. What's the correct answer here? I had to like look at it and think. I had to be like, okay, what's the correct answer? What is the right polynomial order to use? I do like this. This is a great. Yep, Casey. 1,000 points, Casey. Right. Yep. It is 4. Really quick right there. So many random things. So it is 4. And so great job. You might have seen it. If you got that good that you can kind of just see it. Now, which of these numbers do we pick first as the highest? 1, 2, 3, 4, 5, 6. Which of those is technically the one we pick according to step 1? According to step 1, which number? 5. Yep. We pick this one. Emily, 1,000 points. Thank you right there. You're first on that one. We pick 5. What do we do to this now? Step 2. What's step 2? And these are good notes to have. What's step 2 right here? Yep. There we go. And then we look to say, does this pass? No. Does this pass? No. And does this... It was 4, right? Does this pass? No, this passes. That's when we finally pass on 4. You always start from the simpler model. And Andrew's in the chat. What's up, Andrew? He might be willing to tell you about a little Occam's razor, which we always try to use the simpler model. So the goal here is to use the simpler model when we can. So even though 5 was the best, 4 was basically as good as it. And so it's a simpler model that does basically as good as the 5 variable model. And even if we use Akaike's information criteria, Akaike, a very famous Japanese statistician, one like he, when you here, let's just I gotta talk about the gentleman. And he taught Humphreys Bosdogan. So Dr. Akaike, he Hirotugo Akiyime. I wish I had met the guy. Super. I mean, yeah, is that him? Wonder when that was taken. But Dr. Humphreys Bosdogan, one of the professors in our department, is a pupil. I tried creating a for loop for Q1. Oh, let's take a look at that. Oh wait. Really good question. Let me take a look at this. I bet I can fix it. Look at that. But Akaike's information criteria, there are over 170,000 scholarly articles and book that use his Akaike's information criteria. In April 2016, it had 17,000 citations. It's the 73rd most cited research paper of all time. So that's completely awesome that this guy has the 73rd most cited research paper of all time. Like, and they say it's like cited so often that people, if I got 1,000, sure, why not? I think you got it at the end there. I'm like, sure. I feel I get more generous at the end. Okay. Okay, I think I see the issue. So, okay, I think, okay, you're saving it as X. You're going to print X. And so when this runs, you're taking, wait. This is going to be an issue here. This is rows 1 through 2, columns 3 through 5. So you would want to do something like this, but I think there's going to be an issue. What it is the whole thing right here. You should just be able to do the following. You don't want to do it there. You want to go, and you could just go 1, 2, 4, 5. That might work. Error unexpected. Well, let me see. Oh, wait. I think it's this. And then that needs to close. Good. Yeah, look at this. There we go. Because, does that make sense, Alex, right there? Great job, Alex. Like, great job on, yeah. It was just, you just want this to change. You just want this to go through 1 through 1, 2, 4, 5. But man, Alex, another 1,000 points, Alex, on top of your thousands. I'm so glad you're thinking, how can I do this as a for loop? You're definitely thinking, yeah, and it's just small. And great, you wrote the whole thing out. Yeah, no, great job. You know what you could do? Because wait, what does it want you to do? It just wants you to make each model, right? So what you could do, watch this. Let's change this. Let's go here to list, and let's create a list, and let's go model list. Watch this, Alex. So let's create model list, and let's go to model list position I, and I believe we could still print the summary of model list position I. We might be able to still do that. I've never really tried this. Let's see what this does. If it works, it works. Ooh, it looks like it worked. Well, it gave us a different summary than what I want. But if you go to model list now, model list has in it, well, there's the model, but because cool, there it is. That should do it. Okay, that should do it. So now, there we go. Here, Alex, I'm going to put this in the chat for you. But now you've stored all your models. Whoops, I just hit V. What did I do? Does it still work? Let's see if it still works. So I hit random buttons. And now you could go summary of model list 1. There you go. And there's your summary of your first model list. Let's see if this drops all in the chat. Ooh, just barely. Grab that right there, Alex. Does that make sense, Alex, what I did to all this? I created a list of models, and I'm trying to get better at what I do. So I'm trying to make it so like you can, that's storing just different models in a list of models. So you've got just here your different models, and you can just store all your models and like this. So you could just literally go down here and go through your third model, which there's no third model. There's a fourth model and a fifth model, and you could fix that up. Yep, and then, but it prints them to the screen too. When you run this, here, I'll show you. It still prints them to the screen. So you can still just print them to the screen like that. But now you've also got them stored in a list of models, which I kind of like right there. Alex, great job. You're making me think, how can I make this better? What can we do? You threw it into a for loop. I added a list to it. So we just got different models in a list, but that's what we do. And this is how you get elements out of a list. Like this is the first item, the second item in a list. So it's like double brackets. And I don't know, it's got to practice. It's the way we learn. I will be back. See everyone in 5 minutes here. See you, Andrew. See you, everybody. 5 minutes. Be right back. Hey everybody, we got everything all fixed up. Eggs with chorizo and salsa, breakfast, burrito. Oh my gosh. So, good morning. How's everybody doing? We're going to start off. Where did I put it? Where did I put it? Here we go. We're going to start off talking a little bit about grades. Well, one, good job. The take home was really tough. There was, and feel free to email me. I put how many points you lost. So I tried to, it was, I didn't go as specific, like, here's why you lost points on this, here's why you lost points on this. Man, I should have put that in because a few people have asked me and I've sent them the reasoning. So if you're wondering about anything specifically, like I think some people know if you left something blank, you hey Kelsey, what's up? If you left something blank, then you generally lose points. And I think a few people kind of knew why they lost points on some, like, oh, extreme jump, I just couldn't get to work, but you put in some work, so you got like 2 or 3 points. You enjoyed 1920, nice. Yeah, and for some people got those and didn't. Me, those were the tough ones. And I think there was a small curve on the take home. And then the in class, I think, had like an 80. So I did curve the take home up a little bit. And so the take home got a little bit of a curve. And the biggest thing is, if you're wondering how you did, and I just wish I could show you how I graded it because it was kind of cool. I created a function that because I can't do it without like showing grades. So what it would do is it would prompt me. I created the key for your exam, and then it would go through and it would look to see if what you had matched the key, and then if it matched it, it wouldn't do anything. It would do if it matched nothing else, it would show me it would show me what you had, and it would show me the key. I wish I could get it to print your code too, but it would show me what you had. It would show me the key for it, the answer for it, and then I would look and try to figure out how close you were, like how close did you get? And then I had consistent things I did across, like if you had this mistake, I took off this many points. Like one of the biggest mistakes, I think it's question 3, probably one of the most common mistakes, was an early on mistake. It asked like how many unique levels there are. It asked how many unique levels there are, and it said do not include NAs, and a lot of people included NAs. And then another mistake there too was people reported the vector but not how many. A lot of people didn't do length of the unique, and then if you could do -1, or you could remove you can't do, there's no NA dot remove. If people email me about that, and there's no NA dot remove on unique. NA dot remove is not part of the unique, but feel free to ask why you got something wrong. That's a very big thing. But one thing I want to point to is the following. Now, this says 320. It includes 474. So what I'm doing here is I'm loading the data I created for the class. Then I'm going to here, and I'm turning the class into a factor because it's words, so it's getting turned into a factor. Here's where I'm removing the names, just so we don't have names in there at the moment, because the first column was the names. And then here, I'm creating a regression model trying to explain so this is descriptive statistics. We're not doing predictive. We're just doing descriptive right now. I'm explaining the average in the class with your time spent watching and the class you're in. And I'm very happy to say that the coefficient is positive. The coefficient for time spent watching, this is how many hours you watch, is positive. Now, this doesn't mean if you watch longer, you'll do better. Because unfortunately, don't worry, sorry if it's you, sorry it's you. Like right here, I just feel bad. Like this person has a lower average than they would be expected to have. This person is actually drastically taking away from the model's descriptive ability because they're very far off the line. But still, there's a general linear trend with the data points that follows a positive pattern, and still with 320 and 474. So what do we notice? 2 individuals who are otherwise identical, who differ in how long they watch by 1 hour, and this gets into your guys' next assignment. 2 individuals who differ by how long they watch the class by 1 hour are expected to differ in their overall averages by 1/3 of a point. So what does that mean? 2 individuals who differ by 3 hours in how long they watch the class are expected to differ by how many points in their average? 2 individuals who differ by 3 hours in how long they watch the class are expected to differ by what? Just take this right here and do what? You got it, Ahmed, right there. Both Ahmed and Anisha, 50 points each. We'll do 200 points today. Might go crazy with the points, who knows? But this right here, and I took the time you spent watching. And also, you'll notice there's a difference between 320 and 474, but watch this. Let's go to the next model. In the next model, this is how you did on the midterm, and it's still a positive linear relationship we see right here. 2 individuals who differ by 1 hour, who are otherwise identical because we have to say they're in the same class, are expected to differ in their midterm scores by nearly half a point. So 2 individuals who differ by 1 hour in how long they watch the class. And we still have an individual over here they're behind my head. This person right here was drastically off the model, but still, and they're at 30, right? If we remove them, which we can't just remove them, we can't just take things out, but this person's definitely altering the model, and the slope would be bigger, don't worry, but you can't pull data points out. They just don't follow the trend, which is what happens with data. But it's still statistically significant, and it's still half a point that we notice differences we would expect between two people who differ by 1 hour in how long they watch the class. If you don't watch the class at all, for 474, we'd predict you to make a 77. So for people who don't watch 474 at all, it'd be a 77.5, because we would add this on. If you notice, it hits down here right at 77 or so. For 320 students, for students who don't watch the class, we would expect them on average to make, and there might be some nonlinearity. Actually, you know what? I think it passes everything. I hope it's showing all the points, but 320. So what does this tell us? Watching the class is statistically significant, and we would expect between two people who watch the class, the people who watch the class more, to get higher grades. Now, here's the thing, it doesn't show cause and effect, because maybe the people who watch the class are just the people who work harder. Is it that they watch the class? It's not an experiment, so we don't know. But I just wanted to point this out. I wanted to run the numbers on it. And here's the biggest thing. Let's go to the syllabus. So we're going to hop over here to the syllabus. We're looking at chorizo to start class today. If you don't like chorizo, you can. Who doesn't like chorizo? It's one time, gosh, it was like something like 2 decades ago. I was like, what is this chorizo? And they're like, it's spiced sausage. And I was like, oh, I'll try it. And I tried it, and it just changed my world. And now whenever I see chorizo on the menu, I'm like, okay. And I got bummed. One time I had it, and it wasn't spicy at all. It was very, very bland. And I was like, this is not chorizo. It's got to be like, it's got to have some good taste to it. Anyone else fans of chorizo in the chat? Am I the only person? It is so good. Let's go down here. Here's Brian, hopefully giving everyone hope. So you crack me up. 50 points right there, Casey. So there we go. Hannah, 50 points. So here's a big thing right here. I want to point to this. So this part of the syllabus, never had it. Give it a try, Jacob. See what you think. Always try new things as long as you're not a vegetarian. I mean, it's okay for vegetarians. So give it a try. Try some chorizo. If you like it, you like it. If you don't, you don't. Then you find out. There's things I don't like olives. I don't like olives. They're ugh. So one of the big things I want to point out is right here, that the Respondus exams are worth 17.5 and 12.5. So please take a note that if you did poorly on on the first Respondus exam, you can make up for that by doing well on the second Respondus exam. So do not lose hope. The worst thing to do in this class right now is to be like, well, didn't do well on this, can't do well. Please be reviewing the notes, be reviewing the lectures. Let's do this right now. Who did well on the Respondus and wants to give tips for how to do well on the Respondus where you have to answer the questions? Who maybe there were people who got hundreds on it. I think there was 2 100s. Who did well on the Respondus? I'm going to keep non-memorable. And wants to say, like, here's what I did that helped me ace the Respondus. Who got a good A on the Respondus? Or you can do me, B+. Watch the Kahoot. Yeah, I try to make the Kahoots like the Kahoot. Hopefully that helped a lot. So, and this gives me good advice to like, I'll try to put the Kahoot was super helpful. Anything other than the Kahoot. I know. And then I know you guys had the harder take home. The PowerPoints. Yeah. The notes in the class. Yeah. So, if you keep taking notes throughout lectures, the Kahoots and the notes and the PDFs. Yeah. So there's some really good advice from everybody. If you're looking for advice right now, the advice for the Respondus exams are, if you're doing well in the Kahoot, once again, I take my questions with the Kahoot. Previous class notes, I would write down any questions you said. Important, yeah. And I try to, please, if you want me to do questions, put them go to the Discord, and in the Discord, put questions for the proposed questions. There's possible test questions. Take the practice test. Yep, I tried to do that. And I'll try to do this for the final also. So I'm going to be working on the final this weekend. Woohoo! Yeah, I'll do it again for the next one. I mean, you guys, I think it's nice to have a practice test. And I know it's summer. I know it's very busy. Man, I say that because I'm saying it to myself, but I want you guys to have a practice test. I want you guys to be able to see what the test is probably going to look like. So, yes, and I take questions that will be on. The final is next Wednesday, and it'll be due on Wednesday night. We really won't have any new material on Wednesday. We might just be reviewing, and I'll probably talk about some cool stuff. And I think we have a bonus assignment. I think the neural networks is a bonus assignment. So I might not cover much of the material, but it's meant to be a bonus assignment, which you can kind of look through the notes. Like if you're behind, if you had a bad assignment or two, you can do the bonus assignment. And so I might not be able to do all the material on it, but it's a bonus assignment. It's completely bonus. So if we have 3 finals on the same day, yeah, talk to me about it. We'll talk about that. Send me stuff about that. Yeah, 3 finals. Oof. Yeah, send me stuff. Yeah, it's summer, so send me stuff on that. We'll talk about it. We'll see what's going on, and I feel like you shouldn't have to have 3 finals on the same day. Yeah, so let's talk about that. Let's get that. Let's work on that. We got it. Always remember to talk to me about these things. Everything I do, I always offer fairly to the whole class. So especially if you're hearing this right now, if you're another person who has 3 finals, you're in the same boat, Carly, talk to me. So you know what I might do? Maybe we should just do it maybe we should do the Thursday at 2 p.m. thing again, because we will also have the take home coming up here very soon for it also. So there's a lot of work. Like this week's a little bit easier, and then we had a lot of work, and we're going to do activities today to review material. So there will be a take home. I think that the take home for the final is going to be easier. It's more on just model building, so take a sigh of relief. The take home for the final is going to be where the first one was maybe an 8 out of 10 difficulty. I think the take home for the final is going to be a 5 out of 10 difficulty. The take home for the final, it's going to be a good bit easier. So it's going to be a good bit easier. It's way easier to use train. So we got a lot of good news there. We got a good plan for the, so I think the hardest part is the midterm coding. So I'd say it's the hardest. And so what advice do people have for the, what do people have for the take home? What advice do people have for the take home? What advice do people have for the take home? Any advice for the take home? Any advice people have for the take home? Because there's some really great, the highest grade on the take home was a 98, and it was so close to perfect. And so I was very impressed. Because I'll tell you, I made a mistake on one question when I was making the key for it because I didn't read it properly. I think it was like making a subset of a subset, and I didn't do the right thing. And I was looking, and I was checking with student answers and control through the notes. Yep. Start early and utilize previous homeworks. Yep. Read the question multiple times. That's do homework sincerely. Yeah. And that's what we want. And that's the way the final will be too, that if you're keeping up with the homeworks, hopefully everything's like, okay, I kind of did this before. I did this before. Another mistake in the later questions, a few people, when they took a subset, they subsetted and they made a vector. And then a lot of mistakes were like, it asked to report like a data frame and people reported just like a vector. So, and do a few questions at a time. Yep. I think that's why I burnt out yesterday, because I was working yesterday from like 8 a.m. to like 10. And please email me if you want more information. Has everyone seen where it is like if you go to your assignment, it'll tell you how many points you missed per question? Has everyone seen where that's at? Do you guys know where to look to see how many points you missed on a question? Because you should see like it says like 2 points off on the good. Yep. Please email me if you're wondering. I'm more than happy to explain it. Just make sure you know, you can go look at that and you'll say like how many points off you lost. I do make mistakes every once in a while. One person's gotten points. I think like 4 or 5 people have emailed me, and one person has gotten point back so far. And so it wasn't that big a mistake, but I was like, yeah, you get a point back right there. So I'm always open to giving a second look. I did grade like 70-ish assignments yesterday, 70-ish take homes, and I take them very seriously. So I was probably spending about 5-6 minutes on each take home. And so that's like 70 assignments. That's why I was grading from like 8 to like 10 last night. And then I made this stuff right here. So once again, I take your grades very seriously. If you see any errors, please talk to me. If you're concerned about your grades, please talk to me. And once again, here's a big thing to remember is that your best respondist is weighted heavier. So if you did really well in this first respondus, great. Like if you got the hundreds, then awesome. You are setting yourself up for success because you can only have one that's weighted less. But if you did worse on it than you wanted, that can be your lower weighted respondus test, and you can do better. So, which is a good thing. So please, 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 a lot of this is going to be conceptual with the test on the final. Yep, I'm gonna try to make it as similar. I like consistency, and it's been so quick. Sorry, my only regret so far this summer is we haven't done nearly as many activities as I want us to. The final is not really. We don't really go back and do previous stuff. And I'm loading up activity right here as we talk. The final, it's going to do clustering, but it's like you should know basic coding. But it's not like I'm going to pick a question from basic coding and be like, or validation. But it would hurt to lose that knowledge, but it wouldn't, like, someone could do well without going through the basic coding. It would be harder. It'd be way, way harder. It'd be way harder to do it without the knowledge. Let's see. I'm loading up the activity right here. Let me load down all the data sets. Does that make sense right here? Everything's going crazy right here. So not really cumulative. It's not really cumulative, but it's like, it would not be a good idea to forget everything. But you put it this way. You shouldn't be for the final going back and studying everything. For the final, I would not go back and study the start of the class. It's everything from clustering. No, wait, no. Market basket. Sorry, clustering was on the last test. It's everything from, is that receipts -3? That might cause a problem. It's everything from market basket, excuse me. Canvas is being really slow. There's always something off. Today it's Canvas. I don't know if Canvas. Are you going to work on the homework due tonight as well? Yep. We can do some of that. We'll do part activity here if the activity wants to do its thing. I'm like on the page right now downloading all the files as we speak and answering questions, and it's just taking a while to download everything. And the files look to maybe have different names. So I might have to change some file names right here. It's like receipts-3 and receipts-4? Well, let's download the activity and see what happens. Is anyone else having Canvas being really slow? Is anyone else like Canvas is just being very slow for you right now? Like I'm clicking the pages and it's like taking a while. It's either my internet or Canvas, and hopefully it's not the internet because then that causes stream issues. Okay, good. I'm not the only one which Canvas is like just completely being horrible with right now. So that's good news. Good, it's not me. Okay, we've got the activity. Let's start talking through the activity. Let's get the answers up and going right here. Let me see here. Questions. Yeah, look at this right here. Mark 1 if you're in class. Question 2C, you'll need to go through questions 1 and 2 to help generate the transactional data. Here, let me show this on the screen right here for everyone to see. We're going to do activities for the start of class. We'll do some assignment too. But remember, we're going to do activities right now. Very important to be in class to get the answers. So let me pull back up the chat. It's fine for me. Yeah, for some reason for us, it was just being really weird. Okay, you'll need to go through questions 1 and 2 and run the code there to get the transactional data. Enter the 10th most frequently appearing item, respective capitalization and spelling. Enter the prior probability that a transaction involves hot coffee. Because of how this is encoded in Canvas, you'll need to write the number starting out with 0, then continue it for 3 more digits, truncated, do not round. For example, this would be right here, would be this. Pretty standard right there. So we need to load in this data right here from this coffee shop. So we've got 75,000 from this bakery shop, and we're going to get the code right here. We've got receipts, and I'm wondering if, there we go. Let me go to session, set working directory, choose working directory. We're in downloads. Okay, I think it was receipts-4, receipts-3. There we go. For some reason, the file was different names. There's the receipts. There's the products, those loaded in. Make sure, is everyone getting this loaded right now? When I loaded up the files, they came in as receipts-3. Sorry, that's going on right here. Let me see. I'm going to change it on Canvas because I don't like that. There's Dr. Akaike. And let me go in. Is anyone else having any issues with the file names? For some reason, when I went to download receipts, it came down as receipts-4, which it's showing that right here. Let me change that. And let me try to add it in files, receipts. I'm going to try to fix this right here. I don't like that it's looking like that. I don't know why that happened. Receipts. I think sometimes we just upload stuff multiple times. LMNOP. Here we go. Receipts. Receipts. Oh my gosh. Okay. Whoa. Did that just get overwritten? What is Canvas's? Oh my gosh. Receipts. There we go. Is retailer, receipts, product. Okay. So, is this? Ooh. That's retailer. Okay. I think everything is accurate. Now, how are we doing? Do people have the files? Do people have these loaded in? Yours loaded fine? Okay, good. Then I'm just the crazy one. Okay. So we've got the products loaded in. We've got the receipts loaded in. And then we're going to create I think everything right here is creating it for us. We're reading in the transactions. We're good to go. Loading up the libraries. Good to go. Please tell me if there's any issues. Everything's loading in for us right here. Load it all in. Nothing's breaking. Here we go. Okay. So what do we have right here? We need to make sense of what this is. 100 points first person. Tell me, what are we viewing? Put this into words. What is this for your company? What is this for your company? What does this mean? For one of those, a Red Bull. Cart, Jennings, you're right. Blueberry Red Bull this morning. These are the carts. These are the transactions that people, the first person came into our store and bought apple pie ganache cookie. The second person bought a coffee eclair, apple pie, almond twist, and hot coffee. Well, we got to be talking about this in the morning. 50 points, everyone, giving the answers right there. That this is a cart. These are the second cart, the third cart, the fourth cart, the fifth cart, the sixth cart of people. And we just got to be talking about like vanilla frappuccino when Brian can't get a vanilla frappuccino. When the world gets back to normal because wave 2. Haha. Okay, I'm going to stop thinking about that. Anyway, sorry. Item frequency. I think they wanted us to do the item frequency of, we've got the transaction data, which we should, boom, right here. And this is all the item frequency. Can we just sort this? Can we just go to item frequency sort? Can we sort it? Of course we can sort it. Can we go decreasing equals true? And there we go. So now we've taken, I'll drop this in the chat right here, but we've taken and we've sorted the frequency of the items. There's an item frequency plot. Let me see if I remember the code on that one. Item frequency plot, and there's a horizontal in here. It's like horizontal equals true. No. Can't remember the thing. We should, it won't be, let's do top N. I always hate it when these don't have, oof. So I don't know some of these off the top of my head, like the, so I don't know the, it's not a capital. I hate it when you pass an argument and it doesn't, here, I'll finish. I hate it when you run an argument and if you mistype something, it doesn't give you an error. Maybe that's the error. But their top N is not a graphical parameter. So we do top N there. And it is working now, but it's giving lots of warnings messages, but it's got it. You can see right here in our item frequency plot, or item frequencies, we could just do the top 10 items. So let me move this a little bit more this way. So here are the percentages, and you see coffee, eclair, hot coffee, and everything going right here. Does this make sense what's going on? That I've got in this line of code right here, the item frequencies, and in this line of code, I'm getting a plot of them. So you can see berry tart, and berry tart is right here at about 8%. And we should get, I wanted to see, there we go. That's fine enough right there. Item frequency plot, ooh, let me take it right here. I like this. Andrew, 100 points right there. And I think that's out of the notes. There you go. And I don't know. Depends on how you want it. There we go. Just depends on how you want to view it. How do you want to view the item frequency plot? Do you want to see 30? Do you want to see 25? So it's a lot going on right here, but I'm going to go inside of here and go to 20 just to change the view. Does everyone understand what this code we're doing does? Is it shows you the top item frequencies where you could go here and go to like 100 and get something. Oh, there's not even 100, it looks like. But you can change this according to how many items you, whoa, there's not 400, so you can't do that. There's 40. And so we can view the top items and their frequency to where you can see things like pecan tart. I don't feel like the blueberry Danish sounds awesome. I don't know why people are not buying our blueberry Danish. So do people understand the point of these codes? We don't just code to code. We code because there's a reason behind it. Why are we investigating the item frequency right here? Well, this just shows us the values of this right here. We can also see if we were to times this by, let me go to transaction data frame. Where's the transaction data frame? Here, we'll just run it. The transaction data frame has in it this many carts. So, and there's only 50 items. So if we were to go to here, we could take all of this, and let's take this whole thing right here, and then multiply it by this. And that tells us that coffee eclair was bought 8,193 times. Why did I times it by 75,000? Because there's 75,000 carts, and now I know how many times coffee eclair was in people's carts. Is this making sense right here, that I took the percent, multiplied it by how many carts there were, so I know how many carts had coffee eclair in it? So you always have to think, what am I doing and why? What does this mean? You don't just run code to run code, you run it for reasons. So that's what we do. And so let's take a look. We've got the question on the screen. Let's see what the question said. I'll pull it up on the screen for you guys to see. So there's the question right here. It says, enter, oh no, you'll need, enter the name of the 10th most frequently appearing item. So we can get that right here. It's berry tart. And make sure you spell berry tart correctly. Just literally take berry tart like this and copy paste it. So we need berry tart. And then the second question is, we should have done that as a numeric entry. I don't know if I can fix that right now. Oh, good. We entered more answers, so you can't really get it wrong. The second question is, enter the prior probability that a cart has hot coffee in it. So I don't know if hot coffee was in, oh, there it is right here. So let's remove this. And there we go. Now, one of the things you might want to do, and I will say this, you can get it correct right here if you enter in. I'm going to put a round on this. Don't worry, it says truncated, but we've corrected it so that you can't get it wrong. So don't worry, that's a correct answer, and we'll accept multiple different versions of this. But that is the answer to the first question. So we should have that question entered, and we're ready to go to question number 2. So here's where we start to get into a lot of the ones for the homework assignment, and I'm going to need some help from everyone in the chat. We are going to take a look at this question right here that says, enter the support of the items coffee, eclair, hot chocolate. Note that this is a different item set than what was referred to in the practice problem. Okay, so all we need to do here is figure out what carts have in them those two items. So I'm going to copy paste this vector as is. It's going to help me spell it. And you know what you could do? You could call this items. And so now we've created items. Now I want people to have both of those items in their cart. 100 points first person who tells me the connector that we are going to logically use. And there's lots of ways to do this. What is the connector we will use to see if people have both those items? Not that they have one. That's formula format right there. Good guess. 100 points right there, Madeline. We want some sort of connector. No one said it yet. No one said it yet. 1,000 points first person. This is a review question. You have to go back to, yes, Ishan and Jordan, you both get 1,000. Crazy points today. You're right. It's the percent AIN percent. And so we need to go here to sort, not sort, subset. And we're going to subset the transactional data frame. And I think we say, is it just items? I always forget. I always have to like take a quick look. I think this will work. And I named it items. That's where I'm like, wait, we'll do here. Let's see here. Oh, it did it. Cool. It is items. Because you have to know it knows to do items right there. And you have to do items percent IN percent. And so we should have right here the percent of carts that only have these things. So let's go to sub. And this is our subset right here. We went to our transaction data frame and the items have to be here. Now remember, my items is merely just this. So that's what's right there. That is what is right there. Now we can confirm this by going to inspect, and let's inspect the sub, and you have to go to inspect sub 1 through 10. Now, if you notice, what do the carts have in it? We should see. Let's cross our fingers. Coffee eclair, hot chocolate. Coffee eclair, hot chocolate. Coffee eclair, hot chocolate. Coffee eclair, hot chocolate. And these are the cart numbers right here, which are different cart numbers. But every single cart has to have coffee eclair, hot chocolate. Do they all have the same thing? Okay, good. They have different things. I was like, that's worrying me. Coffee eclair, hot chocolate. Coffee eclair, hot chocolate. So every cart has to have coffee eclair, hot chocolate. Now, if I change it to this right here, the cart only has to have one of those items. Now it only needs hot coffee. And we won't do PIN, but PIN's a partial match, which we could do like coffee. Well, why not? I finally figured out what PIN does. PIN will do, if we do like coffee, and I think it has to be spelled with the capital letter we figured out, it'll find any carts that have some sort of coffee. Like this cart has chocolate coffee, this cart has coffee eclair. So any sort of coffee item, it's a partial match on the word. It has to have the same upper and lower case, but any cart that has any sort of coffee has to have a capital C. We can confirm this by going to lowercase c, and now we get nothing. So you have to have some sort of coffee in your cart for this partial match. Now, OIN is only coffee. So we have to pick something someone would have only something of, like coffee eclair. And OIN will only be that they have coffee eclair. And do we have any? Yeah, and these are the carts. So if you notice, OIN means they only have it. PIN is a partial match. AIN means they have to have all those items. And IN means they could have just those carts could be in the cart. So the ones you really need to know for the assignment are AIN and IN. So AIN means they have all the items, and we saw this previously. We'll go way back in time right here to AIN is going to be they have all those items. So these are the carts that have all of those items. They have to have coffee eclair, and they have to have hot chocolate. And to differentiate between that, we would have IN. And IN right here means they could have any of those items. Because now this cart right here has hot coffee, but it does not have the chocolate eclair. It does not have the coffee eclair, excuse me. It's hot coffee, but does not have it. Do people think they understand the difference between IN and AIN? Those are the key ones. I know I showed you more because it's kind of neat to see the other ones, but do you think good? That's the key thing you should know right now is that AIN means you have to have both those items. Do you need a specific library to run AIN? A rules. Yep. A rules. Make sure you've run your A rules. A rules is specific to, and here I'll show you right here, A rules. AIN is in the A rules package. So great question right there. Sarah, 100 points. Thank you for asking that. If you do not have A rules, you do not have AIN, IN, OIN, PIN. So, and I finally understand all of them. I'm like, yes, I know what they are now. AIN means you need both items. Perfect note in the chat right there. 100 points, Madeline, right there. Up to 200 points today. Keep it up. Keep talking in the chat. Remember, you get those points for watching and interacting. So, well, the answer to this is just going to be, does it want how many cards or what percent of cards? Here, let's just double click sub. That is, there's 13,000. Wait, let's make sure we're doing the right one. I think it's the wrong one. Yeah, there we go. 2,367. If your A rules viz won't load, make sure you've run. Make sure, yes, Ahmed, 100 points. Make sure on that. If there is 3 in the C, will it take them all? Yep. Adam, great question. Like if we put a blackberry tart right here, and so we can go to blackberry tart. Now these are carts that must have all 3 of those items. So now every one of these carts right here, we'll only look at the first 10. Whoops. So now we're only looking, Mary had to do inside the inspect. They have to have coffee eclair. So here's the coffee eclair. They have to have hot coffee, and they have to have blackberry tart. So every cart has to have all 3. If you do IN, they can have any of the 3. Does that help make sense of that, Adam, right there? That AIN, they have to have all 3. And you can do more than just you can do as many items you want, but they have to have all of them then. And, oops, printed that screen. So I think that's the answer to this question. And we kind of did some good review of it, and definitely this would help. How many different items? So we should see, oh, it wants a percent. Okay. Was it 75,000? Sorry. There's the answer. Yep. So 100%. And yeah, and then it wants it rounded. So it wants this rounded. So the answer is literally, that's the answer. So if you're, there you go. Make sure you see this right here. That's the answer to this question. Everyone should have it right here. There you go. Yep, people are getting it. There's no ggplot2. So if it says no ggplot2, install.packages, ggplot2. So if it says no ggplot, it says no ggplot2. Is it ggplot2? It is ggplot2, isn't it? There you go, yeah. Just make sure to install it. If it says no package this, then run install this. Does that make sense, Hannah, right there? Every time it says no this package, install that package. So, yeah, I wish it would do the packages for you, but it's like, I don't have this package. Like, well, why don't just install it? Just install that package. But good job, Hannah, right there. 100 points, Hannah. Thank you for asking. That's what we do. Whenever we're stuck, we just say, hey, this is not working. We get it fixed up right there. We get it fixed up. Let's take a look at the next question right here and do another market basket analysis. We did this in my master's class, big thing. We only got 3 more questions on here. Enter the largest value of the support among the 8 rules that met the specified condition for 3D. So now we need to do the a priori learning method. This is really good review. I'm glad we're doing it in this order because this is going to be really good review. The a priori learning method is how we narrow down our rules. So we have inspect a subset where at least one of the vanilla or frappuccino soda appear on the left-hand side and the rules have at least 90% confidence. Okay, so the a priori learning method, I might try to write it out from scratch today. The a priori learning method takes, and we store it into something, so it's going to store into something. So we got here rules, and we'll just call it rules because we're just making a set of rules. First thing we take is our transactional data. That's the first argument, is the transactional data. The second argument is, I'm going to forget the last because it's the control. The second argument is the rules we want. So the rules we want here are that it has to have at least 90% confidence. So we should be able to just write confidence, if I could spell. And that's the one thing I hate. I hate when autocomplete doesn't kick in. Confidence greater than 0.90. Does at least 90%? At least. So we need greater than or equal to. Now what you can do to check to see if this works, and let's do one thing here. Now we're leaving the conditions part of it, and we need to do control, good, equals list, verbose. Is it just verbose? Is it verbose? And then it's false. We'll see if this works. I can't remember. I don't want to cheat. I want to try to write it out from scratch. I can go look at the notes. Confidence. So it doesn't like the confidence. And yeah, so let me just take a quick cheat right here. We'll take a quick, let's go see, because that's always the syntax of this one. I just forget sometimes. Let's go look at the syntax. Market fast association rules. Okay. So a priori, and there's that. We'll open it up as a function. Oh, a priori. What? Oh, I didn't put the I. If I could spell today, that'd be good. And parameter conf. Yeah, I just wish the autocomplete would kick in on that. And then control equals list, verbose equals false. Got that. Okay. And so it's conf. Did someone say in the chat? 1,000 ways if someone corrected me in the chat. I bet someone did. Let me look at chat. This right, was it parameter? Did I mess that up? I bet I did. Parameter equals. Ooh, that's what it is. That's what it is. Parameter equals list. There we go. That's why I take a look at it. And control equals list. The parameters is a set of lists. There we go. This should work right here. Jordan, 1,000 points right there. Jordan, thank you for correcting me. Okay, conf not found. What did I misdo? Let me copy paste the code. The syntax of this one, I don't use it nearly as much. There's parameter equals list. Where's the syntax error? Where is the syntax error? There's that. There we go. Same thing here. Same thing here. Parameter equals list. Confidence. Oh, you just do this. This at the end. That should be all right. So there we got the graphic error. We're good. And then we're going to add another rule. It was the greater than or equal to. You just say what you want at least. So this ends the list right here. And I wonder if, because you don't need a list right now, I bet this would work. If you just did parameter equals this, it might work. It doesn't like it. It wants it as a list. This is the way the function's meant to run. Cool. if you don't enter a function in the correct way, it won't work. And so now we've created these rules right here that have at least a confidence of this. The reason we do verbose equals false is because it'll just print this off to the screen right here, and we just don't want that output. I guess it's not the end of the world. It did super quick, but that the verbose equals false just removes that extra output. It just, what do we do if the parameter is not found? Double check the writing. It should, there's different parameters you can use, like SUPP for support. So you got support, you've got min length, max length, and support and confidence. So double check the way it's written right there, Sarah. Does that make sense? Does it say like a certain error is saying it's not finding it, is it? These are the different parameters you can use right here. Make sure it's, does it fix, Sarah? It must be a typo, probably, it seems. Very small typos. And that's why, once again, I don't use this code as often because I don't do a lot of market basket analysis. I do more predictive analytics in what I do daily. So I forget, like, okay, the parameters need a list, the control need a list, and then I forget. I just wish the autocomplete, because if you type con at, see, it doesn't show you conf. Ooh, maybe it does. Well, it doesn't have the equal, but the autocomplete's your best friend, and without autocompletes, and I was like, wait, what? How do I spell that? How's that look? And so you might say, wait a minute, these rules right here, we don't have enough created from it yet. What you'll notice is we have that at least one of vanilla frappuccino or cherry soda appear on the left-hand side or the right-hand side. So we'll do right here where we go and search for left-hand side, because we can do a subset of the rules right here. And look at this. We're just going to take this code right here, and we're just going to augment it. So inspect subset rules. Maybe that's got it. Let me take a look at that code right there, Andrew. We're going to take Andrew's code. Oh, no, Andrew, I was gonna take that code. Because we've got here that the left-hand side has this. And here, let's see. Let's take a look at Andrew's code. He might have it. Great job, Andrew. So remember, the answers are posted, but it's good practice to do it. Inspect. Here, we're going to break this apart a little bit. He's got a subset right here. And here's the condition. That's the first condition. And then he's got a second condition right here, which I guess you can do it without doing the a priori. Yeah, that might do it, Andrew. I'm going to do it a little differently. Inspect, Andrew, 1,000 points. Thank you for that. Inspect a subset where at least one of vanilla appear on the left-hand side. Yep. So Andrew's doing this by taking the rules, and this should work. And we don't get any, I'm not getting anything. Hopefully, did yours produce output, Andrew? Because mine's not. Hopefully it's not being weird. Let's take a look at the rules. Set of 0 rules. Uh-oh. Uh-oh. Parameter, confidence. Let's change the confidence. Set of 3 rules. And is significant. Well, something weird's happening right here. Because the transactional data frame, there's that confidence equals this. Let's see what happens here. Something's weird. 3 rules. Someone's going to say it. What does a priori limits the amount of rules? And something weird is happening. Let me just grab, because it's only giving the, do we need to enter in a min support? Maybe it wants that. So it's saying do all this right here. We might need to do all this. Yeah, I think we need a support for it. Oh, is that what you, yeah, you went through and did, oh, it does say, see, I should read through the question. I think the only thing I'm missing is a confidence of at least 60%. There we go right there. And then Andrew's removing out the redundance and everything. I'm going to grab Andrew's part. So the a priori limits the amount of rules that you're looking at. That's the whole point of the a priori learning method. And so let's grab this right here. We did this a previous class or two ago. And it wants more right here. So we're going to do a confidence of at least 60, like it says. We're going to do a support of at least 100 out of the carts have it. And apparently it doesn't like it if you don't enter in these parameters. We should be fine on the min. Does it say a min or max length of the rules? So I don't think it has any rule length on it, which we should be good on. So let's go ahead and run this. Let's look at how many rules we have. Now we got 102 rules. Is that how many rules you're getting, Andrew? And then we remove out the redundant. We only keep the significant. And we have 102 rules. Usually redundant and significant are not issues, but it looks like we're good. Are you at 102 rules? That should be what we are at. So we should be at 1 or 2 rules. Let's drop this in the chat right here. Yep, 102. Good. We're at the same thing now. So, and we could have, here's what we can do though. We can go to 90 And this should be fine too. We should just get rules that have 90% support. These are the rules that have at least 90% confidence, excuse me. And then we're going to go here. We're going to take that curd code we wrote a moment ago, and we're going to drop it in here. And this is just going to be a subset. Let's just call it sub again. And we're going to go to the left-hand side. Needs to have either of those two items. So vanilla frappuccino or cherry soda appear on the left-hand side and has at least 90% confidence. So here we are with this right here. So now that should go away, good. What does verbose do again? It limits the amount of output. So watch as we change verbose to true, and you'll get more output here. This is the extra output you get with verbose. It's like it kind of talks to you more, so then verbose equals false will not put out more output. So the verbose just controls how much output there is. Preference to not see the output. Good question, Ishan, right there, 100 points. And we have the rules right now. We have the subset. Rules not found because the name there is different. We have the subset now, and the subset has in it one rule. One rule? Is that it? For how many rules we should have? Note this is a different... Wait, let's go back and look at the test question to see if we should have one rule. Enter the largest value of support among the 8 rules of the specified condition. So inspect a subset where at least one of vanilla frappuccino or cherry soda appear on the left-hand side, and the rules have at least 90% confidence. Oh my gosh. Yep, that's the issue right there, it looks like. So now, yes. It's always a typo. Let me drop this in the chat for you guys. Once again, the answers are posted, but the issue is I didn't concatenate. Thought I had to sneeze, but then I didn't. So every time, yeah. The issue was I didn't concatenate this vector right here. The faster you work, the more mistakes you make. And it's so easy to not concatenate, and it just created havoc in the code right there. And then it wants the what of the rule? Let's see right here. It wants the enter the largest value of support. So what do we have to do to take a look at the rules? First person 100 points. What do we have to do to take a look at these rules? What do we do to take a look at these rules? How do we take a look at the rules? The last rules I get, set of 0. Let's take a look. Andrew, 100 points right there. Inspect these rules. So there's the rules right here. And those are pretty large. So if you look at, we want the highest, I think it was the highest, which was it? Let me take a look at what did it say? Enter the largest value of support. So you could sort them by support. It looks like this is the largest value of support though right there. So that would be the answer. Let me double check it and then I'm going to answer the other question. Yep. And the answer is going to be this rounded up. Let me put in a second answer though, just in case. So that way I'm going to enter a second answer here. I don't want people to get it wrong and be like, I was so close. Okay, there we go. Update question. Let me save it. So there's a second answer in there now, just in case. And I think Madeline had a question too. Let me see here. So wait, it was back here. No, wait, I saw a question. What does Bros do? The last rules I get a set of 0. So Sarah, when you are doing your rules, when you run this line of code, do you see the right amount of rules here? Do you see that there's 73 rules? When you run this, you should still have 73, I believe. You still have 73 rules. How's that going on that? Do you have 73 rules from there to there to there? Does that all work out each step of the way? Do you get 73 down to this spot right here? At this spot, you should have 73 rules. And then this right here is making a subset of the rules. You got 102 at the beginning? Oh yeah, because we did this right here. So if you did this, you'll get 102 rules. If you do this, you'll get 73 rules. So you can already you could do what the question says to do at least 60%, but at the end here, we're going to get at least 90% confidence. So I'm using the a priori to do that right here and creating rules that only have 90% confidence. So I'm using the condition right here in the a priori learning method. And so to kind of review what the a priori does again, is it limits the amount of rules we're looking at. So a priori is like the beforehand learning. So it's like, okay, we are only going to look at rules that have at least 90% confident, apply to at least 100 carts, and that's right there. We're going to only, rules must meet these criteria for us to look at these rules. So do you now have the, I think, 73 carts? So you should have 73 carts, and then run this line of code right here. Run that line of code. After you get 73 carts, run that line of code, and that should have it work out right there. Is that working now, Sarah? Yes, great job, Sarah. Great job. And then always think about, what is this asking? It's like, do we have rules? Which we should look at these rules. Let's take a quick look at the rules. So the rules we have right here, and I hate that the output's so much larger now that it takes up too much of the screen. No, these rules are so long right here. This is saying, given someone has apple croissant and cherry soda in their cart, how does it impact them having an apple Danish? Well, 2% of our carts have all three of those items. We know if somebody has apple croissant and cherry soda, the probability of them having an apple Danish is 90.8%. Don't worry about the coverage, we don't cover that. And 13.4 is the increase in the probability of apple Danish. So apple Danish is 13.4 times more likely to appear in a cart than it would be by random chance if someone has apple croissant and cherry soda. And that's key interpretation. That the lift right here means that the apple Danish right here is 13.4 times more likely to appear in a cart than by random chance given an apple croissant and cherry soda in the cart. So key things right there, understanding what the lift means. So now we get to question number 5. We're almost done with this activity right here. Question number 5. In question 5b, remember to make and refer to rules 2 specified in 5a. So we got to do that. Okay, let's do 5a right here. We're probably going to do some a priori learning because we're making rules. So let's go down to 5a where we want to do the a priori learning method, making rules. Make the association rules so that the support is at least 100 carts and the confidence 50%. Well, guess what? We've already written our code. This is the fun thing about writing code, is you just take and do this, and you're done. And it wants a max length. So I think it's max len. We'll see if it likes it. I wish there was autocomplete. We can cheat and look, but I think that's it. Left arrow the results into length 2. Change that. Remove any redundant rules. We need Andrew's code back here. We're going to take the redundant, and does it say take the significant also? Remove any redundant rules and non-significant ones. Cool. So there we go. And we need to change this right here to this. Be careful. Your code needs to change. And everything there needs to be that. So be very careful. This is the correct code right here. And I'll have to drop this in the chat. Well, let me check it first before I give it in the chat. Okay, so let's look to see how many rules we have. 14 rules. Does it say inspect the 14 rules? And I think nothing will change. Yeah, it didn't change it. That's what I thought. So truthfully, you only need this. It's usually the rules are significant, whether or not. So there's the code right there, and we fixed it up. Once again, that's why we copy paste code. Once you have, and that's why I don't learn the format sometimes. It's like, oh, because now that I've written it, I can just copy paste it, and I just need to know if I want to add additional arguments where I add them. And I think a lot of times breaking your code apart like this makes it way easier to see this is what we're learning on. These are the data we're learning on. The second line right here is, and you could go and do this if you want. Like if you want, you could do that. And then here's your parameters. The comma here after the parentheses separates the arguments. These are arguments right here inside of the list, but this comma right here brings you to the next argument inside of a priori. After this, you've left the list. And I think this is where I also saw mistakes on the take home, is when people were subsetting, they put a comma and they left the condition part of it. So I saw that on the take home, that people were doing subsets, and then they would write conditions, and then they would put a comma after each condition, which caused the subset to break apart. So if you're wondering, like, I wrote every condition, you might have put commas between them, and then that leaves the condition part of the subset. So I saw that on the take-home too when I was reviewing code. What is the significant doing the is redundant? So sometimes you get rules that are the same rule. The a priori learning method will create the same rule. So if a rule is redundant, it'll remove it, and the significant means it has a p-value less than 0.05. And here's the thing, though. When you put an a priori learning method that has decent enough standards, usually everything's significant. So you might say, well, why does this code do nothing right here? It's because we created a subset of rules that had no redundant rules and had no non-significant rules. So we're only taking the significant rules right here, and all the rules were significant. They were low enough to be unlikely by random chance. Sarah, 1,000 points. Keep asking those questions. Thank you so much. That's another 1,000 on top of what you get. But keep asking, what does this mean? Why do we do that? That's very important. I could put these things on the test, like, why do we do this? It's not just about coding in this class. It's like, why do we do this? We want to not have repeat rules. That's this line of code, to remove the repeated rules. And we only want to have rules that are unlikely by random chance to occur. Like, they're actually, we're saying that they're statistically significant. Good questions. And so we did that part. And what does the question ask now? I'll put it on the screen in case anybody is pausing. Oh, it's right here. Fill in the blanks to interpret the lift of this. Report the probabilities in the first and third blanks as percentages truncated to 1 decimal. A probability of 0.4 would be this. Report the number in the second blank truncated to this would be this. Overall, the probabilities that a transaction contains cherry tart is blank, given the apricot is part of the transaction. Okay, cool. So we need to find overall the probability. Oh, it's so hard to see where I'm writing on this. Overall, the probability that a transaction contains cherry tart. Okay, so the probability that a transaction contains cherry tart is the what of cherry tart. 1,000 points, I mean it. This is the what of cherry tart. However, given, I won't do that one yet. So the probability it contains cherry tart. Can you explain what a rule is again, like what they do? Sure, it tells us how, like, item frequency, great job. It's Jordan's right, 1,000 points, Jordan. The rules tell us associations between items people buy. If somebody buys this item, they'll be more likely to buy this item. They could be less likely if the lift is below 1. But we're trying to see, like, the people come into the store, they buy this item, then what are they likely to buy because they buy this item? Like, what associations are there? So the rules tell us the associations. So it might seem confusing, but the quickest way to figure out what's going on here is to go to item frequency. And if we go to item frequency of transactions, and we go right here, and we need to put in the name of it. What was it? It was cherry tart or something? Was it cherry tart? That might be it. So there's the item frequency of cherry tart. If that's what we were looking for, we just found it. It is cherry tart. So with this right here, so enter to 1 decimal place. So I think it wants this to 9.3. So I'm not even look at the answer right here. I think that's going to be 9.3. Let me take a look. And it is 9.3. Good. So that is 9.3, which is the probability that someone just buys a cherry tart. So the first thing we're looking at is just, what is the probability that someone buys a cherry tart? Let's now inspect the rules right here, or inspect our length 2 rules. And we need to look for a specific one. Cool. Didn't go around the screen. We're looking for cherry tart. Is it apricot Danish? I believe it is. Let me look at the thing again. Cherry tart apricot Danish. So what we could do is we can go here to simply this one. Cherry tart apricot Danish. And let's make it very clear that we're only looking at this rule. Got it. So now that we're only looking at this rule, it wants, for the second part of this question, however, given that someone has an apricot Danish in their cart, wait. Oh, wrong rule. We want the reverse of it. Apricot Danish. Cherry tart. Why don't I see it? There it is. There was rule 13. Sorry. And so let's reverse that. Here we go. Given that someone has an apricot Danish, because this is the given part of it. Given someone has an apricot Danish, what is the probability? However, given they have an apricot Danish, part of the transaction, the probability involves cherry tart increases by, yes. Andrew, keep it up. 1,000 points right there. And it wants you to truncate it, but let me just add another answer here. I don't want people to get it wrong because they don't. Like, when I was a kid, I took a test and it was like round everything to 1 decimal, and I think I rounded to 2, and the teacher gave me a 0. That's not right. That's not right. So there we go. So we got that one, and we got that corrected. Good. And then, so Andrew has interpreted that the factor increase is 6.1, 6.2. I've got both answers in there now, I believe. Please tell me if you think you get something wrong just by decimals. And then the last thing here is given it goes to a new probability. So the last part of this is, so what is the new probability? Increases by a factor of this. This right here is the lift. And then the last thing right here is the what. It increases to a new probability of what? So this is the original support of the item. So that's the support of the item right here. Support of the item. So the original probability of cherry tart is this, support of the item. We figured that out with item frequency. It increases by a factor of this, and who knows in the chat right now, what's the last thing? It's confidence. 1,000 points right there, Caroline. Crazy points today. This is really good practice for the test. You can't forget this stuff for the test. We did it a while ago now, but that's the confidence. And the confidence is right here. And you enter that in as a probability. So make sure to enter that in as 57.3 or there's the percent also, or 57.4. So please tell me if you think you get it wrong, but you got it right. I'm just going to add in more answers here to make sure nobody gets it wrong. And yes. So I'm entering more answers to make sure nobody gets it wrong. Well, I hope not. Please tell me if you get it wrong. You're like, Brian, I swear I got this right. Brian, help out. I will help out. Okay. Last question right here, and I'm updating the quiz with new answers as we go, just to make sure everyone gets it right. Don't want the way you enter it in to get it wrong for you. The number of distinct clusters of rules in the graphics, if you can move from one to another along the same set of arrows, regarding of the direction of the arrows. So let's take a look right here and let's run this. This is going to be the A rules viz right here, which is a pretty neat answer right here. And let's take a look. Okay. So this is Q6B. Q6B. Here it is right here. And I think it's basically made for us. Okay. So we need to make this graphic. Okay. Let's take a look. A rules viz. Plot. A rules viz not found. Do we not make it? Make A rules viz. Here we're going to do this real quick. Because there we go. Let's hop over here. Wait. Set seed, A rules viz, plot A rules viz. Say a priori. What I'm going to do right here is I might hop over to, because I tell you guys what, how about, because I've always had trouble writing A rules viz questions on the test. How about, I'll tell you guys the answer to this one, it's 6. But how about, if you're doing it, the answer to this one is 6, because I want to hop over to the next activity. Would you guys like it if I didn't put A rules viz on the test? What's the vote on that? Yes or no? A rules viz on the test, yes or no? We've got enough on the test as is. Unless there's a resounding yes. The answer is 6 to that one if you want. I just want to hop over to the next activity so we start talking about that. But I also removed it. Yes, not on test. There we go. Okay. Not on the test. Not on the test. Let's do that. There's enough with market basket analysis. And I often find that the output for it is very cumbersome for the A rules viz. So I'm like, okay, let's just not put A rules viz on the test. So if you're here right now, you heard it. No A rules viz on the test. So who's got 100 on this? Who got 100 on this activity? Who got the 100 on the activity? Any hundreds? Let's see those hundreds in the chat. Let's see those hundreds in the chat right here. We're going to load up another lab right here. We're going to load up another lab. Because I really want to do some classification stuff. Let me load up another lab. Let's take a look right here. There we go. We're going to load up another lab right here, so get ready. Whoa. Sure, let's keep it that color. Okay. And we should be good. I think we're good. Let's change the due date. This one will be due tomorrow night. You should be getting hundreds if you're here, though. Some people who aren't here are going to be scared because they'll be like, wait a minute. Why do we have so many things due? That's why I come to class, get them done, get these 100s, review. You got 4 and 5 wrong. Hacks right there. Caroline, email me, see with what you entered in, I'll just fix it up probably. Show me what you got wrong. 6, 5, did I change it? 5, let me look at 5 again real quick. I'll show you the answers. So if you're here in class, once again, anytime we're doing activities, it's meant to be like you get them right for just being here. If you are here in class, you should just be getting them right. 2 seconds. Wait a minute. Everything's going crazy right now. Everything's going crazy. What did I just do? Let me do that. Nope. Okay. This one's the one I want actually. Okay, cool. Here we go. Okay. Let's make this one. 2 seconds. We'll go back. And we'll have it open here in a second. Someone's going to be looking at their stuff that's due. And they're like, wait, what is going on right here? What? And then we'll pull up the answers to the other one. And we will do some predictive modeling. This is where some of my favorite stuff is predictive modeling. It's kind of what this class focuses on. Market basket analysis is very unique. It's a very, very important thing to know, but it's very unique to what it does. And let me go back to the quizzes. I think that's got everything we need. And let me go back to the market basket. And people were saying they got wrong questions the last few. Which ones were the ones people got wrong? You got a 9.3 out of 8. Yeah, and there's bonus in these. I got 5 and 4 wrong. Also, when it displays the right answers, which I put. Wait, what? Wait, what? So, which ones are people putting in? This is question 3D. Question 3D is the following. Here, I'll show it on the screen. I'll show the answers because it should accept these. And make sure to enter these in exactly how they are. Question 3D. So there is the 3D answers. Questions. This is a lot to show. Here, I'll just show it over here. Question, the last one, which is only the last one now because I updated the quiz. There's that one, there's that one, and there's that one. Maybe it's because, yeah, that should be 9.3. Here we'll answer some 9.2s also. So we'll put some 9.2s just so people don't miss it. But do people see their error on what they entered in? So do people see, and I put in a bunch of different things here to make sure people get it. These are all just possible answers. 2, 3, and 4. Is anyone, who's got hundreds now? Who's got hundreds? Surely there's someone with 100. We'll go through. You ready? Should have them all. Berry tart. Make sure to enter berry tart as is. Copy paste the name. Here. Copy paste that name. Name 2. Here's the second thing. Any of those work right there. I want people to get hundreds. If you're here, you should get 100. That's the goal. This one, you enter in like this. Here, we'll even do this. We'll do that to make sure. So we'll update it so it has a little more of an error. Here is Q3D. And here is the last one. Make sure with all the blanks to enter in one of those, or one of those. How are we doing? Is everyone good on all these? If you aren't, please rewind the video. All the answers are literally here right now. Surely someone's got 100. Who's got hundreds? Who's got the hundreds? People have hundreds now, right? How are we doing? Wait, which ones did you miss? Got 100 each on. Awesome. Which ones? So definitely 100. Good. Vedrina. Which one were you worried about? And definitely like pause the video if you need or ask. Which ones are people looking at? 4 and the first 2 of blanks 5. Okay, got it. Let's go to the last ones here. Okay. So here we go. 4 is going to be this right here. One, if you it's not berry tart. Don't type berry tart. Don't put berry tart there. Oh my gosh, what is going on? Copy. Oh my, what? Oh, apparently I can't copy that. Okay, there we go. So that's that right there. And then these right here are 9.3 for the first blank. And second blank is 6.1. And the next blank is 57.3. There's multiple answers. So I put in more answers to make sure people would get it. Okay, so that's got it. You lost Q2. The second question is this one right here? Q2 should be berry tart. Make sure it's spelled correctly. And then 0.102. So, and unless you're speaking of this one right here. Got it, thanks, good. And this one right here is 0.0316. So definitely make sure, be putting these answers in, be trying them out as we move along. If you get the right answers, remember, everything is in this video right now. So please. The point is, if you come to class, you get hundreds on these. And we do have some bonus built into this. So great job. 100 right there. That's what we like to see. Attempt 1, 8 out of 8. Attempt 2. Oh, nice. I like that, Adam. I like attempt 1. You miss 8 out of 8. And if there's any, I'll fix up the averages if there's because now there's only 8 points. So we got it. Okay, good. Let's take a look at, we've got more than enough time to go into another activity here. So let's start talking about this next activity. I'm going to shorten it down so we can complete it today. I just closed out a canvas, so let me hop back in. So I'm going to make some changes to this activity, and it's going to go into the next assignment. And I do like that I just want us to have as much time as we can for activities, but remember, we do talk about the theory all throughout class. So theory is so important. We only have 2 more activities. Well, so yeah, we should be good. And problems with analytics. Okay, let me go to the questions, see how many there are. And yeah. Okay, we should be fine. The total number of, okay. Let's do this. We're going to go to solutions today. Solutions. Okay. So the solutions, once again, show you how to do everything, but let's talk about some very important stuff with predictive modeling right here. Do not leave because the questions are going to be still out there. And let's talk about predictive modeling right here and make sure we understand why we do predictive modeling and what it means. So when we do predictive modeling, we want variables to bring with them new information. And I do have, install, sure, restart our GLM net. We're just installing the packages right here. We won't be netting this, so we don't have to worry about these. Oof, that gave a bunch of weird messages. Robust base and PROC. That's used for AUC ROC. Okay, so let's take a look at what we have. We've got a function up here that we're going to run, suggest transformations function. But there's going to be some really important parts right here when we look at our data. Here we go. By taking this data right here, loading it in, we're loading red class, we're getting our census data, we're going to look at a histogram. What is the first thing you notice about this histogram right here? What is the first thing you notice about this histogram? You know what I'm going to do? I'm going to do something super nice. Get ready for this. In your extra credit email, you have to do the following today. You have to email me today and say, Brian, I got an activity. I got 100 on activity 7. You need to put, if you're watching this video, Brian, I got a 100 on activity 7. You need to put that in your email. I will give you the 100 on activity 7. Or it's activity 6. Sorry, don't say activity 7. Brian, I got 100 on activity 6. If you put that in your email, or if you just email me, like if you're watching this now, you need to email me that, and you don't have to do the quiz. I will change it to a 100. Does everyone understand that? So you get the free secret 100. This is like secret 100 if you're following along, paying attention right now. If you're not, you're going to have to go in and do every question. But I'm going to go through the theory on it, and you can still do the activity quiz, but if you email me that, you get the 100. Awesome job. I like to utilize time. So I'm going to talk through the topics on this, talk about what we're doing. If you're paying attention right now, you got it right there. Yeah, retweet, hashtag secret 100, hashtag secret 100. That's what we do right there. So that's what we get. There's one fly that's been here all week. So what do we have going on right here? We have a very, 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 very skewed histogram. So we can do the suggest transformation on it, and the suggest transformation, good, loaded the required package. The suggest transformation, it won't do that now, I don't think. Yep, it's already loaded. The suggest transformation is going to suggest we take the log 10 of it. So we log 10 it, we take a look at it, and what do we get? It looks way more normal. So we talked about this also a few classes ago on how the transformation looks through it. I think it was a while ago. I think it was Madeline, did you ask, or Sarah, did you ask about how fine transformation goes through and it tries to find the one that has the smallest skewness. That's exactly right there, Yaoshi. We try to take this and make it more normal. This is extremely skewed. We try to make it more normal because we don't want outliers greatly impacting it. It literally goes back to 201, QQ straight enough, no outliers. You don't want those outliers. But here's something you may never have thought of, and this gets to the very important next part of it, which is in the activity quiz questions. When you put X variables into your model, in predictive modeling, we oftentimes put in a lot of variables. Even with really awesome computers, this can really eat up our computing power. So what do we want to do? We don't want to feed it variables that are kind of junk variables. So imagine if I tried to explain your grade in the class by how many yachts you own. Go ahead and put in the chat right now how many yachts you own. How many yachts do you own? Like a literal yacht. Not your parents. And someone might feel like one. I'll be like, okay, they own a yacht. But how many yachts? -1. 100. No. See, I wonder if someone says 2, I'm like, You guys are trolling me. You guys are trolling me. I see when someone says 2 though, I wonder. When people say 1, I wonder. So what do you think? Do you have a 14-foot yacht? A yacht, not a boat, a yacht. I don't know. Maybe people do have yachts. How many 747s do you own? You guys are the best. You guys are the best. I love teaching this class because I love seeing the. You guys are just cracking me up. Andrew owns 3 747s. You Jacob, I'm sorry. Jacob gets 1,000 points. He just that was the perfect comment. I don't know. I don't know the operational definition. If you do process control, they'll talk about operational definition. You have to have criteria for it to be defined as that, and that limits the variation. So you would need operational definition of a yacht. Everyone gets 100 points, but Jacob gets 1,000 because he crushed it right there with that comment. Do we have a non-zero? Yeah, we have the code up here. What's the code called near zero? Where is the code for the function? Oh, really? Is it in the other thing? Is it in the predictive modeling? Yeah. Let's go. That's practice set data mining 3, near zero variance, near zero variance. There it is, near zero variance. Wait, where's it at? Here, wait. Where's near zero variance? Am I losing my mind? Because we need the near zero variance. Info density, near zero variance. Is this something, where's it loaded up at? Near zero variance is going to tell us near zero variance. It's a function. It's in the package caret. It's in caret. Why didn't I know that? Does someone say in the chat? It's in caret. So we did not load the caret package. And caret has near zero variance. That's why we weren't having it. That's why it wasn't loading. I thought it was a custom function. But so what I did was, if you're wondering how I figured this out, I Googled it, and Max and what's his name, Zach, created the caret package. There's their caret package on version 6 already. And once I saw it was in the caret package, I just went straight to loading the caret package. So that's how you figure out where's my function at. I thought it was a custom function though. I thought Petri created it for a moment, which this is such an important thing to do. But why was I talking about yachts? You're like, what, Brian? Why does Brian go on these tangents about yachts? If no one owns a yacht, then the variation in the amount of yachts we own would be what? If everyone owns 0 yachts, like if we take a vector of yachts, is that how you spell yachts? So if we do a vector of yachts, and everyone owns 0 yachts, so now the variation in yachts, you guys getting it, would be 0, and there's no variation. Think about this. When you say the variation in y is explained by the variation in x has no variation right here. So if something has no variation, what can it not do for y? If an x has no variation, it cannot what? If an x has no variation, it cannot possibly do this for y. 1,000 points first person. If an x has no variation, because the variation in y is by the variation in x. Cause there's a explain, Sarah, 1,000 points right there. Explain. Vader, you're first, 1,000 points too. Explain, yep, because we use variation in one variable to explain the variation in the other. So we remove out these variables that have very little variation. So this right here is going to tell us the low variation variables. So we're getting whether or not it has near 0 variation. So this is 0 variation and this is near 0 variation. So none of them have 0 variation, but some of them have near 0 variation, and it's doing certain metrics, which I just know. Here's no variation, which none of them have no variation. And then here is variables with near 0 variation. They might this. Now let me show you what near 0 variation is. Near 0 variation would be something like that. That's near 0 variation. And now it's near 0 variation. And what it does the computations for us. You could say, well, maybe is it doing it right? That's a good question about theoretically, how is it saying, is it near 0 variation? Good thing to look into, well, how near to 0? And probably there's thresholds on this that you could control to be how close to 0. So what do we have? We're creating a set of the 0 variance variables, and there's nothing that's 0 variance. So we're gonna look at there, and here's the near 0 variance variables. So the rows with the near 0 variance are located right here. So it's crowded units, no phone units, no plumbing units, no new units, and they were all next to each other. or column 32, 33, 34, 35. These are the variables that have near zero variance. Now take a look at what we're doing. We're going to the census data frame and overwriting it with a data frame that has those columns removed. If two variables don't have variation, do you end up choosing other variables? Yeah, like you just remove them. That Sarah, great question right there. If variables have near zero or zero variance, we're going to remove them just because they're kind of junk. They don't do anything. Like they're just going to make the algorithm take more time, and we're already going to do like an intensive search through it. So this is kind of a pre-processing of data, like a pre-processing of data. So we're removing out those near zero variance variables. So this code right here concatenates, removes the concatenated vector of the near zero and zero variance variables from the census data frame and overwrites the current data frame. Does this code make perfect sense? We found our zero variance, we found our near zero variance. We're removing out these columns, row space right here, column space over here. And we're going to those positions, removing them out and overwriting census. Hopefully, like, makes perfect sense. We made a vector of the near zero variance, we made a vector of the zero variance, and these are just the positions. So those are just numbers. These numbers right here might as well just be these numbers. This is not written correctly, but, well, I guess I could do this. And now it's written correctly. And this was actually nothing. There were no near zero variance. So we're just removing out those columns. It's just, those are the columns we're removing, and they were all the near zero variance. Does that make sense? And why do we do this? We don't want our algorithm to be handling variables that just don't really help. These variables don't do anything, so it's like, why make our algorithm do all the work if it's like these don't do anything? So there may be highly correlated predictors. This gets into multicollinearity. If you were watching 320 today, they talked about multicollinearity. So what you don't want is you don't want your x's to explain your x's. So when you talk about your data set, you don't want your x's to be overlapping with the variation with your x's. And we did a really good example in 320 today. Is that here? Yeah, it is here. So watch this. Take a look at what x1 and x2 are. x1 and x2, we'll call it x1 now. x1 and x2 are what? Who can say in the chat for 1,000 points? Show me you're following along. x1 and x2 are what right now? x1 and x2 are what? They're what? They're vectors. I'll take that for 1,000. That is correct. Identical, Ahmed. You're right, Ahmed, for 1,000 right there. Big points. Be paying attention, follow along. They are identical. And so now watch this. There's no estimate for x2 in the model because they completely overlap in the variation they bring. Does everyone see that the model literally can't make an estimate for it because it does not bring with it new information? For those remember from 320, we try to have the variables bring with them, the x's bring with them new information. So just going back to just regular old regression, if you have x's that do not bring with them new information, then the model's like, I don't know what to do with this. So this x3 right here is a random variable, and we can go right here and add it onto the model, and x3 brings with it new information, and x3 gets estimates. x2 has no estimates because it doesn't have any new information. So what does it mean for variables to have new information? They need to not be highly correlated with each other. So all this is going to do right here is find sets of variables that have correlation together that's more than 90%. So 30 and 33 are highly correlated. So we can get the names of the highly correlated right here. It's homeowner, what is that? Homeowner HH and number of HHs. I think it's homeowners households and then number of households. So the homeowners and the households and the number of households are highly correlated. We'll go right here. We're looking at the correlations, and you can see other correlations with the all correlations. Here's more correlations, the strongest correlations, and there it is right here. That's the strongest correlation between the two. The next strongest is that. So we really don't have that strong of correlations. So what if we change? Oh, yeah. Oh, well. So Ahmed, really good question. This won't work because it's a wrong. Oops. The vector length here is incorrect, but so there's not enough data right there. But watch this. This might work. I know another way to make it work, though. That did work. And now there's overlapping. Ooh, it does not contain new information, but watch this. There we go. Now we'll actually see it in the variance inflation factor, and those p-values are identical, which is interesting. If you remember variance inflation factor for variable 1 and variable 2, the variance inflation is ridiculous because Now the degree, so is knit in here right now? Because this goes to matrix algebra. Previously, these were completely linearly dependent, and you could make linearly dependent vectors like this, because that's just a linear combination of the first. It's still the same information. So do you notice here how this is the same information for these two? Does that make sense, Ahmed? That x1 and x2 have the same information in them still, even though they're not the same thing. It's just the same number sequence, but shifted. So it does not contain new information. And so x1 and x2, if you did a correlation on it, which should just be core x1 comma x2, we get 100%. So they're 100% correlated. It's like if you know what x1 is, you know what x2 is. Because if x1 is 1, x2 is 101. So there's no new information. But if you were to change this, like x3 is just random numbers, then if you were to look at like correlation between these, then it's just randomly correlated, which is close to 0. So what are we going to do? Whoops. What are we going to do? We are going to take and we're going to remove out those highly correlated variables. So let's go ahead and remove out those highly correlated, and you can see we now have a data set without those highly correlated variables. And then there's linear combinations, which is literally going to do this. And let me explain what linear, there's nothing to remove. Yeah. Linear combinations would be kind of what we're talking about with the mathematics about this, is that if this literally goes to matrix algebra, that maybe one of the variables in your data set is just a combination, like some sort of mathematical equation of other variables. Does that make sense what a linear combination would be? It's like to say BMI is a linear combination of like your height and your weight, I think, or different things. So if we had like height, weight, and BMI, we wouldn't need BMI because it's a linear combination of the other variables. It's some sort of mathematical equation derived, i.e. it does not bring with it new information. So the code previously here removed highly correlated variables because they bring with them redundant information, and then the code here removes out linear combinations, and there were none to remove. But does that make sense what a linear combination is? Linear combinations would be variables that are just the same sort of variables that are bringing the same information. Right here, it doesn't always find the almost linear. So here we go right here, and we're going to null these out. Now, the reason we're nulling these out, let me explain why. So the reason we are nulling these out right here is because these right here are categorical variables about what percent of things are suburban, what percent of things are age less than 5, and what percent of things are others for a categorical group. I'm trying to remember which categorical group that is. But suburban, if we were to look at the census data, you have here urban, rural, and suburban. And if you look at this, can anyone tell me for this census block here, census block 4, what percent of census block 4 was suburban? What percent of census block 4 was suburban? Basically what? Which we no longer have suburban right here. Suburban for census block 4 would have been what? Very close to 1,000 points. Who's got this? Right in the class. We're not done yet. Suburban would have been close to what for this one? I'll ask a harder one here in a second. But wait. We got urban, rural, and suburban. So Nisha still and Jordan, both of you, 1,000 points right there. How about for the first one, what would be suburban over here? For the first one, what would be suburban over here? What would be suburban? Suburban over here should be, oh no, you're fine, you got it. I think you'll get this one. Suburban for this one would be what? It doesn't exist, we removed it. But what would it have been before we removed it? Do you know what it'd be? Yep. And so if you know that, then don't the answers here explain this? So it doesn't find everything. So right here, we know the amount it would be with the other two variables. So what was suburban doing? It was not bringing with it new information. Like these age groups right here, if you know these age groups, you wouldn't have to know this one. So, and then here's the classifications, and this is census data, so it's just how the census is doing it. And so we removed a category, and it's arbitrary which one we remove. You could remove any category, it's arbitrary. So we just remove one of the categories as we're doing with the code right here. And why do we do this? Because the fewer variables you use in these really comprehensive methods, then the better your data works, the easier it is for it to do. And that brings us right here to where we'll start this tomorrow, where we'll actually make our training and our holdout. So we have everything right here to make the training of the holdout. We'll start tomorrow with this activity because we're going to go back through predictive analytics and finish up numerical predictive analytics, and that's right on time. We start on time, we end on time, but all we were doing here was getting our data ready to go. The reason we get our data ready to go is because we want to give it as few variables to look at as possible. I know that sounds ridiculous. Like, why do you want to give it few variables? Well, we're really going to push our computer here. We're going to give our computer like tons of models to look at. So we don't want to be like, okay, look at 1,000 models, but you know, the fewer things we give it to look at, the more important things we give it to look at, the better it does. So we're limiting what it looks at to have it look at more. Does that make sense? Who's with me on that? Like, we're saying like, I want you to do tons of work, but I want you to focus in on these important things. So we're setting it up for success from the start and then giving it a lot of work to do. And that's where we go next. So this was all the pre-processing of data. Make sure to email me that you got that 100 so you can skip this quiz. Who's got questions 3:20 or 4:74? We will do office hours at 4 today. I mean, we're going to stay here for a bit. So 4 p.m. office hours return. 4 p.m. So I will stay here for now. Whoever has questions, feel free to ask a question. 3:20, 4:74. Get some lunch here in a bit. Who has questions? Can you do homework 4 for Q for 4:74? Yeah, let's do it. Number 5 on the assignment. Yeah, can you help? Okay, cool. We've got the first question here. Kelsey asked. Let's do it. Let's do that question. Thank you guys for staying. Let's hop in here. And thank you everyone for all the hard work. I know, like, I really can tell that, you know, there's a lot of work right now. And I know I keep saying that. I just mean it. And I can't say thank you enough because I know it's a lot. There's a lot of work. So you guys are working really hard. It's a busy summer. And like 474 is not the easiest of classes. It's not an easy A. If you get an A in 474, Petrie and I have always said we're more than happy to recommend. If you get a B in 474, that's good too. But if you get an A, then we want to be like, we want to recommend you for the master's program. Not that we don't want to recommend you if you get a B, but it's just to say that this is not one of those courses where you, yeah, and that's the thing. You got to do it like every day. You just got to be like practicing, and that's what it's all about. So you guys and gals are doing great, and I really appreciate it. And I keep emailing me when you're stuck. Remember, that's the goal. And it's so busy. So busy. It's the summer. Okay, so let's go right here. Let's read in the transactions. Retrieve groceries. Everyone got the transactions in? We good on that? This is a grocery data set discussed in class. It comes from New Zealand Grocer. Read in the transactional data. Is that how you spell transactional? Ooh, wait. Now, set up, make a rule set. Okay, here we go. Rules that have at least 77% confidence apply to at least 25 transactions and that have a maximum length of 4 items in the antecedent. Okay, so this is the trick on this one. Awesome, Ahmed. I'm glad to hear that, Ahmed. The trick on this one where the mistake is made is that 4 things are in the antecedent. Is the antecedent the left-hand side or the right-hand side? 100 office hour points. Is the antecedent the left-hand side or the right-hand side? The antecedent is the left hand. The left-hand side is the antecedent. That's what comes first. And the consequent. Think about the consequent. Like, so you have like what comes after the consequent. Does that make sense? So you have the antecedent and the consequent. So because of this, we will be considering rules of length of what? So it says the antecedent should have 4, but it says careful about the max length because the consequent always has at least the rules we've always looked at, and I've never seen anything other than this. The consequent always has how many? So that'll change our rules. It says we should get 7 rules right here. So let's take a look at that. And one of the things we're going to do, okay, we're going to do it. We're going to write this from scratch. I'm going to get this. You ready? I got this. Okay. So we're going to go here to rules. I can do it today. We got this. I'm not going to look at the notes. We're going to go to G. That's what we're making our rules from. And then we're going to go to parameter. Ooh, autocomplete. Jordan, 100 points. 100 office hours points. 100 office hour points. You can get up to 200 office hour points. We're going to do the thousands. List. And then what does it want? 77% confidence. That's conf equals 0.77. I'm going to do this where we start a new line right here. Support, SUPP, equals, I wish it did like 3 for each. It should be like max L. See, it tells you their max length because that one's one I always forget. 25. How many things are in the transactions? there's this many carts. So you see I'm taking the amount of carts there and I'm saying, wait. Yeah, it's how many. We should apply those. Yeah, that should be fine. That should be fine. And then we want max length. And you see that's where you don't get the autocomplete. So that's a bummer. And the max length is 5. I think it'd be good if we ran this. I think it'll work. It'll just give verbose true. Ooh, we got an error. So it's warning message. Only patterns of length 5 are returned. That might be all right. How many rules we get? What? Let's put in the... What is it? Confidence equals this. Support equals this. Let's put the support inside here. And then control equals list verbose equals false. Is that really that big of an impact? Error in length. Where did I make the error? Let's go back to the rules. A priori. That's why we have the notes. Parameter conf. Where did I make a mistake in this? One little error. That's why we copy paste. Let's take a look. And if you notice, this is hard to read when it looks like that. So it's easier if you break it apart like this. And it is called G. Support conf. And did I do the support one? There's support, confidence of 0.77. He'll just run this right here. Method, error in object. What is going on, everybody? Error. Method length. No, it's the wrong math length. Let's just run the code as is. What is going on? Error in object's length. You know what it might be? No, it shouldn't be that. What is going on? This is where everything breaks. Everything breaks. Simple set. We've got the a priori. Yeah, no, I know it's math length equals 5, but this code right now should just work as is. That's the issue I'm seeing. I don't think I had an error with my first code. I've still got my first code over here. I think it's something else because this code should run. We're getting error in length object method not implemented for class rules. I'm wondering if it's different packages I have loaded up. Like I'm about ready to like restart R and just try again because let me do this. Let me run everything above here. Okay. We've got the set of transactions. That's good. And method. So where there always has to be an error, doesn't there? We've read in the rules. So let's make sure our rules are looking good right here. I say at the, yeah, no, that's, is it working for you, Sarah? Yeah, that's, why is my code not working? Drop your code in the chat real quick, Sarah. You got 9, why is Brian's code not working? Is this, Andrew, your code works right here? This is a trick. I'm just seeing if you guys can figure it out by yourselves. What did Brian make a mistake on? I know we did. Yeah, we did it the other day. If you're like, Brian can't do this. It's like, I did it already. I did it the other day. You go watch the other video. I did it. It worked. There we go. What? You see, I think there's something odd about R right now. Let me call this. Okay, I think something it's going weird. Let's call this homework 7. Cool. Saved as homework 7. Let's, well, maybe I shouldn't have closed my R because I had everything open from yesterday. We'll see here. Let's go to homework 7 now because that just was not making sense. If things are just not working, my advice to you guys is always like just close out, like just close out. Let's see what's going on right here. There's my 1,000 things open. I can just reload whatever I need. There we go. Retrain. Oof. Yeah, I shouldn't. I can get that fixed. I had things open that I kind of needed. Okay. Let's run all the code above because it's going to load some packages we need. Packages are loaded. Reading the transactions, no such file. We're in the wrong working directory. Set working directory, choose working directory. Let's go here to downloads. Let's do this. So we load this. We load this. Was that not the first thing I wrote? Was that not the first thing I wrote? Yeah, it's fine, Hannah, right there. Literally, this is what I wrote. R, you behave. You don't do that to me, R. I wrote the right things, and I wrote it all without cheating. I did that all without cheating, and R was like, I'm going to cheat there. R, my code worked. And then Andrew thinks, I know, I think, hey, Andrew, if you want to drop that redundant thing in the chat again, you can drop it in the chat if you want. I'll just copy paste it, because after that, I'm like, come on, you got to be kidding me. Yeah, R, you're in timeout. Here, wait, let's do this right here. Here, wait, you know what I'm going to do? We're coding one thing real quick. You ready? We're going to code this while, okay, let's do this. Start, and then system time. Okay, there's the system time. Cool. Okay, cool. And then let's do this. And okay, so there's system time. Cool. Let me run this. This is my one thing. This is my fun for a second. Cool. Let's do this. Start or n minus start. 12 seconds. It's greater than 10. Cool. Okay. While start minus end is less than 10, less than 5, print, I'm sorry, Brian. Okay. This is what ours gets for this right here. You ready? This is saying it's sorry to me. For 5 seconds, R is going to tell me it's sorry. That's what R gets. So you want that right there. I got 5 seconds of R telling me it's sorry. If you guys want that in the chat right here, here's let me remove this code right here. You should run it all as one block though. Run that as one block right there. So there's your R telling you it's sorry for 5 seconds code. Yeah, I've had fun with that kind of code before. But yeah, so you just figure out things you can do for fun. You just gotta be like, okay, what can I get R to do? Okay, let's get serious here. Let's get serious. Now that we got R fixed. I can't believe that. It's frustrating. I did it without the notes. I was like, I don't write this code a lot, but I remember it's parameters, list of this. Yeah. Okay. And wait, did Andrew drop in the chat? Andrew dropped in the chat. We're going to just take it from the chat. You can leave that in the chat, Andrew. If I say you can leave it, don't worry, you're fine. So once again, what does this code do right here? It's just going to the positions in the rules that are redundant, removing them. So these are the not redundants, though, because it's going to take the rules that are not redundant. So all of these right here, Andrew called his rules. So you know what we're going to do? We're going to change that to rules, and then that fixes those problems because now it's called the same thing. So I just, instead of changing these to capital rules, and I love when you double-click something, it highlights it. So we got this right here. Everything's good. And it'll tell us if rules are redundant by running this code right here. This is not redundant, though. If you notice the exclamation point there, it tells us not redundant. So the 9 rules are not redundant. It keeps them all. This tells us if a rule is significant. All the rules are significant. So it keeps all those rules. It keeps everything, and we are still left with 9 rules. So these 9 rules right here can be viewed by going to inspect. Once again, if you double-click something, you can go around it, and then you can start typing if you knew how to type. I don't. And it's a little bit longer than we get on the screen. I think if I go right to there, we good? R, you're not my friend today. Here we are. Here's the 9 rules. The 9 rules to rule them all. Okay, so the question asks, what does the question ask? So, print to the screen the 7 rules that involve at least one dairy item. So here's what you need to do here. Don't write these by hand. And this needs to be in the antecedent. So the antecedent is the left-hand side. That's correct. I have to stop and think for a second. So I think I can do this one too. Here we go. Subset. And what I'm going to do is I'm going to do my trick right here. I'm going to call these items. I'm going to concatenate that. Did everyone see the trick I did right there? We got double parentheses around this and it got mad. But does everyone see the trick I'm doing right there? And so this right here, and Andrew did his milk items. That's perfectly fine right there. And does it say the left-hand side or right-hand side? I guess it might, right? Andrew. Great job, Andrew. Andrew's right. Yeah, we did this last time too. It says the left-hand side or right-hand side. So you have to go here, as Andrew puts, you go to the rules. And now we're going to do the conditions. Now I like to do a separate line right here where we're going to do the first condition, which will be the right-hand side. And I called mine items. So we're going to do % in items. And then we do or, and we need an or here. So it's doing another condition right here. The left-hand side has something contained in the items. Now, we should get, I think it's going to print off, that's capital items. Yep, that's going to be a problem. And because I called it this. Andrew's right to call it milk items. Much better idea. Rerun that code now and change these. Just makes more sense to be more specific. Specific is terrific. 7 items, 7 rules. So now we've got the 7 rules. We can go to inspect the, well, we didn't make a subset. Didn't store it. So since we didn't store it, we can't use it. Now we can use it. So there's our 7 rules right here. What's it want these rules? Be very careful. You probably don't need to inspect the rules right there. You could also block comment that out. What's the right-hand side? The right-hand side is this right here. That is, we're saying that given someone has domestic eggs, root vegetables, tropical fruit, how would that impact them buying whole milk? So these are carts that have domestic eggs, root vegetables, and tropical fruit. How does that impact them buying whole milk? So this is the right-hand side. Does that make sense what RHS is? It's the right-hand side of the rule. It's the consequent. The right-hand side of the rule is the consequent. So kind of some, easy test questions I can write related to that. I could write the right-hand side of the rule is the lift, the confidence, the consequent, the antecedent. So the right-hand side of the rule would be the lift, the consequent, the antecedent, or the support. I don't know. I can say different things like that. It's the consequent. How would you sort by? Yep. So now we can go to the sort of the rules. So we should be able to go to, you go to your sort, and the first thing you do in sort is you say the sub is what you want to do it by, and we should be able to go here to this is where I always get confused. Sort by, see, I'm going to cheat. I'm going to look. Sorting the rules is always one of those things that I always cheat and look at. Here it is right here. You do inside the inspect. Sorry. And let's go right here and sort the rules by, it's by, because these additional arguments I sometimes forget. And you go here to confidence and make sure you type that in the right way. So this only reports the first 4. Maybe we want to show them all, and that should do it right there. And double check as soon as you do it, make sure that the confidence is now being sorted. If you notice, we start with the highest confidence and we go to the lowest confidence. Does that make sense right there? And then Andrew's showing how to find the item frequency of whole milk. So we want to find out how much people buy of whole milk. We can just go right here and go to item frequency, and then you want to do it of your transaction data. Transaction is G right now, though. And then you go here to make sure you spell it correctly, whole milk. We can do some tricks, though, Andrew. Is we could do things like, I guess can we do a subset? Probably do a subset of G and items. And I wonder if we should be able to do, this will work too, %AIN whole milk. And good, that's a subset. If you notice right here, and here's this is the amount, and we should be able to do this length. I think it's length of G. Yeah, there it is right there. So if you're wondering how many carts have milk, all these things right here, and you could divide this by length of G. And that, it doesn't like it because of the way it reports it. It reports this as a subset like that. But if you want to know how many items are whole milk, this is how many items. If you want to know what %, then you can just do this right here and get the %. So is this pretty good on this one? How are we doing on this? And this also shows some of the ways to use like %, and we could have used IN. It'll do it here too. Does this make sense right here? What's going on? How's everyone doing on question 4 right here? Do people feel pretty good, especially with today's lecture going over market basket and all of this? How are we doing on this? Pretty good? Pretty good? Not pretty good? Good? Awesome. We'll go on to the next question right here. The next question was, what was the next question? Scrolling back up. The next question was number 5 on assignment 6. Number 5, yep, Andrew, you got it. Made more sense today, that's what we like. Unfortunately, the sizes of the 3 quality measures for association rules support confidence lift don't have any intrinsic importance. Bigger isn't always more interesting. In other words, sometimes a larger confidence is interesting, sometimes it's not. Sometimes a larger lift is interesting, sometimes it's not. So it's like, when is it good? It's like, depends. It is found that the rule A, so this is right here, let's call this beans, let's call this cheese, let's call this milk, has a confidence of 1 and a support of this. Okay, so immediately I gave it some context by putting things in here. Somebody tell me what the confidence of 1 means right here. These are really great, easy test questions, multiple choice. What does the confidence of 1 mean right here? Because I can write so many answers that are wrong for this. I can write 100% of our customers buy bean, cheese, and milk. 100% of people buy bean and cheese. 100% of people buy milk. What does the confidence of 1 mean? Those are all wrong answers. I love beans and cheese, and cracking me up, Andrew, right there. 100 points, Andrew. What does the confidence of 1 mean? What does the confidence of 1 mean? Any ideas? This is very important for the test, because these are where I can put multiple choice interpretations. Kind of. I think you get it. But what does it mean? Take a moment and think about what it means. Like, be able to write a full sentence, which I would, 100% chance milk will be in the cart together given they have the other 2. Yep. Jordan, 100 points right there. That's exactly what we want to hear, that given somebody has beans and cheese, the probability they will have milk is 100%. Yes, Jacob right there, 100 points. You're exactly right. 100% of people who have beans and cheese will have milk in their cart. But think about this. So it sounds impressive. The support is 12%. What does the support mean? Try to do this. You need to be able to interpret like support for a rule at any time. Be like, what does the support mean? Any idea what the support means for this rule? Support deals with all 3 of those. So I could write the support means 12% of people have milk. The support means the probability of milk increases by 12%. The support means, what is like the support for this rule? That 12% of people have beans and cheese. Yes, Jordan's right. 100 points, Jordan. Support is the probability of having all 3. So the support for this rule means 12% of people who came to our store bought beans, cheese, and milk. Like if you looked in carts, 12% of carts would have that 3-item combo. Now, it doesn't mean they only buy those 3, but 12% of carts will have those items. 12% of carts have blah, 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 and every item, blah, 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 and we see. However, think of a scenario where a rule that has 100% confidence has actually no practical significance. What percent of people do you think buy milk at our store? I just did this yesterday. I just bought milk. What percent of our customers do you think are buying milk? Use a nice number. There's a really nice number we could use for this. What percent of our customers do you think are buying milk? 95%. 95% of our customers are buying milk, which means the lift, there's the lift. And the lift is so small, and maybe this is like a subset of people. It only applies to 12% of our customers. And it's like, whoa, if people have beans and cheese, they also buy milk. Well, they're kind of buying the essentials, and cheese is on the dairy item. So, like a Vidrona right there. Vidrona. Nice. Yeah. I like the exactness, 100 points. Yeah, I think the fact that pretty much everybody buys milk anyways, then the fact that everybody buys milk if they buy these items is not that interesting. It's like, well, people already, like, maybe the original support of milk is 100%, and then the lift would be 1 because everybody buys milk. So everybody buys beans, cheese. Everyone who buys beans and cheese buys milk because everybody buys milk. Just listen to that again. Everybody buys milk. So everybody who buys beans and cheese buys milk because everybody buys milk. Does that make perfect sense why this is like, well, okay, cool. It has a confidence of 1 because everybody buys milk. So everyone who buys beans and cheese, they also buy milk because everyone buys milk. So the confidence of 1 is like, meh. It's like, well, yeah, that's what we would expect. Does that make sense why this would be like, who cares about a confidence of 1? I know it's weird to say you don't care about a confidence of 1. It's like, but it's like, yeah, everyone buys that. So it's like, yeah. How are we doing on that one? Does that make perfect sense why we wouldn't care? I'll do one more because I did that one last class too, and so I'll do this one. So the rule A and B has a lift of 10. Interpret that lift. Interpret that lift right here. The lift of 10. Here's some wrong answers. These are all wrong answers. Try to interpret the lift of 10 in the chat. A and B are bought. A and B are bought 10 times as many as other items. B is bought 10 times more than A. A is bought 10 times more than B. And then I put the right answer. So this would be like my wrong answers to that. It would be A and B are bought 10 times more than other items. Pretty much. I think Andrew knows it. No, that's pretty much it, Andrew. It's pretty much. Like, I know you're probably typing it in a shorter version. But given, that's the key word, it's a conditional probability. Given someone buys A, the probability they buy B is 10 times more. You can also say A and B are seen 10 times more in the cart together than they would be by random chance. That's also what lift means too. We saw 2 mathematical ways of computing it. I think there's a question way up higher with the music listings where it says to interpret it 2 ways. Hint, hint, hint for that. The first way is B is 10 times more likely to be bought given somebody buys A. The other way is A and B are seen in the cart together 10 times more than we would expect by random chance. And that's where you do the probability of A given B over the probability of A times B, because that's the random chance probability. And we talked about that a little bit in class. But the first way is given someone buys A, they're 10 times more likely to buy B. It's my favorite way. And then the second way is the combination A and B is 10 times more likely to be in the cart than it would be by random chance. Does that make sense right there? Those are the 2 ways to interpret lift. It has to do with probabilities and knowledge and a priori information. At first glance, this sounds impressive. Given that A is in the cart, the probability that B in the cart is 10 times more probable. Exactly. However, it is possible that this list is not statistically significant, and that the rule has absolutely no practical consequence. So I think Andrew's got some good numbers here. Maybe, Andrew, maybe. You could probably use smaller numbers. And be equal to this. Yeah. So what you want to do is you want to create a ratio right here. So all this does is solve for lift right here. If you look at this function, the function takes inputs and then literally just solves the mathematical probabilities of it right here. So this is the probability, this is the amount of carts. These are the amount of carts that have A, this amount of carts that have B, the amount of carts that have A and B. So these are the carts that have A and B over the probability of A and B being in the cart by random chance. Do you see here? It's like lift is literally the amount of times we see items in the cart compared to how often we would see them by random chance, which this literally goes back to stat tool 1. Look at the 2 probabilities multiplied together, just gives you the probability of it being there by random chance. Stat tool 1 all over again. So it's like, yeah, stat tool 1. And then we have the actual amount of times we observe A and B together. So this function right here, we just put in the amount of carts we're dealing with. So let's go here and put in the amount of carts. I'm going to do, does it want at least a certain amount of carts? I don't know if I do a certain amount. And then you want the lift significance. So we got lift significance right here. Okay. So this is going to give you the significance, and we won't worry too much about that. It just calculates the significance of it. And so let's just do the lift right here, because in this, I'm going to try to think through this mathematically. If we have 100 carts and we have 10 carts that have A, think about this. Right now, what is the probability that a cart has A? What is the probability that a cart has B? What is the probability that a cart has A? What is the probability that a cart has B? Who knows what, from my math right here, what is the probability that a cart has A? What is the probability that a cart has B? Made it very easy with 100 carts. What is the probability that a cart has A? What is the probability that a cart has B? Any ideas? Probability of a cart having A? 10%, yep. And so what I'm going to do here is, what is 10% times 10%, which is the bottom part of that equation? The probability that they would have them by random chance is just 1%. But it turns out they're always bought together. So now you notice the lift is 10. Does that make sense why the lift is 10? Because the amount of carts that have A and B is 10. This will be very statistically significant. If I run this under lift significance, it's going to be super significant. It's got to be, because that's like unlikely. Oh, and rules. Oh, number of rules that we're making. Number of cards. We have to do the number of rules. So in rules, number of rules considered. So yeah, and then we have to do number of rules, like 5 rules considered. Sure. And because we want to attach that. Cards. And rules equals 1, but the lift significance returns false. Add another set of values where the lift of 10, but this returns true. I think we just did it. So come up with 2 scenarios where lift is 10 and where the lift is not statistically significant. In other words, try out different values of this right here so that the lift is 10, but the lift returns false. Another set where it returns true. Okay. So let's go down here and let's just put in our values right here. And you see we basically have the values right here, but let's try lift significance. There we go. How do you find, so that you just come up with that. It's just like, so I just made up in my mind that 10 cards have A and B. And what you could do, here's how, if you want to get a lift of 10, here's what you can do. Let's put this in the chat. Let's make an equation to solve for the lift of 10. Solved lift 10. Here's solve for lift 10. You need to take, to get a lift of 10, you need to take these 2 numbers here. So we need to take NA, NB, and then we simply take, and we do NA divided by N. This is the hard part of this question. Let's just make it so we can find out the answer. NB divided by N, and then we take this and times it by 10. So this will solve for what we want for a lift of what we need. Okay. So this will solve, when I put in these numbers right here, it'll tell me what I need for a lift of 10. So we could even have it say, like, this is what this number should be right here. So whatever I put in right here, this is going to solve for a lift of 10. Let me try it first, make sure it works. So this will solve for a lift of 10. Solve lift 10. So if I put in 100, 10, 10, it should say, oh, it says 0.1. So then times n. That should do it. See, there we go. That's where we test things out. Ooh. Oh, we didn't put in the return. And then we'll times it. This should work. I like my parentheses. There we go. There we go. Okay. So if we try out different number combinations like 500,000, and then we go here that 50 have it and 100 have this. So the lift of, really? That'd be, wait. That doesn't seem accurate. We'll try it out. Something seems off. Would that be right? Yeah, I guess it might be. Wow, how did I get that lucky on that? That is false, though. And then let's run the lift on this to see if we get a lift of 10. Did I just solve it? I don't know if I'm really smart today or not really smart. But apparently, because if I had chosen something like this, you'd get that and it wouldn't be a whole number. And what I should have checked was, I mean, it's doing the math for me. It's solving for the lift of 10. So let me drop this in the chat right here. But I just solved both questions. And that solves what you need for a lift of 10. That will mathematically solve out for a lift of 10. So that creates the amount of observed items. And I just got the whole number. I don't know. Probably just done this one a whole bunch. But those, does that make sense? So the answer is, well, so let me explain what this is right here. There are 50,000 carts in our grocery store. Of those 50,000 carts, 50 of them buy item A. 50 of them buy item B. One of those carts buys item A and B. Now, the probability of random chance of them buying all these items together would be this right here. The probability of them buying A and B together by random chance would be this. That's the probability by random chance they would buy them. But we actually see the items appear in the cart this amount of times. And look, you can literally see it right here. that it's what more likely to appear in the cart by random chance. That A and B actually appear in the carts what amount of time more likely. It's hard to tell with the e's, but you can kind of tell if you know how e's work, that it's like decimal movement. So what is it? It's a factor of what? 10 times, exactly. Does that make sense, Adam? That it's a decimal movement. And I just got pride in this one way too much. But I just lucked out that it was like a whole number. And my solve for lift 10 tells me, like, this will literally compute for me whatever value. Like, if this is 6,000 and this is 1,000, it'll say, well, that's cool. So you could literally do this number right here for your lift thing. And this will do, like, this will create a lift of 10. So all this thing does for me is it just solves so that this has a lift of 10. And then if I do lift significance right here, or lift, what's it called? Lift significance, and then I put in 1, that would be a rule. So let's look at the 2 scenarios right here. Here we got a scenario here, and we got a scenario here. So let's look at these 2 scenarios. And if you think about how this works, you'll kind of understand what's... So the function finds... Yep, exactly. It just solves out what I need. It just... Since rather than guessing, it just mathematically computes what this number has to be. So it just mathematically figures it out for me. It's just like, oh, here's your whatever you need to... It just creates that based on, you know, like what the lift should be. Does that make sense, Adam? Like it answers it for me. It's in the chat too. So if you want to grab it, and it'll just compute for you whatever you need for a lift. So you just have to enter in the first 2 values, and it computes the last one. Just solves out what it should be. Does that make sense, Adam? So why solve things yourself when you can just let the computer solve it? So I tell 201 all the time. Awesome job, Adam. Adam, 100 points. Thank you for hanging out and doing a bunch of work here. Think about this rule right here that's not significant. I mean, think about what we're basing it on. This rule with a lift of 10 is based on somebody who bought the item 1 time. Do you know what the lift would be if no one bought this item? Do you know what the lift would be if nobody bought that item? I think I know what it would be. I got a good guess at what it would be. If nobody bought that item, I'm guessing. Yeah, let's do 2C next. You got it. I'm guessing the lift's going to be 0. Yep, it's 0. One person buying that item created a lift of 10. So what does that really mean? That lift could just be by what? Boom. You guys know it. That lift could just be by... They're never going to get me for doing it that quick. Oh, man. They claim videos. I don't know. That lift could be by random chance. That's literally what it means by it's not being significant. Does that make sense? Like, one person created that lift of 10. One person. If they had... But think about this one right here. This one right here, $6 a month. We're seeing how long we can press it. I need to do the privacy.com thing. I need to like go in, put a credit card on privacy.com and go in and do that. Or maybe talk to UT and be like, hey, UT, the volume seems a little low today. I don't know if you guys feel it seems a little low. Maybe I just need to be always closer to the mic. Now it's doing good volumes. So I always have to have it turned up all the way and everything. I'd be willing to donate. One big thing I'll try to remind people is subscribe to the Twitch. That's going to be a big thing I'm really going to push. And always feel free after you graduate from this class or leave UT, check out some of our videos anytime. That's a big way to help out the channel is check out videos. Just when you see me, if you see me post a new video, if you don't even want to watch it, just put it on the background and like just play with no volume. So the more you watch the videos, the more we'll get traffic to the channel. And we already have 45 Twitch subs, which I'm sure many people would love to have 45 Twitch subs. So I currently have it in here. Let me show you the Twitch. I'll put the Twitch channel here. So you can sub to the Twitch channel. I'm going to try to get that up and going. It says Stat1 is offline. Do we not have the background on here anymore? Is this my... I'm logged in as myself. Usually it shows the background. I hope we still have our backgrounds. I know. So, yeah. So go ahead and check that out. We'll hop over to the next question right here. About, schedule, videos. I don't know if they changed it. I don't see... Here, wait. Stat 201 UTK. It says it doesn't find us. Do you guys see like the channel with the... What? I had a background up. I don't know. It used to show it. It used to show it. Well, I'll worry about that later. Channel. I don't know. I gotta learn this Twitch stuff. That's a hard thing too. Is am I following anybody? Not following anybody. Following everyone on my normal Twitch. Okay. So yeah, it changed it. We had an image of yeah, I see the purple background. I don't know what Twitch changed recently, but we did have a well, thank you, Adam, right there. Thank you so much. I think I see that right here. Whoa, we just got a bunch. We got 3 subs right there. Thank you guys right there. Yeah, and if you guys want me to check out your channel or something, and I can throw my Twitch Prime to you guys, especially since we're not using it. But yep, and we're gonna try to, like, if we get Twitch Primes. Thank you so much, guys, right there. It's so funny. I can see that on my mini feed. So like here, I'll just cut the end of it so people don't, like, I don't know if people want their Twitch names broadcast, but you can see right here, you guys, like, I can see it on my feed. So I've got it in Streamlabs over here on the side. Yeah, followers, different subs. Yep. Because subs, like Amazon Prime sub and stuff like that, and followers. Yeah, definitely follow, and we'll get our follows up. We'll get our subs up. Yep, subs are paid. And so you guys don't worry. And if anyone ever pays money, it'll just go right to students. But followers help. Like, the more followers we have, I'm sure that'll create more of an impact. And I really want next semester, to do more streaming on Twitch. I just have to know the ins and outs. Oh, really? How many followers do you have to get the sub button? Adam, we need to talk about this more because I don't know all the ins and outs of there you go, that's how it's connected to it. I know YouTube pretty decently, but Twitch, and then, like, should we use Mixer? Should I do TikTok videos? Over mini term, they're like, Brian, you gotta do TikTok. You gotta make stat TikTok videos. I think, was it here, I'm gonna start loading up the next question right here as we're talking about this. 2C, you got it, Jordan. Let's do 2C. 2C. Let's do 2C. Definitely anything you guys know about how the world works, how the internet works. Sound like such a boomer. Okay, we're going to write this out. We're going to do it again. You ready? How many rules were found? Let's remake the rules for music. Okay, so here we're going to do this. We're going to load in the music data frame right here. Yep. I'm sous videing. Oh, wait. Oh, you're sous videing some fillets. Sous vide. Vacuum cooking in water right there, right, Andrew? Sous vide? Sous videing some fillets. Man, Andrew, that sounds awesome. Andrew, you need 50 followers, 500 minutes of broadcast, 7 unique days streamed, an average of 3 people watching to become an affiliate. Psh, we're gonna crush that. We're going to. The thing is, if you become an affiliate, Adam, do you have to, like, only broadcast on Twitch? That's, like, my fears. Too long didn't read. Equals sub 1. Do you have to, like, can you only broadcast on Twitch at that point? Like, my fear is that remake the rules from music. Okay, so we're gonna go to rules a priori. Like, my fear is, like, I broadcast and they're like, you can only broadcast on Twitch now. What you broadcast on Twitch has to be unique for 7 days, but you can stream anywhere. Okay, cool. So it has to be unique for 7 days. What does that mean? Adam, thank you. Adam, 1,000 points. You know you get from helping me out here, but what does it mean it has to be unique on Twitch? Like, I can't be like, I mean, that's my problem, is, like, if I do office hours on YouTube and Twitch, are they gonna have a problem with that? Like, he's doing office hours. Like, you can't upload your VOD from Twitch. Oh, okay. Got it. Yeah, video on demand VOD. Yeah. Thank you. See, no, I know for the. Okay, cool. So that's I know some people, like if you become, like, a ninja, you're on, like, which I think Ninja's on Mixer now. Is he? Did he sign the contract with Mixer, or is he on Twitch? Where's Ninja? Yeah, he left Twitch, didn't he? He's on Mixer. And so, yeah, Mixer. And how much do you think he's getting paid on Mixer? Like, I tell my parents about this stuff. It's fun to tell older people about, like, yeah, this guy plays video games online, and Shroud did too. Millions. Yeah, like, and, like, they gave him what, like, millions, but then, like, he got, like, tons of subs on top of that, or whatever it is on Mixer. If you were going on 2C, you also did this one the other day. Awesome. You got this. Let's crush it. Because we're going to do parameter. Okay, it gives it to us. Let's just take it. But look, it's tricking us with that parentheses right there. We're going to get an error. So we have to be careful. We're going to hit an enter right here just to space it out. This is going to be a sub condition inside of here. Okay, see, that's the extra thing. Watch out. You can always click the end of it to see where it ends. Yeah, we'll do all of 2. You got it, Adam. Yep, let's do it. We're just chilling. This is just relaxed time. It's office hours. You don't have to add this in. You can if you want. Parameter, nope, list, verbose, equals false. And that should work. Cool. And we got the conditions. Remove out the redundant and non-significant. I'm going to go right back here to what Andrew wrote. Andrew dropped the rules in the chat. So Andrew has it written out this way. I have it capital rules. So to make it easier on myself, to make it way easier, we're not even going to worry about changing all of mine. We're going to go here and change it to this. That just makes life easier. So remember, this is in the chat right now. But does this make sense right here, Adam? So you guys got it. We're just chilling out. We're doing some work. I think it wants us to remove the parameter argument, doesn't it? Does it? Let's see. Oh, haha. So remake the rules, but use different parameters for everything. Remove the blah, 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 blah. Wait. Remove the argument parameter. It wants us to remove all of that? Really? And then were there other arguments? Am I going mad? We will take a look. Let's take a look. So if we go here, is it 500? You should just have a priori music, yeah, and then, yeah, the beautiful thing is gone. And you see, yep. You guys getting 500 rules for this? 500 rules sound good to you? I'm so sad we lost this though. I wanna copy it and keep it. Sure, copy. And you can do the got 500. Yeah, sounds good. Tell me if I'm wrong on something. 500 rules. You don't need the control list verbose. It just cuts down on the output, so you don't have to read this. There's no point to that. I don't read it, so you don't have to. How many rules were found? 500. How many rules have levels of confidence between this and this? There's lots of ways to do this. One, go here to insert an R chunk. Probably the quickest way is to go right here and do this. Make it go crazy. So now let's go here and let's call this rules 2. And let's go here. Let's call this rules 3. And boom, boom. And we should get, that's 278. That's 70, and the answer is 208. And we could do it mathematically right here. I don't think we can subtract the numbers on this. Like if we do rules 3 minus rules 2, I don't think that'll work. Yeah, it doesn't like it. I think that's a cat to the screen right here. I think that's a cat, so we can't capture what it says. Like if you were to literally try to capture what that says, it's probably going to store nothing in X. Oh, it does. X. Oh, it's the rules, right? I wonder if we could do length of it, right? Should be able to go. Will this work? Ah, there goes. There goes. So length of rules 2 minus length of rules. I thought it was just printing to the screen. It's just, it does print to the screen. There we go. That right there. About the quality function. So yeah, the quality. I don't use quality that much. What does quality do again? Quality. So many things. I can post what I have. Yeah, post me what you have. So I think Andrew might have a way to inspect, sort rules. Which one's this, Andrew? Which one are you working on? Which one is this? How many rules? Andrew has, he's sorting the rules by lift, decreasing equals true for the top 5. Ooh, I like it. Let's take a look at this Jordan right here. Let's take a look at what Jordan has written. So we should get the same answer. And let's take a look what this code does. This code right here is going to go inside of the rules. Probably we'll go right here and we'll separate this out. There's 2 conditions. Okay. So the quality of the rule, the quality is creating a list from the rules. It's all the qualities of the rules. Oh, it's just rules. I'm going to change this to rules. And he just said rules. There we go. So yeah, that should work. That should work. That should work. And so this is the quality of the rules. So take a look at it. And you're looking at only the confidence. There we go. And then you're finding out this will do logical statements right here. And there you go. And yeah, that's an excellent way. 1,000 points. I mean it. Great way of doing it. And then we should get this right here, which then you could do a length on this. Ooh, wait a minute. We got different answers. We got different answers. What is going on? Is mine not inclusive and is yours inclusive? The quality of the rules, confidence of this, confidence of less than or equal to. Let's see. Let's do this. And let's do this. And let's see if we get same answers. 192. So this makes the rules of set. We're both working off of rules. I'm wondering why it would. Do you think we have redundance in here maybe? There might be redundance. Let me see. That's what you got for A. Let's see here. Let me double check. Inclusive. Inclusive, so we need the greater than or equal to, so we need that. Let me see here. Rules. Yeah, let me do this right here. But it doesn't say anything about removing redundance. Rules, operary, music. Sorry. Wait, rules, save into. Okay, wait, that's the new line. When I copy, it doesn't do the new lines. So let me go here. And I'm just wondering why these turn out two different codes. That's what I'm not liking right now. 2 seconds. This is definitely a much longer way. I'm just seeing if there's differences. Ooh. Were none of them significant? Is that really? 70 rules. Wait, whoa. We didn't have 70 before. How are we getting 70 rules? And then how is rules 2? Oh, that is what we were getting. You got 208 also? Let me take a look here. So quality of the rules, confidence. See, I'm wondering why. Let's do this. Let's remove out this right here and see if we get 262. And then we get 69. They're so close. You know what we could do? Do it the hard way. How many rules are we getting? Let me look at the first rules, because this is, I'm all of a sudden like, what's going on right here? Let's go to, how many rules are there? There's 500 and, whoa. Didn't we get 500 rules to start? I think, like, I swear this is haunted. We got 500 rules to start. Why are there now 522? This thing's haunted, everybody. You got 500? I swear we're running the same lines of code. I swear we're running the same lines of code. Did we remove out the redundance and everything? We got 500? Okay. You remove out the redundance. So remove the redundance and non-significance. Okay, we're good. Okay. How many rules have levels of confidence between this and this inclusive? Okay. I think I know the issue. Is that the rules that I created did not have the redundance removed. So let me see here. So now we go here. And that's a set of, that shouldn't be 500 rules. Because we should have more rules. Rules 2. Oh my gosh. This is where you run into problems, everybody. I've done this before. I've had this problem. Okay. Okay. I think, who was it? Adam or Jordan? Wow, look at that. That's the problem. 193. And where is it? Jordan, great job, Jordan. Wow, Jordan, well earned. We did not move out redundance in our code. Would have caused a problem. Jordan's code right here, I think it gets 193 also. Error object rule 2Q not found. So we need to go to rules. And we were not removing out the redundance. And so we now have new rules. Oh, I overwrote. That's fine. Don't tell me. It's off by 1? No, come on. I should accept either one. See, why is it got to be off by 1? Let's see something right here. You ready? We need to know where the error is at. So here is the rules. Let me look at length rules. And I need to know why. have an idea why. And I think it might be due to something, and I'm really not happy about it if it is that, because I think the way it reports the first... No, I'm wrong about that. I was wrong. Okay, let me... Sorry, everyone, I'm doing so much right. 194. So this is the rules. I am losing my mind. You got 190... Yeah, I know, right? This is just maddening at times. Okay, that's the same. Okay, there's only one rule that... Okay, wait. Because what we're doing is we're taking a subset of the rules. So you got to be careful. What I need to do is I need to not overwrite my rules. I need to call this rules new. You don't... If you're going to overwrite something, you got to be very careful. So there we go. Okay. So there's 69 rules that are greater than that. Then there's... There we go there. And so we should get 262 minus 69 equals 193. Okay. And then we run this. There we go. I think it was because I was overwriting the rules. I was just, don't do that. So here we go one last time. You ready? So what we do right now is we take and we just add in this final condition right here. And we go to and. I need a second Red Bull is what I need. And the quality is less than or equal to 95. How can that be? Because how are we getting... We just did it. We just did the math on this. We got 69 rules are greater than this. 262 are that. If you get 193 and 194, it's fine. He's got to make sure... yeah, that's the redundants have to be removed because it's just probably a better idea to do this. A better idea to do it this way right here with the quality of the rule to do the confidence. Either way is fine. 193 and 194. I'm really wondering where the difference is because we saw... I don't understand why we would get one different. Because right now, we should have the things... It just makes no sense. Because this right here... Okay, now that's where the issue's coming from. What have I done? Oh, because that's all the ones that are less than that. My brain is not working today. I'm fine with your answer. And I can't think about why the differences happen right here. Did I do greater than 95 last time and just lucked out and got a same answer? Oh, mine is completely wrong, everybody. Do not do the way I'm doing it. Because, let me just think about this. No, don't do the way I'm doing it. Jordan, great job, Jordan. Wow. My way is completely wrong because... No, wait a minute. Sorry, this is just one of those confusing moments. No. My way should be correct, and I'm just wondering why we're getting one number off. I might literally go through and look at all these rules, and I'll explain to you visually what we're doing. I'm thinking about it visually in my head as I think about this. It's just, I literally say this, but I think one of the hardest things about teaching is I literally have, like, lights shining on me. So there's all these bright lights, like, on me. So it actually gets a little bit hot, and I can't have my AC on, or you guys would hear it the whole time. So after I sit under the bright lights for like 4 hours, it's like because it's literally like right there on me. So I mean, I don't know. I should just not worry and turn off the lights. We'll do this. We'll go full no lights right here. Oh, the green screen's still working? No, I don't need that one. I thought I need this one for the green screen to work. Urgh. Okay, 2 seconds. Okay. What is Brian seeing in his mind? Okay, the way I wrote my code is I wrote my code to find... We'll do the next few ones. Right? 193, 194, I don't care either way. I can't figure out where the error is, and it's one rule. And so the first code does greater than or equal to 90. The second code does greater than or equal to. So when you subtract these two, what are you left with? When you subtract these two off of each other, you're going to take this area off of this, and you're only left with this area right here. So actually, that might be the issue. Because I think, let me look at that. I think I'm subtracting off the 95. Do you think that's, so I think that'll work right there too, Kelsey. You're getting 194? I have an idea. I think I'm subtracting it off. I think I'm subtracting the 95. I think there's a rule with exactly 95% confidence, and I'm deleting it. I think that's the problem with my code. And Kelsey has Kelsey 1,000 points. Thank you for chiming in. Kelsey has another way of doing it right here. I'm just going to have to change this to rules. And yes, nice, Kelsey. This is a great way of doing it. We're just doing, just do a subset this way. I think that's the way I did it last class, when I did it last time. And we get magically right there 194. I bet you with my ridiculously long way of doing this, let's do that. And so now let's do this right here. Figured it out. The reason is there's a rule with exactly 95% confidence, and I was subtracting off that rule. So what did I do? I made it 95.00001, and that did not subtract off that rule. Now, if I want to be really particular, I could probably go here and do something like that, and hopefully it still runs proper. There we go. Because there was a rule with exactly 95% confidence, and that was the one rule we were losing. We were losing that one rule. That was it. When you see an error, you're like, what's the error? So the graphic made me think about it. A lot of times I just draw out because this rule was getting cut off there. I'm fine either way. The answer is 93. Wait, what was it? Let's look. The answer should be 90. Is everyone getting... Wait, you're getting... Wait. Okay, wait. Here's the answer. Let me show it again. It's 94 because I was deleting the rule. The answer is 94, but I'll accept either one. The answer is 194. Because if you look at right here, it's 194. There's 194. And here's 194 also. So there's 3 ways. We made up 3 completely different ways. And do you know whose way is the worst way? Guess whose way is the worst way? Not joking. Don't be mean to anybody unless you want to be really mean to them. And you can be mean to this person, which gives a hint of whose ways was the worst way. Now that I look at it. Andrew says this way, not your way, Andrew. I'd say my way was the worst way. I'm putting a vote towards Brian's way right here. If you look at the amount of code, the amount of errors that can happen, worst way, I'm going to go towards, it's almost a tie between these 2 ways. I kind of like, it's really a tie between these 2 right here. I'm probably going to go with this one. It's a tie between these 2. Does that make sense? Like when you look at these, and you would have to go here and go length of rules new. So great job. We figured out the error. We worked it 3 separate ways. And yeah, so 3 separate ways to work one question. Just good practice. I was not going to let that error go through. Now we can just crush it. There we go. How many rules have a level of confidence of this and above and lifts between this and this? So if you look at this, Kelsey dropped in the chat right there. She dropped some amazing code. And once again, the notes have all the answers. If you go to the subset in the code, you can literally go here and do subset, and you can see the different ways we're subsetting the rules. So you can just see multiple different ways to subset the rules based on what you want to do. So we're going to drop in here a chunk, because why work it in a different spot than right below it? How many rules, and we got our original rule set, have a confidence of greater than or equal to this, and a lift between 3 and 4 inclusive. So all we're going to do is a confidence greater or equal to 0.85. And then we're going to go right here, and we're going to say and the lift needs to be greater than 3. And the lift needs to be less than or equal to 4. And then let's look at it. There you go. That should be the answer right there. So if you notice, once you get kind of a style for it, or you have a way of doing it and you confirmed an answer, pretty good on that. But that one made this one a lot easier using the structure of the code. And just kind of look how it flows. Here's what you're making. You're making your subset from the rules. You want these conditions, second condition, third condition. Does that make sense right here on how to do this right here? But pretty good to do using the subset on this right here. Print to the screen the rule that has the highest lift, which you'll notice is blah, 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 blah. The output shows that this rule applies to 194 users, and the rule has a confidence of this. How many users in the data set like Katy Perry, Miley Cyrus, but do not like Kesha? Okay, so this gets to an interesting thing right here. We need to figure out people who like Katy Perry, Miley Cyrus, but don't like Kesha. So what we could do is think about this. You have two groups. So let's draw it out graphically right here. We have right here, let's just call it A, B, and C. Okay. Here's the people who like A and B, and then we're going to have overlap right here. And this would be A, B, and C. So we want to figure out how many people, and we don't have to worry about how many people like C, because this is just how many people like C. So when you think about this right here, can you think of a mathematical equation to figure out how many people like AB? Can you think of a mathematical equation? Who could write the math? Don't worry about writing complicated math. Just think about how to figure how many people like only A and B. How many people only like A and B? How do we figure out how many people only like A and B? I know someone can figure out the math on this. Just think about the way it looks. And you wouldn't want to do ABC minus C. Close, close, close. Here's what you're interested in. You're interested in this. That's what you're interested in. You're interested in this area. So how would you find that area? Here's a hint. These are your hints. 100 points first person. Who knows? You got this. That's the visualization of how to do it. I always try to visualize what I'm doing, to think about it. And that's what helped me solve the last problem. Be like, how do I visualize this? What am I doing? And I was like, oh, I'm inclusively removing it. Well, not divide. Don't divide. Because that'd be a ratio. You want to figure out how many people like A and B. Only A and B. Because they're within the people who like AB, there's the people who like A, B, C. We're so close. Jordan, you were so close. Put your answers kind of together. You're very, very close. Because you want only the people who like A and B right now. Only the people who like A and B. So, yep, Adam. Yep, Adam, Jordan, everybody. So if you're participating in this, you got 100 points right there. It's going to be A, B, the people who like A and B minus the people who like A, B, and C. And that's the people who only like A and B. Because it's like, does that make sense to everybody right there? It's the people who like the two artists minus the people who like all three artists. And then you would only have the people who like the two artists. I mean, they can like other artists, but so we want to find, let's make some subsets right here. And we're going to do this. So, is that the only thing? How many users? What logic Friday if you push strength? Okay. So we can do a subset, right? Or we can do the following, which I guess, yeah, sure. Well, wait a minute. Want to go here to subset of music. And does it want with these rules? Okay, wait. Then output shows the rules applies to... Yeah, we're fine. So this is where it gets confusing, because you have to go here to items, which it's weird you have to do items because, like, I never think of that. And then let's go and do the following. We're just going to see if Katy Perry appears. Ooh, I think her name has no spaces. So let's see if this works. Good. Always, here's the biggest thing, is always make sure your code works. And I know a lot about how this data set works and the frustrating things, that the names in the data set don't have spaces. So all I'm doing right now is finding what? Can someone explain what I'm doing in the chat right now with this code? What is the code Brian is writing out right now? What is the code Brian is writing out? Oh my gosh, is it really? Oh, because the $sign on her S must not have translated. Oh, because it'd be a special character. So yeah, does it say that in here? Oh my gosh, you gotta be kidding me. Oh, that's an error. There we go. So this code, we want this code. I switched the code very quickly there because I don't want the people who have any of those artists. I want the people who only have these artists. And We'll call this L1. And then we go here. And we go L2. And if you want, what is it? We want the people. Wait, how many users in dataset like Katy Perry and Miley Cyrus but do not like Kesha? So we want to move out Kesha here. And that's list 2. We should just get length list 1 minus length list 2 minus 34. Reverse the mathematics. And that should be it. There we go. We got it. Good job on the work right there. That is the people who would be excluded. The people, and that does make sense. List 2 would have more people in it. Yeah, list 2 is the people who like Katy Perry or Miley Cyrus. And so that's got it right there. Can you put that in the chat? Yeah, let's do it. Sure. You guys are here. I'll remove this one afterwards, but you guys are here for us. There you go right there. You got 14? Uh-oh. Let's make sure we're getting the same thing. Be careful. Jordan, do you have your code? Put your code in the chat real quick, Jordan. Let me see the differences to see where the difference is coming from. What does your code look like? I need a second Red Bull is what I need. Need Red Bull number 2. Let's see right here. Here we go. I got yours copied, Jordan. You can go ahead and remove it right here. I'm going to remove mine. Okay. Subset, rules Q2. We're going to... Oh, you're subsetting your rules. So the issue is, and this creates some confusion. So you have less because... Let me look at the spirit of the question. The output shows this applies to 194 users. And that the rule has a confidence of this. How many users in the data? So here's what it is. Okay, I think I know what it is. Okay, I got it. Your rules Q2, which you created from, what were your parameters to control for rules Q2? Because rules, you're subsetting the rules right here. So I think the way, I might even look and cheat and look at the key on this to see which one. But I think, Jordan, since you're subsetting the rules, you should look at the transactions because this is for the full data frame and you're subsetting the rules right here. So you're creating a subset of the rules that have these items. And so yours is going to go to only the rules. And that's why yours has less because the way the rules are created will have less in it. I'm going to take a look right here and take a quick peek because I think... Jordan, I'm giving you 1,000 for seeing if you're right, but I'm giving you another 1,000 if you are right. Let me take a look. 2 seconds. I'm going to pull up the key here. Because theoretically, we're both kind of right. Like, you're right. For the rules we've created, there are 17 users who like Katy Perry, Miley Cyrus, but don't like Kesha. And then I'm right for the full data frame. For the full data frame, I'm right. So it's like, well, which one do we want? And so let's take a look over here. The answer's going to be... Okay, Prince of the Rules win. It's 34. Yeah. So it is 34. Just so people can see I'm not making it. I'm going to show the answers for a second. So it is 34, which I thought it was. I just wanted to confirm. So, whoops, there's a few more answers, but hints. So, but that is, how's everyone doing on this? Is everyone feeling a little good about this assignment? But so the small difference between what you and I were doing is, and then we can confirm 194. We confirmed that. I think we've gotten all these same answers, right? If you see something like, hey, Brown, we got this one wrong, tell me. And then here we'll go ahead and we'll steal this next answer right here. We'll steal it. We'll just take it. We'll take an answer over here. Cool. Yeah. So does that make sense, Jordan? Like, I think yeah. And yours was doing a subset of your rules, which applied to less users than the full data frame. One artist was Madonna. What rules have Madonna somewhere in the antecedent while have lifts greater than 4 and confidence greater than this? Print the 4 rules to the screen. The consequent of these rules are all the same, as in the artist, and as an artist, I think is pretty okay. We'll be updating these, which I'll be doing for part of my later of the summer. But you see here, inspect subset of the rules. So the big thing is the subsetting the rules, which if I'm going to break this part and make it a little easier to read, I'm going to do the following. So if you notice, those are the different conditions within the rules. I might try to re-indent these lines right here real quick. Let me go to code, re-indent lines. Sure, that's the way it looks. And so if you inspect these rules right here, you'll see the 4 rules. Ooh, is that the 4 rules? Do we get 4 rules? We got way more than 4 rules. Probably because, let me see here. When the artist wrote, while rules Madonna somewhere in the antecedent, while having lists greater than 4 and confidence greater than 90, print the force between the rules, the consequent of the rules. Now this is interesting. We're getting a lot of rules right here, which we don't want to get. That's a lot of rules. What is going on? So left-hand side has Madonna somewhere. What rules have Madonna somewhere in the antecedent, which is left-hand side, while having lists greater than 4, and consequence. Did I not run the full thing? Let me do the subset. 569 rules. What's going on? I just took that from the key. Well, what's going on? Let me go look at that again. I should have never looked at the key. The key is wrong. It's not the key. It's the key to insanity is what it is. What? I literally just took this. Oh, did we... Let me look at something. What? I'm just, it's haunted today. It's haunted. It had to have been the rule creation. It's completely haunted. Completely haunted. Yeah, and then the %I in % is going to control what was it before? It's the way the rules were created. What rules did I have before? And this is using no parameters on the rules. Why were my rules so crazy before? There's Madonna on the left-hand side. You know what it might be? No, I don't know. I don't know what it is. I am slowly going mad today, but this does print the 4 rules to the screen. I just remade my rules. Something doesn't work, just remake them. So I grabbed the code that just remakes it. We didn't use any parameters. Then we're going to remove the redundance. We're going to only use the significance. And then we are going to look at the subset of rules right here. So I think that's got it right there. And last but not least, do any of the rules involve him on the left-hand or right-hand side? If not, show that the length of the rule zeros. So we might not have any prints rules. Do any of the rules involve him on the left-hand or right-hand side? So we're just going to grab this code right here. We're going to go right here. We're going to go to prints. And we're going to go to left-hand side. And I don't think we have any other. We're going to go here very carefully and do the following. And go to or. Right-hand side. Prints. And wait, unexpected constant. Oh, wait, what? Oh, haha. There we go. And it looks like there's nothing. It's going to say like subset of 0 rules. Set of 0 rules. And we can just make sure this works right here, like by going back and Madonna or something. But this is going to go crazy if we do Madonna in here. And then there's all the rules. There's 75 rules that have Madonna on the left-hand side or right-hand side somewhere. So we should see Madonna somewhere on the right-hand side. Or just on the left-hand side. But does this make sense right here, what's going on? And I believe there's no rules with prints. So yeah, there's 0 rules. So if you put prints back in here. But what's kind of interesting is the things like the PINs, which you can use. Because maybe prints is misspelled. So we can go to the PINs. This is not the answer. We go to pry. And we'll see. Oh, we still get 0. PR? Surely. What? I thought PIN would do something. So let's try Madonna. There we go. There's those. And let's look at the right-hand side here. I'm just having fun for a moment. There's Lady Gaga. And so it can have Lady Gaga on the right-hand side or Madonna. And the PIN should match. Now, I wonder why Prince was not... That's a lot of rules there. Nobody was listening to Prince. I know, right? Well, look, we're getting matches now with the partial match. Once you do that, okay, there's no rules. Wait, that makes no sense. Because it should have that they're matching. Oh, it's only P. There's no artist with PR? There's no artist that has like PR on the. I need to use a star. Yes, good. You can use special characters here with a star. So maybe like we do like wonder well 1 star. Let's try 1 star. I so rarely do stuff like this. It won't do it right hand side. I'm just having fun with this. Like I like searching. I like this kind of stuff. That's a capital right there. Oh, can't do that. There we go. And you should see. Oh, and it does. It's allowing it to be out of order, is it? Nope. BEN. Sorry, I'm like seeing how it's like doing the algorithm. I took it as print not be. Yeah. Print. Whoops. Prince should be. He might not be in the data set. Let's take a look. If we want to see if Prince is in the data set, item frequency of music, and then go here and go Prince, and there's Prince. But if we times that by length of music, he's in 28 playlists. So Prince, he's only in 28 playlists, so it didn't really have enough to make any. There was no rules it could make with Prince. So he's only just things like that we should be able to do also to be like how many people have Prince in their playlist. You would think he would show up, but nah. He's not in any rules. There was no rules that were found. You know, we removed out the it just didn't create any rules. There might be thresholds that the a priori learning method has without it. It just could not create any rules with Prince, just even with the most lowest of standards. Sorry, Prince. You didn't lead to information about how users listen to other users. Prince is good. Very talented guy. I'm so interested in this PIN with the star though, because BE. See that? There's no BER in this. How is it searching for that? Do we have a subset now of a? No, we're just using the main thing. It's gonna lose it when I say Brian. That's what I thought would happen. BRIA. So it should logically do it with S, right? No. Why is it? Oh wait, but the A works, and then star. I don't know. I never remember how stars work. I don't know. Maybe people who only listen to Prince only listen to Prince. I like that right there, Jordan. I should stop playing around with the stars and the special characters. I should understand better how they work. I always want to understand using stars to search in our AIN or PIN. Let me look at this. No. It's hard to search for stuff like this. Package A rules. It's special characters, and those are always like string searches and stuff can be pretty tricky. I'm not going to talk about doing star. I'm looking at the A rules package notation. No, they're not talking about using it. No, it's not mentioned. That's a bummer. I don't know. I finally learned how PIN works, but now I want to learn how to use a star. But I think that's got it. I'm going to get some lunch probably. Are you guys feeling pretty good about the assignment now? Got most of the assignment done. We did a good bit of it here today. We talked through multiple ways to solve the problem. A lot of times it's just taking this and working through it. Just kind of, make sure to start early. I think I've said that enough. Like start early on these. If you get stuck on something, just ask. But I think that's got it. Everyone feeling pretty good? We're going to hop back on here at 4 p.m. today. You're welcome, Jordan. Thank you, guys. It's just practice. You got to know how to interpret these things. You just got to practice. Remember, we found out to start class that people who watch class, let's go back to that. Let's end with what we started because where is it? I don't see it. Oh my gosh, this is how much stuff I have open. So my brain's broken. So what did we notice? We noticed that between two people who watch the class who differ by an hour. So if you stayed for office hours, you might get about 2/3 of a point higher. Not saying you will, but we'd expect you to get 2.2/3 higher. Sure, ask away, Adam. And then we'd expect your midterm grade to be a half a point higher, or about 2 points higher. If you stayed for office hours, we'd expect your grade to be about a half, 1.5, about a point higher almost, just between two people. So the person who stays longer, we would expect their grade to be a point higher, almost, for if you stay for the office hours. So who knows? How do you find the item frequency of one thing or the other, like Prince or Madonna? So we should be able to go into here. And if you want to find the people who listen to Prince and Madonna, do you want Prince or Madonna or Prince and Madonna? So if you want, and here we'll hop back to that. Did I call it homework 7? Because I think I have some code right here to do it. So we should be able to do, I think you can do it with this code. It's in the notes, but I'm going to try to do it this. I think we can do this. Let's try this. I don't want to do that. Here we go. Oh, I know how to do it. Okay. It's subset, and then you go to music. What are you subsetting? And then here's the confusing part that I always forget, is items, and then you do %%, and you do Prince, and you have to put this in a vector right here, because these are the people who listen to Prince and Madonna. We're going to, whoops, R is trying to be helpful, but it's not helping. So these are the people who listen to Prince and Madonna. And that's the people who listen to Prince, or Madonna, excuse me. These are the people who listen to Prince and Madonna. If you remember, Prince didn't have that many people who listened to him. Sorry, Prince. But Prince had only like 17 people who listened to him. But all of these people right here, like if we were to inspect this, if we go to inspect of this subset right here, these people have to have in their thing Prince, and they have to have Madonna. So now the people must have Prince. Here's Prince. And they must have Madonna. Does that make sense right there? So this code right now is finding people who have Prince and Madonna. This code would find people who only have Prince and Madonna, which, oh, wait. Oh, it's you can have either of those. So this person only has Madonna. So that's what the OIN does. They only have those items. I think they can have both of them, but you can only have these items. Okay, so OIN isn't only that item. Like if we do only Madonna, we'll still get 1. So there we go. OIN, I just never use OIN. Yeah, so if you want only these items are possible in the cart, it's OIN. If you want all of these items have to be in the cart, it's AIN. If you want any of these items can be in the cart, so they can have more things now. Like they can have a bunch of artists. That's going to be the most comprehensive search. And then PIN would be a partial match on any of these, which I think, and you can only use one for PIN. So PIN will do a partial search. So if you don't know how to spell Madonna, you could go here and spell that, and then you'll get the carts that pretty much have Madonna. And this would be the same as pretty much doing AIN Madonna. I think it was 104. And yeah, because I did a partial match on the name Madonna. So PIN only works with one item, and you're doing a partial match. So when I was doing this a few days ago, I was doing things with like Ben Folds, and I don't know how to do a caps difference on PIN, but these carts right here now have some form of Ben F, and it's going to be like Ben Folds and Ben Folds 5, which doesn't shock me that Ben Folds and Ben Folds 5 are in someone's cart. But as long as one of those, like Ben Folds shows up or Ben Folds 5 shows up, it does a partial match on it. So you can do, like, you could do J, but you'll get more than just Jay-Z. You'll get anyone with J in their name. So you can see right here, we might get Jay-Z, but that gentleman right there. So it does a partial match on it, as long as that's in part of some item. So when you're doing like grocery store stuff, you could search for people who have milk. And I wish PIN didn't have caps sensitive, which I'm wondering about right now. PIN with caps sensitivity. Oh, here it is. Someone might have searched it. Case sensitive is called. That's their terminology. I don't know if anyone says how to do it with. You know what you could do? There's a way to fix this. I wonder if I could do this. To lower music. Will this work? No. Music is transactional data. That's a bummer. I don't know. Working with transactional data is so different. And let me see here. We'll look at one more thing. Convert transactional data in R to lowercase. Because if I convert it all to lower, transforming strings, I know how to do strings. It's too upper, too lower. That's what I'm trying to use. Well, it's not going to do it here. Because inspect, you can't put something on the outside of inspect. It won't do it, as far as I know. You see, it's not to lower. And it won't let me do the to lower on this. Just clicking all the wrong buttons today. Yeah. Because it's saying it's for a certain class. No method. Taking a look. Labels. It's transactional data. Can I do it like this? No, it doesn't like that. Dealing with transactional data in R. Data frames and transactions. Read transactions, inspect transactions. Really? That's all this page has on it. So, like, let me try this. Let me go back to the... You know what I could do? I have an idea. We got an idea. We can fix this. It's going to go all the way back to here. Read transactions, CSV. So what we might be able to do is we do the following. We take the CSV and we take the CSV and we call this work read CSV, and we can do this to lower. I wonder if this will work. There we go. Oof, didn't like that, really. Read CSV. Maybe it just doesn't like it. Read table? Shouldn't nest my commands yet. Ooh, we did something. We did something. We did something. Does anyone say anything, John? Yeah, I know, right? Jordan, I'm with you 100%. That's what I'm like. Let's see if this will work. Oof, did not like that. Did not like that. Okay. Let's go write.csv work, comma, work, comma, new, oh my gosh, new data.csv. Okay, hopefully I didn't overwrite something I already got in here. Cool. What have I done? This is looking all crazy like, oh my gosh. Wait, there's a, oh no. I noticed it looked all crazy. That was bad. Okay, let's try this. We got warnings. Okay. We might be fine right now. We might be fine. Oh, invalid graphic states. I don't know. I probably broke it. I didn't like me converting that. It's just crashing. Oh no, what have it done? Well, I think it's time to go. Oh my gosh. That was a bad idea. That was a bad idea. Well, that's what happens when we try to change things. Yeah, I'm shocked we can't just change it to lower because now let's load that back in. Okay, it's mad about the graphics. Maybe it's just completely broken. Item frequency, music. Okay, good, it's working again. So what I was trying to do was, I was trying to, let me look at the read table. Let me go sep. We'll just grab these arguments. I'm very interested in getting this to work. Indeed, launch, but it's probably the problem. Unexpected comma. Yeah, it's a comma right there. That ends it. Cool. Format basket. Yeah, I didn't think that was needed. That's for transaction data. Error in scan line is working here still. That's oof. No, Yeah, my thing's like can't handle it. Yeah, you see just the way it's formatted. It just doesn't like it. It has to be formatted the way 4 p.m. off stars. Yeah, and I should go here in a moment. The way the whole thing of taking it all and making it to lower. But I would think that I could do read CSV on it. Like I just want to get this working. Okay, you see that's doing it. And this is error. And then if I take a look at it, yeah, and this is like, oof, this is not good. Yeah, it's chewing up memory right now. Which I think we had R being bad last time, and now I've like replicated the issue. I think these are very, very large data frames. Yeah, R is just being horrendous right now. I think I've got a bunch of very, very large files in here right now. And so let me clear the global environment before I start really crashing. Oh no, R is being ridiculous. Why? Okay, we're going to restart R. Don't save, because we did something very bad. And so I literally created the problems I was having last time where R was being, you notice it was so good today. I got it fixed up, got everything working great. Good. It's doing a little choppy there. There we go. Good. Okay. So yeah, I was flooding R's memory. I was having it print to the screen thousands of things, and R was just like, I can't handle this. Yeah, transactional data are like just a really odd thing to work with, and the way they look, I'll show you again from the notes how they look. They have a certain structure to them. They're just, everything is in rows. So when you look at transactional data, they look a certain way. They have to be input in a certain way. And there it is. So this is the way transactional data looks as you have it in as a CSV. It's just the first line is the first card of stuff. And the second line is the second card of stuff. And every single thing right here in this is going to be separated out by commas, and each line of data is its own thing. So it's a specific structure you have to have. And if you don't have this structure, it doesn't do it. So then when you read it reads it in as the carts. So you have to use the read.transactions, but then this object it creates is handled through like the A rules package. And this is like created like a specific way for this. So if you don't do this, it breaks it. But that's got it. I'm going to go eat some lunch, answer some emails. I'll see you back here at 4. See you then. Bye, everybody. Bye.